Hello and welcome, I'm your Code Monkey, and here is a free, complete course on making a really nice multiplayer game. If you have lots of multiplayer game ideas but don't know where to start, then this course is for you. Here we are going to build a simple game, but also one that involves using lots of multiplayer tools. So by learning how to build this game, you will by the end have the knowledge required to be able to build just about any multiplayer game in any genre you can think of. We're going to use Unity's official multiplayer solution called Netcode for Game Objects. This is a very robust toolset, and once we understand how it works, it's actually surprisingly easy. This is a completely free course video, but it has the same level of quality as my paid courses or my Steam games. You can download the project files to follow along or inspect the final game. You can even play the final game right now directly from Steam. This course is a follow-up to my free Singleplayer course. In that one, we built this project completely from scratch. Every line of code was written on screen during that course. And now we're going to pick up from where we left off and implement multiplayer. Also, just like the Singleplayer course, one very important thing is how everything we're going to do here, it's all going to be focused on writing good, easy to understand, clean code. The code that we're going to write here is production quality code. This is not a throwaway demo. The quality of the code and the structure of the game that we're going to build is on the same level of quality as my own Steam games. As you can see from the video link, this is indeed one complete, very thorough course. So don't try to watch this whole thing in one sitting. Take your time, take it slow, and just focus on learning. There are chapters for every lecture in the video. Here's a quick overview of the entire course, all the steps that we're going to take to reach the final polished game. So first we will begin by taking a brief look at the starting game. This is what was made completely from scratch in the Singleplayer course. So here we're just going to do a quick overview as a refresher to see how all the code is set up. Then we're going to begin by installing Netcode for Game Objects. This is Unity's official multiplayer solution. We're going to install the package and do the basic setup with all of the settings and spawn a player object. After that, we're going to begin by synchronizing the player movement. And also at this point, we're going to talk about one extremely important thing in multiplayer games, which is Server Authoritative versus Client Authoritative. With the movement synced, we are then going to synchronize the animations. This one is pretty simple to do thanks to the built-in components. Next, we're going to synchronize our first proper gameplay logic. We're going to begin with the delivery manager. So we're going to synchronize how the recipes are spawned, make sure only the server spawns them and all the clients see the same list, and also synchronize delivering the recipes either correctly or incorrectly. After that is just a quick lecture to fix the selected counter visual. This is something that showcases one of the many differences between making single-player games and multiplayer games. We need to think in different ways, especially because in multiplayer we no longer have just a single player object. Then we're going to synchronize picking up objects. This involves learning how to spawn objects on the network so that all of the players can see it. After learning how to spawn them, we're going to synchronize the kitchen object parent so that multiple players can hold objects and everything is correctly synchronized across the network. Then we're going to synchronize the plates counter, make it so that only the server spawns plates. Then for the trash counter, this one involves learning how to destroy network objects. After that is synchronizing the cutting counter, so this one will involve thinking about what parts we need to synchronize and what logic can be just local. Then for the stove counter, for this one instead of using RPCs, we're actually going to use a network variable. The server will keep track of the stove state and sync it to the clients. Next is synchronizing the logic for adding ingredients onto the plates. After that, for an optional design question, we're going to implement some player collisions. Then we're going to synchronize the complete game state, so waiting for all of the players to be ready before starting the game, and also synchronize the game timer and game over. Next, we're going to learn how to deal with pausing, so do we allow it or not? In this case, we are going to allow it, and all of the other players must wait until everyone is unpaused. Then for something very important, which is how do we handle disconnects? How do we clean up all the objects so the game doesn't crash when a player leaves in the middle? Related to that are late joins, so how do we handle a player that joined after the game has already started, or should we even allow that? Then comes a really important and relatively complex lecture. In this one, we're going to handle the complete connection scene flow. How we begin in the main menu in single player, then we have an online lobby. After that, we create the netcode connection and go into the character select scene. Then when all the players are ready, we then go into the main game scene. And after that, just play the game as normal. This is one of the most important lectures in this entire course. After that, with the connection flow working, we're going to build out a nice character select scene. This is one of the main things that I saw people ask about in my netcode video, so we're going to make a nice scene where the players can join and customize their character. Next, we're going to build the game lobby, so the player can create a lobby or join one. Then we're going to implement relay in order to allow our players to connect to one another easily without having to open ports. Next, we're going to talk about some more Unity multiplayer tools, dedicated servers with game server hosting, Matchmaker and Vivox. After that, we're going to talk a bit about all of the tools at your disposal to test your multiplayer games. Then, just before the end, we're also going to add a really important option. We want the game to work in both multiplayer and single player. So we're going to make it so you can basically bypass all of the multiplayer connections and play in an offline single player mode. And with that, everything is done, so we're going to inspect the final game and have some fun. So as you can see, you will learn about a ton of topics by following this course. By the end, you will have the knowledge required to build just about any multiplayer game. Now, if you're new to the channel, then welcome, and here's a bit about me and my credentials, or why you should listen to what I have to teach. My name is Hugo, and I've been running this CodeMonkey YouTube channel for 5 years now. In total, almost 700 videos on all kinds of topics, including tons of tutorials, sharing my knowledge to help you on your own game dev journey. I'm also a professional indie game developer, making games for over 10 years with 8 successful games published on Steam, so what I'm teaching here is based on a lot of years of experience making a lot of games. Just like with my paid courses, I'm always in the comments answering your questions every single day, so if you get stuck on a particular point or need extra clarification on something, go ahead, post a comment and I'll do my best to help. Do make sure to include a timestamp of what you're referring to. I will also be updating the pinned comment with any frequently asked questions that I see, so actually right now, pause the video and scroll down a bit to look at that comment. Since on YouTube I cannot update a video after it's published, I will be updating that comment over the next months and years. And I also made a dedicated course on my website. In there you can download the complete project files for every single lecture, so if you get stuck at any point you can download the code for that lecture and compare it with your own. There's also links to all of the reference videos for each lecture, and I won't be including the frequently asked questions. If you have a common question, then chances are I've already answered it in that page, so it's faster to just check that page rather than wait for me to reply to your comment. So definitely do keep that page open in a second tab as you follow along each lecture. Now both this free course and the single player one took a ton of work to make, so I really hope you find both these courses helpful. Go ahead and hit the like button if it helps you. It's a small thing, but it generally does help this video on the YouTube algorithm. Making these courses was a ton of work, and by making it completely free means that it will obviously never make as much money as if I had just made this a paid course. I'm perfectly okay with that decision, with the hopes that by making it free it will reach and help many more people. I'm also a big believer that education should be free, so if you can't afford one of my paid courses, like if you're just a kid or if you're going through a rough time, I still want you to have access to high quality education so you can achieve your game dev dreams. One easy way it can help me for free is simply by liking this video, subscribing to the channel and just watching this video. That will hopefully help push the video on the YouTube algorithm and help it reach many more people. Another free way to support what I do is I'm currently working on my next Steam game called Total War Liberation. You can wishlist the game on Steam. Wishlists matter a lot for Steam visibility, so just by doing that you'll be helping me. And just in case you can't afford it and you find both these free courses useful, you can also support what I do in a few other ways. I added this exact same course on my website as a regular paid course. Although I want to be very clear, there's absolutely no difference between this free video and the paid course. There's absolutely nothing behind any kind of paywall. All the lectures are free, all the project files are free, everything is free, you don't have to pay anything if you can't afford it or you just don't want to. The paid version is essentially a donation. The only difference is this free YouTube video has regular YouTube ads, whereas the paid version on the website doesn't have any ads. That's it. So the only reason why I made that paid version is just in case some of you can afford it and you want to support what I do, but again, only do that if you can afford it. If you can't, then that's perfectly fine. I hope you'll learn a ton from watching and following this free course. Beyond that, if you follow this course and you enjoy my teaching style, perhaps look into my other ones. If you like this video, then I think you will really like my turn-based strategy course. That is the perfect course to follow up on this one. It dives even deeper into some of the concepts used here, and it will help you make the jump from beginner to advanced. And since you're interested in Unity, then I think my Ultimate Unity Overview course would also be very useful to you. Each lecture in that course is focused on teaching one Unity tool or feature. There's already over 50 lectures, including plenty of small but very important things that just wouldn't work as a regular YouTube video. If you're interested in visual scripting, I have a course on making 3 unique games entirely with visual scripting and no code at all. Or if you prefer, you can learn how to make a nice Builder Defender game. So if you enjoy my teaching style in these free courses, then check out my paid ones. Then of course YouTube has channel memberships and super thanks, so you can use those if you want. I also have my Patreon if you prefer that. And in a lot of my videos I have affiliate links for the Unity Asset Store or Humble Bundle. If you ever pick up anything from those, I get a nice commission. And I also have some of my own assets on the Unity Asset Store. So if you enjoy these free courses and you want to support what I do, there's plenty of ways. But again, don't feel obligated. If you can't afford it or you just don't want to, then that's perfectly fine. I hope you'll learn a ton from watching and following this free course. Alright, so that's enough talk of that for now. Before we begin building the game, let's inspect the final game that we're going to build. So let's see that in the next lecture. Hello and welcome, I'm your CodeMonkey, In this lecture, we're going to take a look at the final game that we're going to build in this multiplayer course. Okay, so here's the final game that we're going to build in this course, and right away on the main menu you see a very important feature. The goal is indeed to make a multiplayer game, but thanks to how Netcode works, it actually makes it really easy to support both multiplayer and single player. So here we have buttons for both. We can go into single player, and if there you go, the game starts playing, so exactly the same as we made in the single player course. So everything works perfectly offline, everything works great, so we can move, act, and everything works great. So it works in single player. Or of course, we can go into multiplayer, and as soon as we do, we go over here into a lobby scene. This is where we can view all the lobbies that other players have created. Right now the game isn't out, so there are no lobbies here, but if there were, they would appear on this list. Since I'm the first player, I can go ahead and create a lobby. I can give it a name, so my awesome game lobby. I can make it either private or public. So if I make it public, as soon as I click, yep, there you go, it creates a lobby, and this one goes into the character select scene. And over here I have a bunch more clients. So on these, let's go ahead into multiplayer, they'll load up the lobby scene, and yep, all of them can see the same lobby. So I can join a lobby either by clicking on the lobby name directly. There you go, joining lobby, connecting, and yep, this client has now joined the lobby. Alternatively, I can press quick join, and Unity will automatically try to find a valid lobby to join. And also, as we saw, the lobby can either be public or private. If we had made it private, then the lobby would generate this kind of code. So you could take this code, give this code to a friend, they would put that code over here on the input box, they would join by code, and they would end up joining the same lobby. Also, one very important thing actually happened in the background without the player even knowing, that is the Unity relay. As a host, I did not have to handle any port forwarding or deal with any firewall. When I created the lobby, in the background the game actually created the relay allocation and connected through there. Same thing for all of the other clients. They all automatically handled getting the relay code from the lobby host and connected perfectly. So like this, the game supports connecting any two players anywhere in the world without any issues with ports or firewalls. Okay, so then here we are all on the nice character select scene. We can look at the players and choose a color. Also over here on the host has extra buttons on top of each player in order to kick that player. Then for each we can select any kind of color we want for our character. So let's say instead of yellow I want to be purple. And there you go, I changed the color, and yep, look how all of those synchronize correctly. Then the server also does some validation to ensure two players don't end up with the same color. So if I try to select purple, nope, does not work. So each player can really select their color. And once they're all happy with their colors, there's a ready button, so each player can mark themselves as ready, and ready synchronize, but the game is not starting just yet. Instead, it must have all of the players ready in order for the game to start, so let's set ready on this one, and finally on this one. And once they're all ready, yep, the server automatically loads the game scene, and all the other clients load the same scene. And now here, just like in the single player game, we have our controls, so each player can take their time to read the rules before moving on. Then when they do, let's interact, and yep, the server is currently waiting for the players, so all the players must go through the controls before the game actually begins. So let's go ahead, interact on all of them, and when I do on the last one, yep, there you go, it goes into the countdown, it counts down the timer, and yep, there you go, the game is now playing. Alright, great, and as you notice, the countdown, all of that was perfectly synchronized, and now here, everything else is exactly like we built in the single player course, except obviously the big difference is everything is synchronized. So all the recipes over here on the side, all the players are receiving the same recipes. I can move around on either player, and yep, all of them are perfectly synchronized. Then I can go ahead, pick up objects, and yep, all of them, they get the object spawning, all of them get the object parent changing, all of that works perfectly. Then I can place the objects anywhere, and yep, it works, so I can place it on the cutting counter. I can do the Alt interact action, and yep, all of them see the object is being cut, and yep, all of them see the cheese slices. Then I can also go into the stove, pick it up, drop it, and yep, the timer for the stove, that one's actually being synchronized by the server. So there it is, and if I leave it to burn, yep, all of them are giving the warning, and if I leave it, yep, there you go, that one is charred, and it's charred on every single client. So now I can trash it, so this involves destroying a network object. Now let's do a proper one, so let's go ahead, that one sets it on cook, then this one, let's say this one picks up a plate, tries to pick up that one, and goes and grabs that one. Then this client down here, go ahead, pick up a bread, drop it, and now we can go ahead and deliver, and if there you go, deliver success, synced on all of the other ones. And of course, the game timer itself is also being synchronized, and as soon as that timer ends up, if there you go, they all get a nice game over scene. Alright, awesome! So this is the complete multiplayer game. We're going to take our single player game and synchronize all of this game logic to make it all multiplayer. And we're also going to implement the tools for lobby and relay to make our game easy to play for any player anywhere. Okay, so now that we've seen the final goal, let's go to the next lecture and see what you should know. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to see what you need to know in order to be able to follow everything in this multiplayer course. Okay, so for this course, like I mentioned, it's a follow-up to my Singleplayer course. The starting project files here are exactly the project files from the last lecture on that course. So I will assume you've watched that and you are familiar with that code base and how the project is structured. In the next lecture, I will do a brief overview of the code base. So if you've seen the course a few weeks ago, then just watching that lecture should be enough to quickly remember how everything works. In this specific multiplayer course, we are going to be using Unity's Netcode for game objects. This is their official multiplayer toolset. I've covered it in a general video previously. And like I said in the Singleplayer course, here I will mostly be using it to achieve our goal with this game rather than covering every part of the toolset itself. So first, go watch that video to learn about the toolset in general. Here I will assume you know the general idea for how it works, meaning what is a network manager, what is a host and a client, what are RPCs and NetworkVariables. You don't need to memorize that video, just watch it once just to get an idea for how it works in general. Then here, as we use each part of the toolset, I will explain what it does. Also, I would highly encourage you to follow the course website as you're following along with these lectures. I saw a bunch of comments on the Singleplayer course asking the same questions over and over again. Those people could have gotten those answers much faster if they had just read the website FAQs rather than waiting for me to reply, so definitely keep that tab open and read through it as you go through each lecture. But at the same time, I answer comments every single day, so any questions you have, post them here and I'll do my best to help. Just like the Singleplayer course, this one is split into lectures. They are all as chapters in the video so you can navigate around. And once again, let me remind you that you are not expected to follow this course in one sitting. Take your time, focus on actually learning. Remember, that's the only goal. You're not competing with anyone, you're just gaining knowledge for yourself. So take as much time as you need, rewatch some lectures if you feel you didn't fully get it, go watch the related videos, read the frequently asked questions, or just ask a comment. Mainly, take your time and just focus on learning. Okay, so all of that to say that you should know the contents of the Singleplayer course and the Netcode for Game Objects video. As long as you've seen those two, you should be able to follow everything here. And now, before we begin, let's take a quick look at the starting Singleplayer project and how it's set up, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to take a look at a quick overview of the code and the game that we made in the Singleplayer course. Okay, so here we are in the game built from scratch on that Singleplayer course. We start off in a super simple main menu with a bunch of buttons, then we can go into play, and right away it loads the game scene, and here we can see a bunch of basic controls. It's telling us the basic game rules, the controls, and asking for interact to continue. So now as I press the interact button, yep, the game starts a countdown, and with that I can now move around. Then on the left side I can see a bunch of recipes being generated, so I can approach any counter and interact with it. For example, there's a container counter from where I can pick up some objects. When I pick up, the object hovers in front of the player. Then over here is a clear counter, so I can place and drop some objects. Now over here is a cutting counter, so I can place down some objects, and with the alternate interaction, I can start to cut them. After cutting a bunch of slices, I can cut the entire object. When that happens, this cheese block became cheese slices. Then for the other one is over here the stove. If I place some uncooked meat on the stove, a timer starts counting up. That timer is the meat cooking, so as it goes, yep, there you go, the meat is cooked, but the timer keeps going, so if I don't take it out, then it suddenly becomes burned. So yep, there you go, the meat is charred. So down here, there's a counter to destroy it, so let's destroy it, and let's cook some more meat, and now let's pick it up correctly. So for picking up, there's also a plate, and when carrying a plate, we can pick up ingredients onto the plate, so there you go, pick up meat, pick up some cheese, and let's also drop some bread on there. So we have a complete recipe, so this is the cheeseburger that the clients are requesting, so let's go ahead and drop it, and if there you go, we have a successful delivery. Now finally, the game itself has a game timer, and when the game timer elapses, yep, here we have a nice game over screen. Alright, awesome! So this is the game that we built in the Singleplayer course. Now let's see the main concepts and how the code works. The core of it is the kitchen object class. This is the class that represents a kitchen object, like for example some cheese or tomato. Then for the type itself, we have defined a kitchen object SO, a scriptable object, which holds a prefab reference and a bunch more data. For the counters, they all extend this base counter class. This class has a bunch of logic, and importantly, it over here has an interact function. This one is marked as virtual, so all of the other different counters, all of them extend this base class, and they override this function. For example, here on the container counter, on the interact, it checks if the player is carrying anything. If not, if the player isn't carrying anything, then it just spawns the object. We also wrote some clean code, so we used events all over the place in order to separate the logic from the visuals. So in this case, this event is what triggers the animation on the container counter. Now over here, this one spawns a kitchen object and gives it to the player, so the player in here is a kitchen object parent. Importantly, each kitchen object can only have one parent, and then each kitchen object parent, which is defined as an interface, each of these can only have one kitchen object. Basically, the interaction between kitchen objects, parents, counters, and players, all of that is really most of how the game works. Beyond that, here we have the delivery manager. This is a script that handles generating recipes and keeping a list of all of the waiting recipes. For the recipes themselves, they are also defined in a recipe SO. This is a scriptable object just holding a list of kitchen object SO for all the ingredients. The delivery counter simply calls a deliver recipe function, passes in the plate, and then over here we do some validation to check if it is the correct recipe. And if so, then once again we have some nice events, which then have the visuals hooked onto it. Another important script is the kitchen game manager. This is the general script that handles most of the global game logic. Importantly, it handles the state of the game. So waiting to start, doing the countdown, playing the game, or game over. And that's really it for how the project and the codebase is set up. It's a relatively simple game, so hopefully this quick refresher helped you remember how all of it works. Finally, before we begin, let me just quickly talk about the two main options you have with regards to making a multiplayer game. One option is to do just like I ended up doing with these two free courses. First, make your game in single player and then convert it to multiplayer. That's one option, and the other option is to get the multiplayer working right from the start. Both are perfectly valid options. Which one you go with really depends on the game you're making, specifically with how complex it is. For very simple games, this approach works great. First make it entirely in single player and then convert it to multiplayer. But if multiplayer is a very core part of your game, then implementing it from the very start is likely the best. And of course, there's a third option where it's really a mix. For example, if I were making this game all by myself instead of making these two courses, if it was just me making this game in multiplayer, I would end up with a mix of both approaches. I would first get the basics working in single player, like just the character moving, interacting with the counter and pick up something. Then, before I went further, I would synchronize just that part in multiplayer. After that, I would build one mechanic in single player, then synchronize it, and so on. So you have lots of options for how you can build your multiplayer games. Okay, so hopefully by now you have a good knowledge of the starting codebase and how all the elements and systems are connected. With that knowledge, now let's begin building our multiplayer game. We're going to start off by installing the Netcode for Game Objects package, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to begin making our game. We're going to install Netcode for Game Objects, which is Unity's official multiplayer solution, and we're going to set up a basic scene with a spawn player for a host and client. Alright, so here I have the project. This is where we left off on the single player free course, so everything here in this project was built during that course from scratch. Again, definitely go watch that if you haven't seen it. It will be quite tricky to follow this multiplayer course if you're not familiar with the codebase. You can download the starting project files from the course website. If you follow the course yourself and you built your own project, then perhaps you can start from there. Although, depending on how much you went off script from the course code, perhaps it might be best to start from the exact same project files that I have here, just to avoid any confusion. The only difference is I updated my Unity version to the latest version as the time of this recording, which is 22.2.7. Like I said in the single player portion, make sure you're using the same version as me. The last number, the 0.7 over here, doesn't matter, but make sure you're using 22.2, or if you're watching a few months in the future, then you can use the 22 LTS. But if you're watching this many years in the future and there's version 23 or later, then still stick with the 22 LTS. Okay, so let's begin making our multiplayer game. Now for making this multiplayer course, I will be using Unity's official multiplayer solution called Netcode for Game Objects. Here I'm going to assume that you've watched my dedicated Netcode for Game Objects video. So I will assume that you know what is a network manager, what is Unity transport, what is a network object, and so on. You don't need to memorize that video. I will still do a brief description, introduction of the components as we use them, but I will assume that you've seen that video and have a general understanding for how the tool stack works. So let's begin by installing the package. Let's go into Window, the Package Manager. Then up here, let's go into the Unity registry and let's make sure we are on all. Then just scroll down, and down here we can find the Netcode for Game Objects. And as of the time of this recording, the latest version is 1.2.0. So we want to install this. But again, like I mentioned with the Unity version, here let me say the same thing. If you're watching this a long time in the future, I would still highly recommend you use this version, 1.2.0, and not whatever is the latest version. The reason for that is because I cannot see the future, so I don't know what changes future versions will bring. For the most part, they will probably be very minor, but even so, if just a function changes name, that could be a breaking change. So I would highly encourage you to follow this course using this exact same version just to avoid any confusion. Then afterwards, after following this entire course, you can go and look in the Netcode package and read the changelog to see what changes have had it since. Like I mentioned in the single player course, don't worry about using a quote-unquote older version. All of the knowledge you will gain from this course will still help you many years in the future, even when Netcode for Game Objects is on a different version. For example, right now we can see the changelog for the developed branch, which is what they're currently working on. And over here we can read that changelog. And we can see, for example, the only significant difference that I can see is really over here the network prefabs. Apparently in this feature version, instead of being on the network manager, it will be on a separate scriptable object. So that's the kind of very minor thing that changes in the versions. But despite being very minor, if you're trying to follow this course with a different version, it can still be quite confusing. And as usual, I will be updating the pinned comment and the course page to reflect any important updates. So if you're watching this in the future and there's a different version, still make sure to install this one. And the way you do it is, instead of using this install button here, let's click on the plus icon on the package manager and let's add a package by name. Then let's type the exact name that we see there. So com.unity.netcode.gameObjects. And let's make sure we don't have any typos, so that's the exact same name. And then over here for the version, let's go 1.2.0. Okay, so let's go ahead, click on add. And there you go, it's installing the correct version. And yep, everything was installed. So we have Netcode 1.2.0, and on dependencies, we can see we also have the NT Transport 1.3.1. Okay, so with the packages installed, let's begin using it. So let's close this, and let's begin working on the game scene. So let's go inside of that. Now, the first thing that we need is a network manager. So let's create a new empty game object for the network manager. As usual, let's reset the transform, keep things nice and clean. And let's add a component, and let's add the network manager. Okay, so this is the main component that Netcode for Game Objects uses. Then for the setup, down here the main thing is we need to select a transport. This is what will actually send the packets. So let's go ahead and select the NT transport. And that's it, it had this component down here with a whole bunch of fields. For now we don't need to touch any of this, so just leave them all on defaults. Importantly, make sure that over here the connection data, make sure for the address we have 127.0.0.1. This one is the local host, so we can develop and test the game in our own machine. Now, if just with this, if we hit on play, right now nothing really happens because we're still not synchronizing anything, so let's do that. First thing is over here on Network Manager, we have a field for a player prefab. This is what gets instantiated automatically when a player connects. So the way we built our game is over here on the scene view, we've got our player game object. This one is just placed in the scene. In single player, we only had one, so we had no need to make this a prefab, but for now we do need it to be a prefab. So let's make it, let's just drag it over onto our prefabs folder. There it is, there's the player prefab, and let's delete the one from the scene. Okay, so far so good. Now we can go into the network manager and just drag the player and drag it in there. Okay, we have assigned the player prefab, but just like this, it won't actually do anything. That is because every object that exists on the network must have a network object component. So let's select the player prefab, and over here let's add a component, and let's search for the network object. Okay, that makes sure that this object can exist on the network. Now let's open up the player script. Here is our script. Again, all of this was built completely from scratch in the single player course, so I assume you are familiar with all of this code. And over here, to make this a network object, instead of extending mono behavior, instead of that, let's extend the network behavior. And this one, we can see that this one exists inside using unity.netcode. So let's add that, and yep, there you go. This one is now a network behavior. So just by doing this change, this script is already marked as a network script. And by the way, over here in the editor, if we didn't add the network object, so for example, if I remove this, and if now I click away and I select it, yep, there you go, now we've got a nice pop-up window telling us that we need a network object component. So if you ever make a network behavior and you forget to add a network object, if you do that, then you get this nice pop-up window, and you can either manually add it, just like we did, or you can automatically, so just click on yes, and yep, there you go, now the player does have a network object. Again, remember, it must have this component in order for this to exist on the network. Okay, so we have the player, we have a network behavior, we have a network object, and on the network manager, we have it set as the player prefab. So like this, the network manager should automatically instantiate the player as soon as the player connects. So if we test this, and nope, we have a ton of errors right away. Basically, what we have here is the first of many errors that we're going to see that showcase the difference between making a game in single player and multiplayer. This specific error is over here on the select counter visual. Over here, we are accessing the player instance. Now, in our single player game, the player was added onto the scene by default, So it was there right as soon as the scene was loaded, which means that the player instance reference was already set. But here in multiplayer, the player is really only created when a connection is established, so as soon as the game starts running, there is still no player just yet, so this instance is going to be set to null. Again, remember how making multiplayer games requires a bit of a different mindset. This is just the first of many examples that showcase why that is so important. So over here, for now, let's just comment out the logic that uses this instance. So let's go ahead, change this and save. And we can go over here onto the player script, and we can find the other references. So using Visual Studio, I can right-click and find all of the references. And I can see that there's just 2 more over there on the sound manager. So let's go onto this line. And over here, let's comment this out. And down here, we've got another player instance. And let's also comment this out. Then same thing over here on the player itself. Let's comment out this one just like this. Basically, in multiplayer, we aren't going to have just a single instance of a player. There is no singleton since by definition we're going to have multiple players. However, we will have just one local player, so this logic will still be useful in a little bit, so that is why we are commenting instead of just deleting it. But then down here on the awake, we've got to test if the instance is already set. If so, we have more than one player. Again, that's a mistake in single player, but in multiplayer this is perfectly natural. So let's cut these lines, and then on this one just comment it. Okay, so that should fix all of the instance errors. Let's try playing again. And okay, so far so good, we have no errors. Then over here on the network manager, when the game is running, we can see these 3 buttons. We can start as a host, server, or as a client. Again, I covered them in detail in the Netcode video. Server is just a server, the client is just a client, and the host acts as both a server and a client. So for our first player, let's make it a host. So if I click on this, and yep, we still have yet another error. Let's see where this one is. And yep, it's right here, it's on the game input reference. Again, this is yet another thing related to the different setup in single player versus multiplayer. In single player, the player was placed on the scene, which allowed us to directly drag the reference to the game input. But when we made the player into a prefab, like this, on this prefab, we can no longer drag a scene reference. The reason is because this prefab can be spawned anywhere on any scene, so you cannot drag scene references onto a prefab. But later on in the course, over here for the game input, we also made it use the singleton pattern. So over here on the player, we can just modify that. So for the game input, instead of having a field, let's go into the game input, let's access the static instance, just like this, on all of these references. So wherever we have that one, replace it, and down here, replace it. Okay, we have fixed another error, so let's test again. Also, by the way, if you don't see the network manager game object, that one isn't over here inside your scene, it is actually inside the don't destroy on load scene. So now over here we have our buttons, let's start as a host, and yep, now it works, we have no more errors. Okay, so far so good. Now, using the inspector buttons obviously isn't very useful. We cannot access these buttons from the game view itself, which means we can't really click on it if we make a second build. So let's make some simple in-game buttons. On the hierarchy, let's go inside the canvas, and inside let's create an empty game object. Call this the testing netcode UI. Then let's make it stretch to occupy everything, so put 0, 0 on everything. Now inside, let's make a new UI image. Call this the background. Let's make this one in full black, and once again, stretch it to occupy everything, and put them all on 0. Okay. Then let's make a button, so let's right-click, create a new UI button. Call this the start host button, and inside for the text, let's say host. Let's change the visual a little bit, so let's put the text in white, let's put it in bold, a tiny bit bigger, and let's increase the size of the button as well. So something like this, and let's put it on a dark gray and put it on an X of 0. Okay, so that's our basic host button. Let's lift it up a little bit, then duplicate it, push it down here. This one is going to be the start client button, and inside let's just say client. Okay, we have our 2 simple testing buttons. Let's just make sure they are on top of everything else so we can click on them. Remember how the sorting order in the UI works. It is all based on the order in the hierarchy. So in order to make this one always on top, drag it to the bottom of the canvas hierarchy. Okay, now let's make a script to run this. So let's go into our scripts, into our UI scripts. Let's create a brand new C# script for the testing netcode UI. Let's attach it to our object. And by the way, if you're following along, this specific Unity version has this strange bug where if you drag a component, it actually adds twice. If you're using a later Unity version, it probably won't have this bug. But if this is still the latest version by the time this video goes out, just go ahead and remove the second one. Okay, so let's open. Now over here, let's just add some simple references to our buttons. So as usual, let's make it a serialized field of type button for the start host button. And then we have another one for the start client button. Then over here in the editor, let's drag the references, so the host and the client, okay. And now let's add our click events. So let's go make an awake and go into the start host button. Let's add an on click. Let's add a listener. And for the listener, when we click on start host, let's go into the network manager. Let's access the class itself, which again is inside using unity.netcode. Then inside that one, there is a static singleton. And from there, we can then call the function start, in this case, start host. Okay, so this will start the host. Let's just do a debug.log so we can see. So we are starting a host. And then afterwards, we want to hide this testing window. So let's make a simple private void hide. And on hide, just set this game object to active as false. So that will hide it. So we post a message, start host, and then hide. And then same thing for the client. So on the start client button, on this one, start as a client and just call the different function. So start client. Okay, that's it. A very simple script. Make sure you drag the references, and now we're ready for testing with multiple builds. So let's go up here into File, and let's go into Build Settings. Now, importantly, for our single player game, we were starting from the main menu, but here, while we're developing our multiplayer game, we really don't want to have to go through the main menu every single time. So let's just drag the game scene on top, so that is the one that we start with. Then over here, select your target platform. For me, I'm going with Windows. And then for some other settings, let's go down here into Player Settings. This opens up the project settings and goes into the Player tab. And over here, let's go inside the Resolution and Presentation. Now, in order to make testing easier, let's make it with windowed instead of full screen. So put it on windowed. Then the size doesn't really matter. Let's just make sure we run it on background so the game keeps running even as we switch between the windows. And then down here, let's make it a resizable window. That way we can stretch and fit them in order to fit multiple windows on our screen. Okay, so these are the settings. Let's just close out of the project settings. And over here, let's go ahead and make a build. Just go ahead, choose a folder and build. Alright, so here is the build, so let's open it. And yep, here is the build running. Now in the editor, let's set on play as well. So we've got both of them. Now in the editor, let's click on host. And down here, let's click on client. And yep, both are connected and we can verify that. So on the editor, let's minimize this. And we can look in the game scene and over here see, yep, we do have indeed 2 player clones. Alright, awesome. Now of course, this is just a bare bones connection. So if I move this player, there you go, both players are moving. And obviously the movement isn't being synchronized. So we are going to need to fix this in the next lecture. But the important thing is that we have a nice network connection all fully established. This is the absolute basics, and basically all we need now is just to synchronize everything. Now before we end this lecture, let's just do some more small things. First of all, on the game state, right now the way we made our single player game is we have this controls window, then we go into a 3, 2, 1 countdown, and only then the game is actually active. Now this is great in terms of the final game, but it's a bit annoying while developing and testing the multiplayer game, so let's just modify the code to skip this part. Let's go over here onto the Kitchen Game Manager, and down here we have all of our various states. So we have that, we start off on waiting to start, and then when we get some input, we go into the countdown, which then counts down the countdown timer. So let's basically just make this start playing automatically. So let's go over here on start, and let's just run the code to automatically start it. So let's run this. Let's put a comment here so we remember why we made this. So just a debug trigger game to start automatically. Okay, and also same thing for the countdown timer. So up here for this one, instead of starting on 3 seconds, let's start on just 1 second. And then also important over here for the game playing timer max. For this one, let's make sure we leave enough time, so let's say something like 300. Basically, we don't want to trigger a game over while we're still busy doing some testing. Okay, so let's test. Here in the editor, I click on host, and there you go, the game starts playing right away. Okay, great. Now, for one more important thing, when testing our multiplayer game, we're going to need to read the logs. Now here in the editor, we can't just access the console and read it, but in the build, we don't really have this. So to solve that, there is one extremely useful asset that I like, which is called the Quantum Console. Although I should point out this step is optional, you don't need this asset to make multiplayer games, it just makes it a bit easier. So before I show the asset, let's see how you can read the logs without it. So over here I have both builds running, so on the editor I can read the console, but on the build I cannot. If you go onto the Unity documentation, here you can see the path for where all of the log files are. Now in this case we want the build logs, so that's not the editor related logs, so let's scroll down, and down here we see the player related logs. In this case I'm running on Windows, so this is the path that I want to find. So it's under user profile, app data, local, then the company name and the product name. Now for the company name and product name, for that you go into File, let's go into Build Settings, and let's go over here into the Player Settings. And over here on the Player tab, up here you see the company name and the product name. So make sure you write these before you actually make the build. And if you go to that path, you will see these logs. So if you go ahead and open this text file, yep, there you go. Here we do see the logs for the actual build. So over here on the build, I just started as a client, so it just logged the client message, and it is exactly what we see over here. Also, by the way, you can just keep this file open and just press F5 to refresh it. For example, if I exit out of the build, it is going to update the log. So if I exit this, and over here I press on F5, and there you go, it updates everything. So this is the manual way to read it. You just go to this file and refresh it. So that works, but having to have this file open all the time and having to refresh it is a bit annoying. So personally, I really like using Quantum Console, which easily adds a console that you can also see in the build. And in general, it's just a great asset all around, really useful for all kinds of testing. I made a fully detailed review on it if you want to learn about it. And there's also an affiliate link in the description if you want to get it. But again, this is completely optional. If you don't want to buy this asset, you can just keep that file open and hit refresh just to read the console. Now, since I do have that asset, I'm going to use it to make developing easier. So I'm going to go into Window, Package Manager. I'm going to go into the My Assets. Then just search for the Quantum Console. And yep, here I have the asset, so I'm just going to import it. I'm going to import everything. Then over here in the project files, inside the plugins folder, QFSW, Quantum Console, source, and over here is the prefabs, and yep, there are 2 prefabs. This game is made using URP, which is an SRP, so let's drag this one. There you go, there's the Quantum Console. Now I'm just going to resize this a little bit, so inside on the console rect, I'm just going to move this, make this a little bit thinner, okay, something like this. And that's it, there's nothing else we need to do. So now if we just go ahead, build and run, and yep, here is the console, which we can now easily read the editor logs for both the editor and the build. Okay, great. Now just one more tiny thing related to the setup. If we look in the network manager, over here there's something called the log level. You can put it on normal, error, nothing, or developer mode. Now normally I would put it on developer to get as much info as possible, but it seems that this version of NGO has a bit of a weird bug. During my testing, later on when we add some animations, it was constantly pushing a weird warning which was causing tons of issues. So because of that, over here I'm going to leave this on the normal log. Alright, so that's it. Over here we created the basic setup, we installed all of the packages that we need, and we set up the network manager so we have a player prefab that we can then instantiate. All of the basics are perfectly set up. Now all that's left is really just synchronizing the entire game. So let's begin doing that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to handle player movement. And as we're doing that, we're also going to talk about something extremely important, whether to make your multiplayer game server authoritative or client authoritative. Both methods are valid, I'm going to showcase both of them, and then it's up to you to decide which one best fits your game. Okay, so the basic setup is already working. We have the network manager set up. So over here with these 2 builds, I can start this one as a host, this one as a client, and yep, both of them are connected. So far so good. However, if now I move with some input, yep, both objects are both on the exact same position and they are both moving with the same input. And of course, the movement is all local, so nothing is being synchronized. So let's handle this. For the first problem, we just need to make one small change over here on the player script. Like we saw right now, the input is moving both players, but we don't want that. And the movement is down here. We have our update where we are handling the movement and interactions. Both players have this script, so both players are running this code, but we only want a player that is local to that build to run this code. And how we do that is very simple. On the network behavior, we have a bunch of nice properties. We can check out a bunch of is things. So we can check is client, is host, is local player, is owner, is server, and so on. And basically for this one, in this case, for checking if this player is the local player, we can check is owner. That is because the player game object will be owned by the player when that player joins and that object is spawned. So if we check is owner, this one is only going to be true for the local player. So we only want the local player to run this. So over here we can just check if this one is not the owner. If not, then we just return. So this one will only be true for the local player. So only the local player is going to run the movement and the interactions. Okay, that's it. That's the only change. Now if we test. So here are the 2 players. And if I move just this one up here, yep, it only moves 1. And down here, and yep, it only moves 1. Okay, great. However, of course, as I move it, the movement is still not being synchronized. The client down here still thinks that the host is over there on the spawn position. Same thing on the host, still thinks that the client is over there. So let's synchronize the movement. And we can do this using a super simple component. Let's go over here onto the player prefab, and we can just add the component, search for a network, and let's add the network transform. Basically, this will synchronize all of the transform data. We can even use these checkboxes here to help reduce the bandwidth by only synchronizing the things that can actually change. For example, in this game, the player only ever moves left, right, forward, and back. There's no jumping involved in this game, so there's no need to synchronize the Y position. For the rotation, we're only going to rotate on the Y, so there's no need to synchronize these two. And for the scale is never going to change, so we can also not synchronize these two. Okay, so this will synchronize the transform and only the things that actually matter. And this is where the question of server versus client auth comes in. The way this component works, this one is only server authoritative. So if we try like this, let me go back outside, save the changes, and make a build. So here are both builds, up here the host, down here the client. Now if I move on the host, yep, there you go, the host does move, and it does get synchronized over there on the client, so that's great, that looks like it does work. However, if now I go down here onto the client and I move, and nope, the client doesn't even move. I'm pressing the buttons, the animation is actually playing, so the input is being received, but nope, there is no movement. That is because that component, the network transform, that one is only server authoritative, meaning that only the server, which is also the host, only this one has authority to move this transform. If this local client down here tries to move it, then basically just snaps back to where the server says that object is. Like I said, I'm going to showcase both methods because both methods are valid. Let's begin by looking at the client auth method. And for this one, we are going to use a different component. We can go into this page, so onto the docs. You can just go into the docs themselves and go into the Netcode for game objects, then go under components and go into the network transform page. So on this one, if we scroll down here we can see a client network transform. This does exactly what we want. It allows for client authoritative gameplay. So we can either import the entire samples from Git, or just down here we have all the code. So let's just go ahead and copy all of this code. Then over here in the editor, let's just make a new C# script. Call this the client network transform. And then over here, just select all and paste the entire code. That's it. So here, basically all it does is it just extends the network transform and just does an override on is server authoritative and returns false. So this way, this one is no longer server auth and works as client auth. So now if we select the player prefab, and over here, let's replace the network transform for the other one, so the client network transform. And let's set the syncing on the same thing. Okay, that's the same setup, so we just changed the component. Now if we test this, so up here is the host, and as I move it, yep, it does get synchronized. And down here the client as I move it, and yep, now this one does get synchronized. So we can move both independently, and both of them are being synchronized. Alright, awesome! So this is how you can make your game client auth, meaning that the client has the authority to make changes on the server state. This has some pros and cons, which I'm going to talk about in a bit. But before that, let's actually look at how to make this entirely server auth. Basically, in order to make this server authoritative, we need to make sure that only the server can move the objects. The client can request to move, but it's up to the server to decide whether to actually move it. So over here on the player script, let's go down into where we are handling the movement. So on the handle movement function, let's go to this one. And basically what we want is over here we are moving the transform position directly. And again, remember this function is going to run on the local client. Every client is going to run this, whether they are the server or just a regular client. And to make this server auth, we need to make sure that only the server runs this code. So how we can do this is basically do a server RPC to tell the server where we would like to move. Now, if you don't know what is an RPC at all, make sure you watch my Netcode video. Basically, it's a remote procedure call, meaning it's a way to run code on the server or the client from another place. So here the clients will tell the server where they would like to move. Also, by the way, for this section, I'm going to rewrite this code to make it server auth, but then I'm going to come back to this state. The rest of the game will be client auth. So if you're following along, there's no need to follow this part. So for that, we're going to have a function like handle movement, call it server auth. This one is going to run on every client. So on this one, all we get is the input, and then we're going to send the input to the server. So we're going to do that with an RPC. So private void handle movement server RPC. And on this one, we are going to receive a vector 2 for the input vector. Then we need to mark this as a server RPC. Up here, we are going to call this function and pass in the input vector. And then down here, we're going to run the exact same code. So I'm just going to copy all of this. So just copy and paste the exact same thing. So we get the input, convert it into a move direction, and then the server itself is actually going to move the object. And that's really it. That's how you make it server auth. So let's go up here. Instead of running this function, let's run the one with server auth. Okay, that's it here. Then in the editor, let's just go into the player. And once again, let's remove this one and add the other one. So the network transform, let's add the regular one. This one is server auth. And again, the same thing. And now we can test. So here we are, and if the host moves, and yep, everything does move, that's correct. And down here on the client, if the client does move, and yep, it does still move. All right, awesome. So in this case, making it server auth is actually pretty easy. The basic idea is you only actually modify the game state just on the server. The clients can make some requests, but the server is the final source of truth. Now let me talk about the differences between server and client auth and why you'd want one versus the other. The obvious pro for server auth is security. If the server is the only source of truth for the game state, that makes it much more difficult to hack the game. The server gets requests from the clients and then can validate those requests to see if the values are valid. Meaning, for example, if the client down here, if it tries to move onto an impossible position, the server can just say, nope, you cannot move there. Whereas if the game is client auth, with that, technically a hacker could modify the game files to change something like the player speed and make the player move much faster. Since the server would just receive and accept the player position, that would actually work. A hacker could modify the game and suddenly the player can walk through walls because the server just accepts whatever the client gives it. But if it is server auth, then the client just sends an input, and if that input has a bit of a weird magnitude than is expected, if so, then the server can just revalidate that input, and that way the hacker can no longer move faster than expected. So when it comes to multiplayer, the big question is really about trust. So do you want to trust the client or not? If you do, and the client is malicious, then they might break the game, they might get some infinite money or just walk through walls. So with that said, you might be thinking that means server auth is the way to go all the time, but the answer is it really depends on what kind of game you're making. Server auth also has some downsides. Building a purely server auth game really requires quite a bit more complexity. You need to validate every single input and everything coming from the player. That really complicates things, so there is a cost to making it server auth. It does require some effort. One example as to how server auth is much more complex is simply with regards to client-side prediction. So right now the game actually looks pretty normal. The movement looks pretty good, so I'm moving around over here on the client and everything does seem pretty correct. But that is really because I'm only hosting the game locally. So right now I'm seeing pretty much no lag. Now thankfully the Unity transport over here actually has some nice debug fields. We can, for example, over here put 500 milliseconds of delay to test the difference. So now here I am playing with the same server auth, and if I move on the server over here, the host is nice and responsive. Everything works fine because this one is actually the host, so as I move, it does move automatically. However, down here on the client, I'm going to press the button hard so you can see. So move, and yep, look at that, it takes half a second for the player to actually move. So I press the button and it takes 500 milliseconds before that one actually responds to input. Now if you launch your game like this, every player would find this completely unacceptable. You cannot have the player press a button and then have to wait a long time for the changes to reflect in their own build. So if you implement server auth, then you absolutely must implement client-side prediction, which is a pretty complex topic. Basically, you would need to create just a local object. Then when the player presses a button, you would move that local object to where you think it will be when the message actually gets to the server. Whereas if you just make it client auth, you don't really have to worry about any of that. The client updates automatically and then the changes are sent to the server. So when working on games kind of like this, something casual and co-op, for this, client auth is usually simpler and will work just as well. People will be playing in co-op with their friends, so if a friend really starts cheating, they will just stop playing with that friend. In the end, the basic general answer is, if you're building some kind of PvP competitive game, then you probably want to go with server auth to stop cheaters. But if you're making something co-op, something more for fun rather than competition, then in those cases you're probably best to go with client auth. Now this game is exactly that, it's a casual co-op game, so for this game I won't be going with the client auth approach. So with all that said, let me revert back the changes to make it client auth. So over here I'm going to get rid of this function and go back into the general and null movement, and down here I'm just going to take these, and both these functions, get rid of them, so exactly the same as previously. Then back in the editor on the player, let's once again remove this one and add the client network transform instead. Same thing, let's not synchronize all of these. And finally on the network manager, down here, let us not add some debug delay. Okay, so let's test again. So here I am, if I move in the host, yep, everything works. Down here on the client, move it, and yep, everything still works. All right, awesome. So here we'll learn how to synchronize basic layer movement. And importantly, we also learn the differences between server and client auth, and which one you should choose depending on what game you're working on. Now like this, so far we only have the movement synchronized, our nice animations aren't actually playing, so let's solve that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to synchronize the player animations. This is actually extremely simple to do in Netcode for game objects, so this is actually going to be a super quick lecture. Okay, so here we have our players, and both the host up here and the client down here, both of them can move, and the movement is indeed correctly being synchronized, so it's all good. Except only the movement is synchronizing. So as I move this one, up here it's playing the animation, but down there, nope, no animation. So let's fix this. And in order to fix this, once again, we have two options. The default way is using the built-in component, the network animator. So let's go inside the player prefab, and over here we've got the player visual. This is the game object that has the animator, so we can add a component, and let's add a network animator. This one takes an animator field, so let's just drag this animator, put it on there. Yep, there it is. Now this will automatically synchronize the animator and all of its parameters. Now before we test, let's just do one very important thing. Over here on the player animator, this is the script that we made in the single player game. Over here for this script, we need to make sure that this one only runs on the owner, otherwise this script will then override the network animator. So instead of mono behavioral, let's make this a network behavior. Let's add unity.netcode, and down here on update, if not is owner. So if not is owner, just return. Okay? And by the way, this object doesn't need a network object because there's already one on the parent player game object. Okay, so like this, we've got the network animator, so like this, it should work. So let's test. So up here, if we move on the host, and if there you go, look at that, the animations are indeed being synchronized. Okay, so that's great. All we really had to do was just add this component, and the entire animator state is already perfectly synchronized, so that's awesome. However, if I go over here onto the client, and as I move it, let's see, and nope, over there we do not have the animations being synchronized. Again, we have the exact same issue that we had previously with the network transform. The network animator, just like the network transform, is server authoritative. So it will only work if the server is the one sending out the commands, and it will not work when the client is the one trying to send out the commands. That is why over here the host does synchronize, but the client does not. So again, we have our usual two options. We could modify this code to make it server auth, basically use some server RPCs to tell the server what state the animator should be in, or alternatively, we can make the network animator client auth. Let's go with that approach. And again, the docs have a nice simple script to make this. So if we go into the multiplayer docs, if we go over here into Netcode for game objects, then under components and under the network animator, over here, if we scroll down, we can see, yep, the owner authoritative mode. So if the client is the owner, which it is on the player, if so, then this becomes a client authoritative mode. And you've got the script, and literally is just this, super simple. So let's go ahead and copy this. Then back in Unity, over here, let's create a new C# script for the owner network animator. And over here, let's just select everything and paste the code. Okay, that's it, super simple. Now let's go inside the player prefab, and over here on the visual, let's get rid of the network animator and instead add the other one, the owner network animator. This has the exact same field, so let's just paste it. And just like this, all of our animations should already be perfectly synced. So let's just go outside, save the prefab, and make a build. So up here is the host, and as I move it, yep, the host is indeed synchronized. And down here on the client, if I move it, any of the client is also nice and synchronized. Alright, awesome! So as you can see, it really is this simple to synchronize animations in multiplayer. You just add a component, and that's really it. So with that, we now have the movement and the animations, both of it working perfectly synchronized. These two are pretty simple thanks to the built-in components. And now we can start handling how to synchronize some proper game logic, like for example the delivery manager, and that's exactly what we're going to do in the next lecture. Hey there, here's a quick intermission. So how are you doing? Are you enjoying the course so far? Are you having any trouble with anything? Is there something you didn't understand? Multiplayer can be complex, but once you understand it, I think this toolset is actually pretty easy to use. Just make sure you fully understand the differences between all the types, so what is a server and what is a client. If you get that part, then everything starts to become pretty straightforward. So from that, let me ask you what has been the most challenging part so far. Remember that I'm always active in the comments answering all the questions every day, so if there's anything you need extra clarification, go ahead and ask and I'll do my best to help. Also remember to check out the course website. I will keep that page updated with frequently asked questions, so you can see what others have asked for each lecture. And you can also download the project files at each point and compare with your own. So keep that page open on a second tab and check it out every time you start watching a lecture. I hope you're enjoying the course and already learned quite a few things. Go ahead, hit the like button and subscribe to the channel if you haven't already. Okay, so let's go to the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to begin synchronizing some proper game logic by handling the delivery manager. Okay, so for our first lecture synchronizing the game logic, let's begin with the simplest one, which is really just the delivery manager. So here we have the game playing right now. We have two players connected, the movement and the animations, all of it is being synchronized. But for example, over here on the recipes, note that each client is generating their own recipes. That is not correct. We only want the server to generate recipes, and we want all clients to be seeing the exact same recipe waiting list. Then we also want to synchronize whenever a player delivers a recipe, either correctly or incorrectly. And again, here we have to answer the same question as always, do we make the server auth or client auth? But before that, let's start from the beginning. Let's first go up here onto the delivery manager script. And as usual, let's swap out the mono behavior for a network behavior. And let's go ahead and add unity.netcode. Then over here in the editor, let's find the object with the delivery manager. And as soon as we select it, yep, we've got the nice window. So let's go ahead, click on yes. And there you go, it does have the network object. So back onto the delivery manager. Like I said, we only want the server to generate recipes. The other clients should just receive the recipes from the server. So let's go down here and where we have the update, where we count down the timer and spawn the recipes. Over here, we want to make sure this logic only runs on the server. So like we saw, if we have a network behavior, we've got all kinds of is properties. In this case, for running things on the server, we can ask is server. So if this one is not the server, if not, then we just return. Okay, so let's do a quick test. And yep, both the host and the client, both of them are connected, but only they're the host, only that one is generating recipes. Okay, so far so good. Now all we need to do is really just synchronize these spawned recipes so that the client knows about them. And for that, we basically have two options. We can use RPCs or we can use a network variable. Both are valid options. I covered them both in detail in the Netcode video. The one big difference between them is mostly related to late joiners. So if a player joins late, they will receive the current state of a network variable, but they will not receive the client RPCs that were sent before that time. This means that it is actually very important for you to decide whether you want to allow late joining in your game or not. That is a very important decision that will decide how you implement certain features. For this game, this is a simple game with a short session duration. Each game session is really just only about 2 minutes. So for this game, I'm going to decide to not allow late joining. So all of the players join in the beginning of the game and they play until the very end. No player can join the middle. Making this choice really helps cut down on the complexity needed to make this game. And near the end of the course, I will have a lecture talking about this difference in more detail and what you would have to change if you wanted to enable the game to support late joiners. The main takeaway right now is that this is a very important question you need to ask yourself when making your game. In my case, like I said, for this game, we are going to not allow late joiners. So for synchronizing this data, we're going to do it through the simpler RPC method. Although also, don't be confused, RPCs and network variables can both be used regardless of what you choose. It's just that in a design that is meant to support late joiners, you probably want to use network variables more often. But even if you don't want to allow it, you can still use network variables just like we will use later on in this course. Okay, so with all that said, let's implement the synchronization with RPCs. Back in the delivery manager, over here on the update, basically the server is generating all of the recipes, and when it does, we want to tell the clients that this specific recipe has been generated. So let's make a client RPC to tell the clients to spawn a new waiting recipe. So let's go up here, make a new function, private void. Let's call it spawn new waiting recipe. And as we know from seeing the other Netcode for Game Objects video, all the client RPCs must end with client RPC. So let's end this with client RPC. Then to make this an RPC, we also need to add the attribute, so client RPC. And finally, the goal is to spawn a new waiting recipe. So let's receive the recipe SO that we want to spawn. So this is the waiting recipe SO. Again, remember the RPC rules that I covered in the Netcode video. So first one is make sure the name ends exactly with client RPC. So it has to be like this, it cannot be in lowercase and so on, so it has to be exactly client RPC. Then make sure you add the attribute. And also remember how the client RPCs actually work. Basically, the server will call this function, so up here when we generate something, we are going to call this and pass in the waiting recipe SO. So the server itself is running this code and calling this function, but in reality, this function will actually run on every single client. Also remember that the host acts as both a server and a client, so the host will be running the code up here and also the code over here for the client RPC. So up here, we trigger the client RPC to spawn the recipe, and then down here we just do our local logic. So we add it to the list and we fire off the event. Okay, so this looks like valid code, we have no errors. However, if we go back in the editor, yep, here in the console we do see a bunch of errors. This is also important. Server and client RPCs have various rules and validation which does not run on Visual Studio, but it does show up over here on the console in the editor. So when you make an RPC, always check the console to make sure you didn't break any of these rules. For example, this rule here is telling us that the Netcode library does not know how to serialize our recipe SO object. Basically, for RPCs, we can only synchronize value types, or we have to tell Netcode how to serialize them. The more complex option is to implement iNetwork serializable. I covered that in the Netcode video, but a much more simple option is to just use a type that can already be serialized. For example, over here on this script, we already have a recipe list SO, and for deciding which one is going to be the waiting recipe, we are really just randomly generating an int, so generating a random index. So we can just modify this code so that instead of sending a recipe SO, instead of that we can just send the index of where it is on the list. Since all the clients have the exact same list, by sending the index, we're actually going to be able to get the exact same SO. So let's do that. So over here, instead of a recipe SO, let's receive a parameter of type int. This is the waiting recipe SO index. And then up here, let's also define that. So the int for the waiting recipe SO index, and we do our random.range, so the usual stuff. Then we pass in this as our parameter. And then down here, we can simply get the waiting recipe SO by just going into the exact same array and grabbing it from there. Okay, so that's it, very simple. Again, remember that the host acts as both a server and a client. So the host will run both the code up here as well as the code down here. So importantly, make sure you only add this local code, adding it to the list and spawning the event. Make sure you only add this one down here and not also down here as well as up here. If you add it in both places, then the host will end up spawning 2 recipes every time. Now, before we test, let's just go up here for the spawn recipe timer. Here, this one starts off at 0 and we count down, meaning that literally on the first frame, it is going to spawn right away. Let's add a bit of time over here, let's say for F. This is just so we have some time to press the host and the client buttons before anything is actually spawned. Okay, so with that, let's test. So up here, let's connect the host, down here the client, and now let's wait a little bit and see if the recipe is spawned. And yep, there you go, that one spawned the recipe, and yep, that one did get the recipe synchronized. So it spawned that one and then that one, so they both have the exact same recipes. And if we wait a bit, yep, both have the exact same max amount of recipes. Alright, awesome! Now here, let me make one point. Later on in this course, we're eventually going to synchronize the game start, the game countdown, and so on. So when we do, this code will work perfectly. But right now, you do need to make sure that you connect the host and the client as quickly as possible. If instead I connect the host here and I wait 4 seconds to spawn a recipe, so just wait a bit, that one is spawned, and now I connect down here on the client. If I do that, then yep, look how now we have 2 recipes, but down here only 1 recipe. So this is a good example of the difference between network variables and RPCs. Basically, this client joined late, so because of that, it missed the RPC spawning the first recipe. But again, like I said, for the design we're going to do, this scenario where the player joins late, this one is never going to happen. Just make sure that during testing, you click on host and then on client as quickly as possible so you get the actual proper behavior and not just a testing bug. Okay, so now that we have the spawning synchronized, let's handle the delivery. If I go on the host and I just try delivering something right now, there you go, only that one receives it. This one down here has no idea something was delivered. So we need to synchronize the actual delivery. Back in our delivery manager, let's go down into the function. Here it is, the deliver recipe. Here we are going to have the exact same question as always. So do we make the server auth or client auth? Meaning, do we validate the delivered plate on the client, and then the client tells the server whether it was a correct or an incorrect delivery? Or does the client pretty much only send the plate kitchen object, and then the server validates the contents? Again, for this co-op game, let's just trust the client and go with client auth. So the client is going to run all of this logic, and then down in the end, it won't tell the server whether it was correct or incorrect. In this case, we want the client to tell the server, so instead of a client RPC, we're going to use a server RPC. So let's go up here, make a private void, deliver correct recipe, server RPC. And we're going to add the attribute server RPC. Okay, this is it. However, this will only run on the server. Again, remember the very, very important differences between server, host, and client. If we do it just like this, and I copy the code, so the local code for delivering the correct recipe, and I just put it like this. If we do it like this, then only the server will run this function. So if you do it just like this, the client will not know that the recipe has been delivered. So always remember those 2 types, server and client. Basically, we want the client to tell the server that it delivered a correct recipe, but then the server needs to broadcast to all of the clients that that behavior just happened. So when the server receives a server RPC, we then need to send a client RPC to broadcast that message to all the clients. So let's go down here, make a private void, deliver correct recipe. This time it's a client RPC, and we mark it as a client RPC. And then it's down here that we do the actual behavior for actually delivering the correct recipe. So then on the server RPC, it just calls the client RPC, which again, remember how this runs. Remember how the host is both a client and a server. So if we run this on the host is going to run this function, and then the host is going to run this code, and then the host is also going to run this one. Whereas a client is going to call this function, but then the client itself does not run this. The server runs this, calls the client RPC, and then the client will also run this function. So with this, the logic should be working correctly on all of the correct places. We just need over here, we need the index. So this is the index of the recipe that has been delivered. So let's just add it over here as a parameter. Since it's an int, we can use it on a server and a client RPC. So let's just find an int for the waiting recipe SO list index. And up here we pass in the I, then we pass that one in onto the client RPC, and then we just use it over here. Okay, so the correct delivery has been synchronized. Now let's do the exact same thing for the incorrect recipe. So let's do a private void deliver incorrect recipe for the server RPC. And then we're going to have another one, but this one is going to be the client RPC. Then let's set the attribute, so client RPC, and up here we've got the server RPC. Then the server is going to call the client RPC to deliver the incorrect client RPC. Yep, just like this. And then on all of the clients, we're really just going to fire off this event. So just like this, and we're going to trigger the server RPC up here. Okay, so that's it. Some pretty simple logic. As long as you understand the flow for how the server RPCs and the client RPCs work, as long as you understand that, then all of this is pretty straightforward. So let's do a test and see if this works. So up here on the host, let's deliver a correct recipe. So let's make a quick burger. So just put that on the fryer. Let's grab some bread, pick up some plates, pick up the meat, pick up the bread. And now if we go ahead and deliver it, and yep, there you go, it does work. Both of them saw a delivery success and both of them removed it from the recipe list. Okay, that's great. But now down here, if we do it on the client, so let's try to deliver a cheeseburger. So let's pick up some meat, cook it. Let's pick it up. We just need this. And let's try delivering it over here on the client. And nope, over there we have an error. This error has to do with ownership, and just like it says, only the owner can invoke a server RPC that requires ownership. Since the delivery manager belongs to the server and not the client, that means that only the server can trigger that server RPC. That is the default behavior for server RPCs. They can only be called by who has ownership. And to solve this problem, we actually have a very simple solution. Over here on the server RPC attribute, we can have some optional parameters. And one of them is down there, the second one, the require ownership. So we can set require ownership equals false. And this way the server RPC no longer requires ownership in order to trigger the server RPC. That means that the client that does not own this network object will be able to trigger this server RPC. So let's do this both up here on the incorrect recipe and down here on the correct one. Okay, so just with this change, let's test. So down here on the client, let's try to deliver a salad. So let's pick up a tomato and just slice it. Then pick up some cabbage and slice it. Pick up some plates, put both of them in there, and let's go ahead and deliver. And if there you go, delivery success. All right, awesome. Now let's try delivering a failed recipe. And yep, that one also works. And up here on the host, deliver a failed recipe. Yep, also works. And now a success, so let's cook a nice burger. Now let's go ahead and deliver it correct. And yep, there you go, delivery success. All right, awesome. So we have everything, every logic working. Now with this working, let me just quickly talk about how you could make this system server auth. The answer is really just like I mentioned a while ago. So over here, instead of running the validation here and then telling the server whether correct or incorrect, instead of doing that, the client would simply tell the server, I want to deliver this plate kitchen object. Then the server would check the contents of the plate and basically validate them. As long as you make every step of the process for adding ingredients onto the plate, as long as you make all of that server auth, then the entire logic would be fully server auth. But again, in our case, for our simple game, let's just stick with the simpler client auth. So here the client validates the plate and then just tells the server whether it was correct or incorrect. Then the server receives that RPC and simply broadcasts the message to every single client. Okay, great. So over here we handled synchronizing our very first custom game logic. To make our game fully multiplayer, we really just need to apply this same process to every other part of our game. But before we get to synchronizing some more things, let's quickly fix just one minor thing. When we first converted this game to multiplayer, we had to get rid of the player singleton, which in turn broke the selected counter visual, so let's fix that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to fix the interact selected visual. Okay, so here is the game so far. I can move around as either the host or down here as the client, but when I look at a counter, nope, there's no selected visual. There's no selected visual down here, nor over here on the host. So let's fix that. Now, this is actually super simple. The issue was over here on the player script, we had our instance, but in multiplayer we don't have a single player instance, and it's also not spawned automatically. However, we still have just a single local player, and that is really all we want for the selected visual. So let's uncomment this code, and instead of instance, let's rename this to a local instance. So this is going to be the local player. And for assigning it, usually we do it down here on awake. However, when dealing with multiplayer in Netcode for game objects, for networked objects, you really don't want to usually use the awake or the start. Instead, there is a similar function that is specific to Netcode. That one is called onNetworkSpawn. So over here, public, let's override the void onNetworkSpawn, so this one. Basically, this function is called when this object is spawned on the network. So over here, we can just test if is owner. So that will mean that this is the local player. So if so, then just set local instance set to this. So we do this, and over here on awake, we don't do anything. Okay, so that should pretty much set the local player over here on the local instance. Then let's go over here onto the selected counter visual script. Over here we were listening to the event, and we just do the exact same thing, except now it's called local instance. Then the rest of the code is exactly the same. However, if we do it like this, we're actually going to have the same problem that we saw previously. Again, that is because the player is not going to spawn by default. It is only going to spawn when we press the host button. So if we run this, then this is still going to give a null reference exception. We don't want that. So basically, we need to know when the player spawns. So let's go back into our player script. And up here, let's make a nice static event. So a public static event handler, and let's call it on any player spawned. We're making this static because we want this event to belong to the player class itself and not any specific player. So we have this event, and then down here, when we have the onNetworkSpawn, when this one happens, let's just invoke this event as usual. So this and event args.empty. Okay, so now we have this nice event. Now we can go back into the selected counter visual, and over here, first let's test if it already exists. So if the local instance is not null, if so, then just assign it right away. But if it is null, if so, then let's go into the player and the on any player spawned event, and let's listen to this event. And when this happens, we're just going to run the exact same code. So check if there's any local instance, and if so, listen to the event. However, yet another potential sneaky issue here. This event will fire multiple times for multiple players. So if the first one were the local instance, then we could end up with multiple listeners, which would cause a lot of duplicated logic. So in order to make sure that doesn't happen, let's just duplicate this, and we do unsubscribe, and then we subscribe. This way we make sure that no matter how many times this event is fired, that we're only going to have a single listener. Okay, so that should fix it. However, let's just do one more thing. Like we saw at the end of the single player course, for static events like the one that we just made, those can cause problems when changing scenes. That is why we made this class at the end of the single player course. So since we added a static event on the player, let's also clear it. So we can just copy the function from one of these, so it's just a static function to do that. So let's copy this, let's go into the player, and over here let's paste our reset static data function, and we just set the event to null. Then we just need to go into the reset static data manager, go into the player, and trigger that function. So this will clear up and not cause any problems. Okay, so with this, let's test. So up here, let's make a host, down here make the client, and now on the host, if I move and I approach that, yep, there you go, that counter is now selected. And down here on the client, we can see that one does not show up as selected. And now if down here I select a different counter, yep, there you go, now that one does show up as selected. So the selection logic is fully working, and it is local to the local player. Alright, awesome! Let's just fix one more related thing. Over here on the sound manager, down here we were also listening to the player event when the player picked up something. So we could uncomment this and listen to the local instance. However, now we're going to have more than one player, and we don't want to listen to this event only on this local player. We want to listen it on any of them. So if any player picks up something, we want to play that sound. So as usual, let's make another static event. So back here on the player class, let's make another one, public static event handler, and let's call it on any picked something. So just following the same pattern as usual. And we're going to fire this on the exact same place where we fired the on picked something. So let's go down here where we set the kitchen object. So it's on this one. And let's just invoke the event, pass in this, and event args.empty. So over here, instead of listening just on the local instance, let's listen to the on any picked something. And that is going to run this function. And again, let's uncomment this code. And over here, we also don't want to play this on the local instance position. We want to play it on the position of the player that actually picked something. So we can just grab the player and grab the player reference from the sender as player. So over here, just use the player, transform that position. Okay, so that should do it. Let's test. Okay, so up here is the host, down here is the client. And now if I go ahead and I pick up something, and technically this did work, so we don't have any errors anywhere, but we can't really test that this is working because we haven't yet handled syncing and picking up the objects. So when the host up here picks up something, the client down here doesn't know that actually happened. But we don't have any errors, so the code is all working perfectly. With that, now let's handle synchronizing the object pickup in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to synchronize picking up objects. Now this one and the next lecture are going to be some quite tricky lectures. It requires us to learn various quirks with how Netcode for game objects works, so definitely do pay attention. If you manage to understand everything in this lecture and the next one, then you will understand pretty much most of what is required to build any multiplayer game. Okay, so right now we can walk around as either the host or the client. But if one of them picks up something, like for example up here the host picks it up, and nope, the client down there does not see it. So we need to synchronize this. Now this topic involves, first of all, spawning objects. So when we pick up a kitchen object from a container, we are going to spawn it. And for spawning objects, you always need to do it on the server. So let's go over here onto the kitchen object script. And like we already saw, in order to make this script multiplayer instead of mono behavior, let's implement the network behavior. And this was inside using unity.netcode. Okay. So let's go ahead, swap this and save. And back in the editor, we need to attach a network object. So let's select every single kitchen object. So over here, let's click on no, just to be able to select all of them. And now just add component and let's add a network object. Okay, so like this, all of them have a network object. Okay, so far so good. Now we're going to spawn these objects dynamically. And for any object that we want to spawn in the server, we need to add it to the network objects list. So let's go into the network manager, and over here we've got the network prefabs. Every object we want to spawn needs to be here, so let's go ahead and drag all of these. So just add all the entries and drag. Alright, so here are all the references. Make sure you add all of them so you don't get any strange errors. So over here we got 3, 6, 9, 10, 11. And over here 3, 6, 9, 10, 11. Okay, great. So now that this network manager is set up, let's see how we're going to spawn it. Let's go over here onto the container counter. This is where we are spawning some kitchen objects. So let's inspect this function. So here it is, the spawn kitchen object function. And to do that, we are just going to the scriptable object and instantiating the prefab. Now, like I said, spawning objects needs to be done on the server. And how we are going to enforce that is by using a server RPC. So technically, we could just mark this function as a server RPC. However, for this function, we made it static, and we cannot make a server RPC static. It needs to be a non-static function. So technically, one alternative would be to remove static over here, make this a non-static function, but then we would need a reference to a kitchen object in order to spawn more kitchen objects, so that's not very good. Instead, let's make a general class to handle our specific multiplayer logic. So back in the editor, let's create a brand new C# script. This is going to be the kitchen game multiplayer. Let's make a game object with the same name. Let's reset the transform and attach the script, and let's open it. Again, just one. There's this weird bug in this Unity version, so just one. Let's open. Now over here, first of all, as usual, instead of mono behavior, let's make this a network behavior. So back in the editor, let's just add the network object component. Okay, great. Now over here, let's begin by making this a singleton. So the usual stuff. So public static kitchen game multiplayer. Call it instance, and we've got a public get and a private set. And on private void awake, on awake, let's set the instance equals this. Okay, we have the nice singleton that we can use. Now let's just copy pretty much the code exactly. So let's copy this. Let's go into the multiplayer, and over here, let's paste it. Except this one is not going to be static, so like this. Then back over here on the kitchen object, this is essentially just going to be a pass-through function. So let's go into the kitchen game multiplayer, access the instance, and spawn this kitchen object. So pass in the kitchen object as so, and the kitchen object parent. So do this just like this. Also, the return type is going to cause some issues with the RPCs. You cannot have a return other than void when you're working with an RPC. Now in the single player game, we made this return a kitchen object just in case we needed it, but we never actually end up using it. So just swapping this out for void shouldn't break anything. And same thing on this other one, so let's go in there. And over here, instead of returning kitchen object, just return void. Okay, so far so good. So now we have this function where we want to spawn a kitchen object. Now again, this one is still not a server RPC. We're going to add that in a little bit. Here we are instantiating to spawn the object, and then we get the kitchen object script, and then we set the parent. Then here on the function for setting the kitchen object parent, we do a bunch of logic, and then importantly, we modify this transform.parent. Now changing the transform parent is actually going to cause a lot of issues with Netcode. So for now, let's just comment out this part so this doesn't run. Let's just do it like this, first to test that spawning is working, and then we'll worry about this. So here we are spawning the object. However, just like this, we are really just spawning the object locally. In multiplayer, when spawning something, we need to go into the network object and spawn it so it actually spawns on the network. So let's grab this kitchen object transform, and let's do a get component of type network object. So we get this network object, so the kitchen object, the network object. We get this one, and then we can call the function spawn, and this is actually going to spawn on the network. Then takes the parameter for destroy with scene. So let's make this work just like any other game object. So by default, game object gets destroyed when you change scenes. Over here, let's do the same behavior. Okay, so let's test and see if the object is being spawned on the network. Okay, so here we have a host and a client, and on the host, I approach this and I pick it up, and there you go, it did work. The object was spawned over there on the host and also over there on the client. Okay, so far so good. But now if I go down here on the client, and let's try to pick up something, so let's go in there and pick it up, and nope, there you go, we've got an error. As it says, only the server can spawn network objects. So this is the error that I mentioned. We need to use a server RPC to make sure the spawn code only runs on the server. So over here on the kitchen game multiplayer script, let's make a server RPC that will actually run this code. So let's do a private void spawn kitchen object server RPC. And let's mark this as a server RPC. And we're going to want the client to be able to call this. So as usual, let's make sure to set require ownership equals false so that the client can call this. And over here, we are just going to run this code just like this. So now we need to pass in the kitchen object SO as well as the parent. So let's put these as parameters. So just like this. And okay, we see no errors here. And up here, we are really just going to call this. So kitchen object SO and then the kitchen object parent. Okay, it looks good. But if we go in the editor, and nope, we see a bunch of errors, so this code is not valid. It's pretty much the same problem that we saw previously. We cannot pass in a scriptable object because it does not know how to serialize it. So over here, let's use really the same solution. Let's just convert this scriptable object onto an index. So for that, we need to define a list of kitchen object SO. Now we could go up here and just find a serialized field for a list. That would work. Or let's do it just like we did with the recipe and make a proper kitchen object list. So if you remember, in the single player course, we made a recipe list. This is a scriptable object that holds a list of all of our recipes. So let's do the exact same thing to hold a list of all of our kitchen object SOs. So let's go ahead and make a new script, a new on the scriptable objects. Let's create a brand new C# script. Call this the kitchen object list SO. And over here, let's make this a scriptable object. And then inside, we just have a public. It is going to be a list. And it's going to be a list of kitchen object SO. And just call it kitchen object SO list. Okay, now in order to construct it, let's add the create asset menu. And now in order to be able to construct an object, we need to be able to compound the code. So let's go back into the multiplayer, and over here, let's just comment out the RPC just so our code compiles. So just comment all of this, okay. So now back in the editor, the code compiles. So let's go inside the kitchen object SO folder and create a new kitchen object list SO. And let's give the name and start with underscore just so it shows up on the top of the list. And okay, now here we have the list, so let's just populate it. So let's use the nice inspector and lock button in order to lock it. And just select all of them and just drag all of them onto the list. Okay, great. So now we have this script object that holds a list for all of the kitchen object SOs. And just make sure we don't accidentally create more of them. Let's just comment out the create asset menu so we cannot create any more. And now if we go over here on the kitchen game multiplayer, we can add a serialized field, and we can make it of type kitchen object list SO. So we have now this field, and back in the editor, let's just select it and just drag the list. Okay, great. So with that, we can now access the list and pass it in as an index instead. So let's uncomment this code, and then for the parameter, instead of receiving kitchen object SO, let's receive an int for the kitchen object SO index. And then here we convert back. So kitchen object SO, we grow into the kitchen object list SO, then access the list inside of it. And then let's access on the kitchen object SO index. So now up here we can pass in the index, and let's actually make some nice helper functions so we don't have to write all of this code over and over again. So a private return int get kitchen object SO index, and this one receives a kitchen object SO. And very simply just returns, just goes inside the kitchen object list SO. We grab the list inside of it and we do index of this kitchen object. Okay, so that one converts into an index. Now let's do the opposite. So return a kitchen object SO, get kitchen object SO from index, and receive an int for the kitchen object SO index. And over here we do the code that we were doing up here. So just go in the list and access on this and just return it. Okay, so we have these two nice helper functions. So over here, let's just grab the index and pass it in. And then on this one for the kitchen object SO, let's use the function and grab it from this index. Okay, so that solves that problem. Now we are only synchronizing the server RPC with a nice int index. However, here in the editor, we still have the same error. This one is related to the kitchen object parent. Again, does not know how to serialize it. And to solve this one, we are going to use a really useful netcode type, which is the network object reference. So over here, instead of receiving that one, let's receive a network object reference. And let's name this kitchen object parent network object reference. This is how you can pass in an object reference through an RPC, and then on the other side, convert the reference back into the actual object. If we just comment out this function call and look in the code, as well as this one down here, and yep, we have no more errors, so this is now valid RPC. So you can now call this function and everything should work. But of course, now the question is, how do we get the network object reference from this interface? In order to get a network object reference, really all we need is to pass in a network object, then in the background to automatically convert into a reference. So we need a network object from the kitchen object parent. And how we do that is super simple. This one is an interface, so really let's just make another function. This one is going to return a network object, just get network object. Okay, so that's it, super simple. Now we just need to implement this function on all of our interfaces. So for example, over here on the player has an iKitchen object parent. So let's go down to the bottom and let's implement our function. And the player is already network behavior. And from network behavior, we can access the network object that is attached to this network behavior. So just like this. Then the other place we need to implement is on the base counter. So here we are on the base counter and let's implement the same function. And now for this one, we still haven't yet made the base counter into a network behavior. We're going to do that in a little bit, but for now we don't want to worry about it. So just make sure the code compiles. Over here, let's just return null. Right now, we really just want to handle the player picking up objects. Then afterwards, we'll handle the counters. Okay, so back here on the multiplayer class, now we can just access the interface. And through the interface, we can just get the function, get the network object. And yep, there you go. The type network object gets automatically converted into a network object reference. So that's great, so this one is now valid. Now of course we need to get the kitchen object parent back from this reference. And how we do that is super simple, so we can access the network object reference, and in there we have a function tryGet. This one basically lets you get the network object that was originally sent. So let's get out of type network object for the kitchen object parent network object. So we get that, and then from this one, we can just do a get component of type iKitchen object parent. And with that, we have the kitchen object parent. So then we can just run the usual code just like this. Now here, let me point out one thing. Perhaps you might be thinking that these variable names are way too long. And again, it goes back to what I mentioned in the naming rules on the single player course. Naming rules can really be whatever you want them to be. In my case, personally, I prefer to have extremely descriptive variable names, even if they become a bit too long. I prefer that over having compact names, which then might cause confusion because I don't know what the variable actually contains. But again, this is personal preference, so if you don't like the super long variable names, then by all means go ahead and follow your own rules. Okay, so over here we wrote quite a bit of code, but everything should now be working. We have no errors, all of the parameters for the server RPC, all of these are valid. So we pass in the SO as an index, and we pass in the parent as a network object. Then on the server side, we just get the other references and we use them. Okay, so with that, let's test. So here we are, and up on the client, let's try to pick up some cheese. And there you go, it did work. Again, don't worry about the fact that it's on the floor. That is because we disabled the parenting. We're going to handle that later. Right now we just want the spawning, and that did work. And then if we go down here onto the client, let's try to pick up some meat. And if there you go, it did work. No errors, nothing, everything worked perfectly. All right, awesome. So here we learn how to spawn an object and synchronize it across the network. However, like you can see, that object is still being spawned just in the middle of the ground. Instead, it should really be being held by the player. So let's handle that tricky part in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to synchronize the kitchen object parent so that the objects are actually being held by who owns them. Okay, so here's what we have so far. I have both a host as well as a client, and I can interact with the container counter, and yep, it does spawn the object correctly, but as you can see, the object is spawned on the floor. It is not being held by the player. So let's handle that, and this is actually going to be the really tricky part, which is parenting the object. Let's go over here onto the kitchen object script. And down here we have the lines that we commented a while ago, modifying the parent, so let's uncomment these. Let's save and let's test again. So here we are, and now if I try to pick up something from the container counter, and if there you go, got an error right away. Right away the message says invalid parenting, the network object is moved onto a non-network object parent, and that is something you cannot do. So the issue here is because when we made the game, we made it so that the spawn kitchen object becomes a child of some transform in order to automatically follow it around. So over here, the player has in front of it an empty point, so that is where the kitchen object would be placed. This is an excellent approach to do in single player, but in multiplayer, handling object parenting becomes a lot more complex. The specific issue that we can see down here is that the player itself, so the player, the main game object, this one is indeed a network object, but the empty container over here, this game object, this one does not have a network object. So we cannot make it a direct child of this object. And beyond that, Netcode for game objects actually has one more limitation, which is you cannot set a network object as a child of another network object that was spawned dynamically. If you have objects that are already placed in the scene, like for example our counters here, if you have that, you can make a network object, like for example a spawn cheese, you can make it a child of one of these counters, but the players, they are spawned dynamically, so you cannot make one of these a child of the player. So basically everything that has to do with parents becomes really tricky in multiplayer. The best option is really to avoid doing that altogether and really just come up with a different solution. The only reason why we made it using this pattern of changing the parents was just to make the movement simpler. By making an object a child of another one, it means it automatically moves along with the parent, but if we can't change the parent, we can still make it just follow some object without having to modify the parent. The end result will visually be exactly the same, so let's do exactly that. Let's make a script to follow an object, so let's create a brand new C# script. Call this the follow transform. And let's go ahead and attach this script to every single kitchen object. So let's go inside the prefabs, the kitchen object, select all of them, and let's attach this script. So the follow transform, let's add this. Okay, now let's open. So over here, we really just want to store the target transform that we want to follow. So let's define a private for our transform for the target transform. Then let's just make a function we can expose in order to set it. So set target transform. And receive a transform for the target transform, and we just do this dot target transform equals this target transform. Okay, so this way we can set it, and then for actually moving the object, for that let's go with a private void late update. Let's go with late so it happens after all of the updates. And first of all, let's do just a quick safety check. So if the target transform, if it is null, that means we have nothing to follow, so let's just return, let's stop. But if it isn't null, let's just set this transform.position equals the target transform.position, and same thing for the rotation. So rotation and rotation. Okay, so we have a very basic script that all it does is receives a target transform and just follows it and rotates alongside it. Now let's go over here onto the kitchen object. And first of all, we need to get that component. So let's define up here a field for the follow transform, and we're going to get this. Let's make a private void awake. So let's do a get component of type follow transform and set this on the follow transform. Okay, we have our script reference. And then down here, instead of modifying the parent, instead of that, let's go into that one and set the target transform and pass in the exact same one. So this target transform. Okay, so let's do this instead of modifying the parent. All right, with this, let's test. Okay, so up here on the host, let's pick up something, and if there you go, it does work. So as you can see, the object is indeed perfectly following it, as if it were with a changed parent, but without actually changing the parent. So that's great, that works. But down here, the client has no idea that the host is holding something. And now if I try to pick up something on the client, so let's pick up a tomato down here, And look at that very strange behavior. So if you see, the object was indeed spawned over here on the client, and on the host, the client did indeed pick up that object. So everything is working perfectly over here on the host, but as you can see, everything is on the floor right down there on the client. Honestly, this one part confused me for quite a bit as I was making the prototype. The issue is actually over here on the function to spawn a kitchen object. If you want, pause the video and look at this code and try to figure out what might be the issue. It's actually very obvious once you remember how multiplayer actually works. Always remember the big difference between server, host, and client. And you also have to remember how the various things you do in Netcode are synced. Here we are instantiating and then spawning a network object. When you do that, it gets actually spawned in the network, so that gets synchronized automatically. All of the clients will receive this brand new spawn object. However, down here the code for setting the parent, for this one the clients will not receive this automatically. So this code is only running on the server. That is why the client was holding the object on the host, but not on the actual client build. That is because only the host actually ran this code. So that means that we need to synchronize this parent data somehow. For that, let's go ahead and do it with a nice RPC. Let's go over here onto the kitchen object script. And when setting the parent, first we need to tell the server that this object should change parent. So let's begin by making a server RPC. So a private void set kitchen object parent server RPC. This one is going to be marked as a server RPC. And again, we want the client to be able to do this. So as usual, let's set require ownership equals false. Okay, we have this parent RPC, and now we want to pass in the kitchen object parent. Except, of course, again, if you remember, we cannot pass in a kitchen object parent directly. This does not get serialized, so we cannot use this. So let's pass it in as a reference, exactly like we did on the multiplayer class. So over here on the multiplayer class, we had this reference, and then we did a try get to get it. So let's do exactly this code. So first, let's copy the parameter. And then let's paste the code to actually get the kitchen object parent. Okay, so now we have the kitchen object parent. But again, this is just a server RPC, meaning this is only going to run on the server. That is not what we want. If we want all of the clients to update the parent, then this code to actually set the parent, this one needs to run on all the clients. So basically the client will tell the server, and then the server tells every single client what the new parent is. So let's make another one. Let's make a private void. And for this one, set kitchen object parent client RPC. Let's make this a client RPC, and let's pass in the exact same parameters. So let's pass in this, and it's over here on this one that we actually run this code. And then for the rest of the RPC, we're actually going to run the regular set parent code. So let's copy this and paste it over here. Okay, so we've got the nice client RPC, and then of course, when we call the local function, we're going to call the server RPC in order to tell the server that this object should have this new parent. And for this one, let's do get network object. Okay, so we have that. Then the server receives the server RPC and basically just broadcasts it to all the client RPCs and tells every single client that this object now has a brand new parent. Okay, so with this, all the clients should receive the message that the parent has changed. Now let's test and see if the client can pick up a new object. So here we are, and up here on the host, let's pick up some cheese. And if there you go, it does get synchronized. Okay, great. And then down here on the client, let's try to pick up something else, pick it up, and if there you go, it does get synchronized. So both of them have the exact same state. All right, awesome. So this part is working perfectly. Now, if I go over here on the host and I try placing this object somewhere, and there you go, we've got an error. The error is that the argument is returning null, and this is actually, if we follow it, we can actually find where we're finding this. Here it is, it's on this line on the kitchen object. So this one goes into the parent, gets the network object, and apparently this one is returning null. And again, this is the issue that we saw a while ago. So if we go on the base counter, a while ago down here we had to implement this for the interface, but we just made return null, so this is the issue. The solution is very simple. Let's just go ahead and make the base counter instead of monitoring behavior. Let's make this a network behavior, and then down here instead of returning null, let's return the proper network object. Okay, so that's good. Now all we need to do is make sure to attach the network object to every single base counter. So back in the editor here, let's go into our prefabs, onto our counters, and here we have all counters. And the way we made them is they are all variants of this base counter. So we can just select this one and just add the network object. So there you go, just add this one onto the base, and now all the others, yep, all the others now have the network object. Okay, great. So if we test like this, so up here we have the host, and let's pick up something. Yep, that is synchronized just as previously. And now if I go and I drop it there, and if there you go, that one also does work. Same thing on the client down here. Let's pick up some bread. Yep, picks it up. Everything works perfectly. Now drop it, and yep, there we go. Everything is synchronized perfectly. All right, great. Again, here we have yet another excellent example of the power of writing good, clean code, because we set up our game with some very good code by using our interface and the base counter class. Because of that, just by making a few changes, we already have a ton of the game working in multiplayer. So that's great. However, we also actually have one slight issue here. So if I try to pick up something from a container counter, yep, it does work. All of them work. However, if now I go over here onto the plates counter and I try to pick it up, and nope, there's our error. Let's see where this error is actually coming from. So over here, kitchen object 50. And this is actually a pretty sneaky error. So something in here is set as null. Now we already know that we added the kitchen object parent correctly. So this one cannot be null. So the only thing that can possibly null is over here the follow transform. And the follow transform is actually set up here on the awake. So it seems like that should always work. However, the reason why this error only happens on the plate, that's actually a nice clue. If we go over here on the plate kitchen object script, over here we already defined an awake in order to initialize our list. So the plate has this awake, and then the kitchen object also has an awake. So like this, we are defining two completely separate functions, so the plate is actually hiding the other awake. That is why over here for the plate, when interacting with the plate is not going to run this, so the follow transform will always be null. This is something that actually took me quite a bit of time as I was building the prototype. That's because Unity for some reason doesn't show you a warning for hiding functions if they are monobehavior functions. If this was a regular function, it would show that warning, but for some reason on the monobehavior functions, this one does not show. Anyway, thankfully the solution is actually pretty simple. Let's just go over here on the kitchen object, and for this awake, instead of private, let's make it protected, and let's make it virtual. Okay, so this is the awake. And over here on the plate kitchen object, we can make this protected, and then make an override. Now this one will override the other one, but we still want to run that one, so up here we can just do base.awake in order to run that code. Okay, so now it should work. So over here I can try going to the plate and pick it up, and yep, there you go, now it does work. Okay, great. Now, by the way, we still have one issue where we cannot pick up an object onto the plate. So if I try to grab some bread over there and try to drop it, like this, the plate contents are not yet being synchronized. That's normal, we're going to handle that later on in the course. For now, we just care about changing the kitchen object parent, and that part is indeed working perfectly. So on either build, I can pick up, interact with the container counter to pick up something. All of it works, so now this one is now picking up something, so that's great. However, the counter interaction itself is actually not being synchronized. So for example, if I'm controlling the host up here, and if I go and I pick up something, look what happens down there on the client, I pick it up, and if there you go, it does spawn the object, but there no animation played. The animation only played locally on the actual object that was interacting with the counter. Again, that's because the interact function, this one is only local so far, so let's synchronize this as well. Let's go over here onto the container counter. And over here, we're basically spawning a kitchen object and firing off an event. This is what actually plays the animation. Now for spawning the event, this one is already being synchronized, so that's great. All we need is really just to synchronize this part. So let's basically make a function to synchronize the interact logic. So let's make a private void, call it interact logic server RPC, because we're going to first tell the server. So this one is a server RPC, and as usual, let's make require ownership as false, so that all the clients can call this. So we do this so we can tell the server that this counter was interacted with, and then the server needs to broadcast that message to every single client. So over here, let's make a private void for the interact logic client RPC. And this one add the client RPC. And now it's on this one that we do the actual local logic. So we run this logic there, we call the client RPC from the server, and we trigger the server RPC locally. Okay, so that's it, pretty simple. Let's test. So here we are, and up on the host, I'm going to pick it up and see if it's synchronized. And if there you go, the animation does synchronize, so that's great. And if I go down here on the client and I try to interact and see if that one synchronizes, and if there you go, everything worked perfectly. All right, awesome. So with that, the container counter is now fully synchronized. And with that, we have quite a lot of stuff already working perfectly. Now, these past few lectures are some of the more complex ones. So if you didn't fully understand something, maybe go back and rewatch it. Also remember to read the course page FAQ, I'll keep that updated as more people ask questions. And of course, I'm always available answering any specific questions you have. Basically, if you do manage to fully understand everything in these past few lectures, then you already have most of the knowledge required to make any multiplayer game. Okay, so with this, with the container counter working, Everything is looking great so far. Next, let's work on a bit of a simpler one. Let's synchronize the plates counter. So let's do that in the next lecture. Hey again, here's another quick intermission. I hope you've already learned a ton in this course. How are you handling the multiplayer? Is it being difficult or relatively easy? Do you understand how the RPCs work? The difference between server and client RPC? Remember to follow the course page website as you follow along. I'm constantly adding frequently asked questions to every lecture. If you ever get stuck, you can just download the project files for each lecture and compare with your own. And by the way, if you're listening to this, let's say this is the secret callout, so go ahead, post a timestamp with a monkey emoji in the comments. I want to see how many people get this far. And if you are finding it helpful, and if you can afford it, then check out the optional paid course or post a super thanks. Okay, that's it for now. Let's go to the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to synchronize the plates counter. We want to make sure that all of the clients have the same number of plates. This is a pretty simple counter, so this one is going to be a quick lecture. Okay, so let's synchronize the plates counter. So it's this one right here which spawns a plate, and then the player can pick up a plate. Right now this logic is only working in single player. All of the clients are spawning their own plates. So if I pick one up over here on the host, it does not synchronize down there. This is not correct, only the server should be spawning them and everything should be synchronized, so let's do that. First, let's go over here onto the plates counter script, and then down here we've got the update where we count down the timer and spawn the plates. Now, first of all, we're only going to run this logic on the server. So as usual, let's do a is server. So if we are not the server, then return and don't run this logic. So like this, only the server is going to spawn some plates. Now all we need to do is tell the clients that the server has spawned something. So as usual, let's use some RPCs. So let's go over here, make a private void. First of all, let's make a spawn plate server RPC. And then a spawn plate client RPC. Let's add the attributes on both of them. In this case, this one is only going to run the server, so we don't need to add the require ownership. So we do this from the server RPC. We call the client RPC. And on the client RPC, we're basically going to run our local code. So just like this. Also, by the way, technically, since the code up here is always only going to run the server, technically we could avoid using a server RPC here, but just to keep the same logic, the same pattern that we've been using, let's do it like this. So on the regular logic, we trigger a server RPC, which then broadcasts a message to all the clients. Okay, so that's it, super simple. This will handle synchronizing the spawning. Then for picking up, let's do the same thing that we did on the container counter. So over here on the container counter, we've got the interact, and then we use a server and client RPC pair in order to synchronize that data. So let's do the exact same thing. Let's use the exact same name, so let's actually copy all of this. And over here on the plates, let's just paste them. And then we're going to fire off the event, so over here. And also count down the number of plates. For the spawning the kitchen object, that one is already synchronized, so that's already great. So just like this, and trigger the server RPC up here. Alright, so that's it. As you can see, it's also pretty simple logic now that you understand how server RPCs and client RPCs work. That is why I said those previous two lectures were extremely important. Since we already learned how to do all those things, all of this suddenly becomes extremely easy. Okay, so let's test. So here are both builds, and let's see if they synchronize. Both got one plate, and in a little bit, yep, both got 2 plates and so on. Okay, so the spawning of the plates, that timer is indeed working. So let's wait for it to reach the maximum. So yep, goes up to 4 plates. Now if I pick one up, let's see if both of them count down. And if there you go, both of them did count down. So just like this, yep, we do have all of our plates, the plate counter, everything perfectly synchronized. Alright, great. So once again, because of writing some good, clean code, this was super easy to implement. Also because we already took the time to really understand how multiplayer code works and how to use RPCs. Because of that, this is really one of the shortest lectures. As you can see, once you understand how the toolset works, making multiplayer games is actually super simple. Now we want to handle a bit of a more complex counter, the trash counter, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to synchronize the trash counter. This one is very important because we're going to learn how to destroy a network object. Okay, so here let's handle the trash counter right here. This one just destroys whatever you place on it. So I want to be able to pick up something like a tomato, approach it, interact with it, and destroy the object. Now remember how all of the spawn objects, the kitchen objects, those are all network objects. So this is excellent to learn how to properly destroy a network object. So first of all, let's go over here onto the trash counter script. And let's make the usual server and client RPC pair in order to run this logic on the client. So a private void interact logic. Let's start with a server RPC. And then we're going to have another one for the client RPC. Okay, we have both of these. Let's add the usual things. So the server RPC, and for this one, let's add require ownership as false. Okay, we have our usual pair. From the server RPC, we call on the client RPC. And from up here, we trigger the server RPC. And down here, let's just fire off the event. Okay, so just like this, let's leave the destroy self up here to see what that happens. So let's test this. So here, let's test. And as the host, let's pick up an object, go into the trash counter and trash it. And yep, there you go. It did work. It disappeared over there on the client and we have no errors. Okay, so that seems like it's working. But now down here on the client, let's try doing the same thing. Pick up something, go into the trash counter and interact. And nope, we've got an error. The error is exactly what it says, which is destroying a spawn object on a non-host client is not valid, so only the server can destroy objects. If we look over here on the kitchen object destroy self function, over here, yep, we are indeed calling destroy on this game object to actually destroy it. And again, the issue is that only the server can do this. So basically we need to make sure that only the server runs this code. And for that, let's do the same thing that we did down here with the spawning. Let's make a function to destroy it. So let's make a public static void destroy kitchen object, and let's receive a kitchen object. So we're going to destroy this one. By the way, here let me point out that obviously you wouldn't need to make this a static function itself. For the spawn, we made it static because we didn't want to require a kitchen object reference in order to spawn another kitchen object. But over here we already have one, so we could make this non-static to destroy it. I'm doing it just like this, just to match the same pattern that we defined up here. So let's do this, and then let's make a function on the kitchen game multiplayer to actually destroy that object. So over here on the kitchen game multiplayer, let's go down and make a function to do exactly that. So a public void, call it destroy kitchen object. And this one receives a kitchen object. This is the one that we're going to destroy. Then in order to make sure that the destroy code only runs on the server, let's make a server RPC. So a private void, destroy kitchen object, server RPC. And this one, as usual, is going to be marked as server RPC. And we want the client to be able to destroy objects. So let's require ownership equals false. Okay, we have our function. And for this, first of all, we're going to need a reference to what kitchen object we're actually trying to destroy. So in order to pass in that reference, let's pass in a network object reference. So over here for a parameter, network object reference, this is going to be the kitchen object network object reference. So you have this, and then from this one, we can do a try get in order to get the network object. This is going to be the kitchen object network object. And then from this one, we can just do get component and get the component of type kitchen object. And then we have our kitchen object. Okay, so we have the kitchen object, and on this one, this code is only running on the server. So over here, now we can indeed do our destroy self function. And up here, when we got the usual function, let's just trigger the one with the server RPC. Okay, just like this, let's pass in the object reference. So that's that one. We just need to get the network object. Okay, so this is all great. And back here on the kitchen object for destroying it, let's go into the kitchen game multiplayer. Let's access the instance and call the destroy kitchen object function. Okay, so just like this, it looks like it works. So basically this function goes into the kitchen game multiplayer and that one destroys the object only on the server. However, if we inspect over here the destroy self function, we are not only destroying the game object, but we are also clearing the kitchen object on the parent. This is something that we must do on every single client. It's basically the same thing that we had up here when setting the kitchen object parent. We had to make sure that we use a client RPC to broadcast it to all the clients and not just do it on the server. So basically, let's just split this logic into two functions. So this one runs on the server and this one on all the clients. So let's make up here a public void clear kitchen object on parent. And we're going to just run this code. So just like this. So we now have the two separate functions. And then back in the kitchen game multiplayer script, over here, let's just make another one. So this one is going to be a client RPC. Let's make a private void, call it clear kitchen object on parent client RPC. Let's pass in the same network object reference. And let's grab the kitchen object from that reference. And then on this one, we can call the clear the object on the parent. And this one is going to be a client RPC. Okay, so just like this, and up here, before we destroy the object on the server, let's just tell all of the clients, all of them to unparent this object. So let's just pass in the reference just like this. Okay, so now we have all of the logic running on all of the correct places. All of the clients are going to clear the parent, their local parent, and then only the server is going to actually destroy the object, which in turn is automatically synchronized, and all of the clients get that object destroyed. So all that's left is back here on the trash counter. Instead of going through the kitchen object and accessing the destroy self function, Instead of that, let's just use the other one. So let's go inside kitchen object and let's use our static function in order to destroy a kitchen object and just pass in this player.kitchen object. So let's do just like this. Okay, so this is going to handle everything on the client and the server. And then we've got the usual interact logic and we fire the event over here only on the client. Okay, so this should do it. It should clear the parent on all the clients and it should destroy the object on the server, which is also then destroyed on all the clients. Let's test. Okay, so here we are, and if I'm up here on the host and I try to trash something, and if there you go, it does work, no errors, everything is synchronized, and then down here on the client, pick up something and let's try to trash it, and if there you go, it also works, no errors, nothing. Alright, awesome! So in order to destroy a kitchen object, we really just need to run this function instead of doing it through the destroy self directly. Now we can use Visual Studio to find all of the references, so if we right click over here and find all the references, so we see all the places where we're calling destroy self, and basically we're going to need to replace all of these to go through this separate function. We're going to do that as we go through all of the counters in the following lectures. Over here, let's just quickly synchronize the delivery counter because that one is so simple. So here we are on delivery counter script. Here it just calls a function to deliver a recipe on delivery manager. We already synchronized this part. All that's left is really just destroying the plate object. So again, instead of doing this, let's call the other function that goes through the server. So the kitchen object, destroy the kitchen object, and just pass in this kitchen object. So just like this. Okay, that's it, let's test. Okay, so here we are, and if as a host I try to deliver something, if there you go, it does work, no errors. Okay, and now down here, if I try on the client to deliver, and if there you go, it also works, no errors, nothing, so the client can also deliver something and destroy an object, and we have no problems. Okay, great. So here we added yet another very important synchronization to our multiplayer game, and in doing so, we also learned how to destroy network objects. Now we want to synchronize the remaining counters, so let's begin by synchronizing the cutting counter in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to synchronize the cutting counter. This involves synchronizing placing the right objects, then doing the alternate interact action, and handle converting an uncut object onto a cut object. Okay, so let's synchronize the cutting counter. Let's try it first to see what we need to sync. So if I pick up some cheese and I drop it over there on the cutting counter, yep, there you go, dropping the object, that one is already being perfectly synchronized. So that part works fine, but then if I try to cut the cheese, there you go, it works in there, but nothing is being synchronized. So we need to do that. Let's go over here onto the cutting counter, and really let's do the usual server client RPC pair, so just like we did on the other counters. This is going to be on the interact alternate, so let's go down here and start writing our functions. So let's call this the cut object server RPC. And let's make another one, the cut object, the client RPC. Let's add the client RPC attribute and the server RPC. And again, as always, let's make it require ownership equals false so that the clients can trigger the server RPC. Okay, so as usual, from the server RPC, we trigger the action on the clients. And on the clients over here, we run the actual regular logic. So let's just copy all of this and paste it over there. And from here, when we cut, let's just do this. Okay, so just like this, we don't have any errors. So let's try it and see what happens. So up here in the host, if I pick it up and I cut, and if there you go, the cut is indeed being perfectly synchronized, so that's great. However, we actually do have a problem. If instead of the host, if I do it down here on the client, so let's pick up some cheese, drop it on the one down here, and there you go, we have an error. We have the usual null reference exception. Let's actually swap the order so we can see it up here in the editor. Okay, so now I have the host down here and the client up here. So on the client, go and drop it. And there you go, there's the error, the null reference exception. And let's see what is this line. This line is throwing in null reference exception, and just by looking at this, we can immediately tell which one of these is actually possible of being null. And the answer is over here, the getKitchen object. This is the only one that can possibly be null, which we're then accessing and returns null, so that has our exception. And the issue that we have here is very, very important. Basically, the issue is that in single player, all of this code, this will all run sequentially right away, whereas in multiplayer, some code, like for example using RPCs, that will not run immediately. Basically, the issue that we have here is that we are changing the parent over here on the kitchen object that the player is holding, so that makes sense. But while in single player, and this changes the parent right away, so then the code down here, this kitchen object on this counter has already been switched. So when the code gets down here on the host, that is not going to be null, so that is correct. However, in multiplayer, the kitchen object will only change parent when the message goes to the server and back. So when the client is running this line, this code, modifying the kitchen object parent, this one isn't going to handle immediately. However, even as that message is being sent through the multiplayer netcode, even through that, this code is going to continue executing, so when it gets down here, that message hasn't yet reached the server, so this object that is on the player is still going to be on the player by the time we get down here. This is a very, very important thing you always need to be very careful with when making multiplayer games. You have to remember when the functions run. So on the host, all of the code will run in a certain way, whereas on a client, things might take a bit more time. So that is something you always need to keep in mind. Here, thankfully, the solution is actually very simple. We don't really need the object to change parent. All we're doing down here is accessing the exact same object, so we can just cache the object up here, and we don't mind that it takes a little bit of time to change parent. So we can just go up here, define the kitchen object, and go into the player and get the kitchen object. So then we take that one and we modify the parent, and then down here we use the exact same reference, just like this. This way the client code is not waiting, not expecting the server code to run immediately. This way it will always work. Okay, so let's test. So here, let's start a host down here and a client up here. Okay, so now on the client, if I go pick it up and I drop it, and there you go, it does work, no errors. Okay, great. Now if I cut on the client, yep, there you go, that action is also already synchronized. Same thing on the host, if I go up there and I cut that object, yep, there you go, everything works perfectly. All right, awesome. So everything is working great so far. However, if I finish cutting on either of these, and there you go, we have an error. This is showing an issue with the kitchen object parent, but in reality, this is really because when we finish cutting, we try destroying the previous object, but we are still using the old method, which no longer clears the parent. So this is really related to destruction, not really parenting. The solution is the same thing that we've already done so many times. So let's just go down to where we are destroying the object. So it's over here, we are calling destroy self. Instead, let's go through the kitchen object and destroy the kitchen object and pass in this kitchen object. Okay, so now destruction should be working. Let's see. So here we are, and I'm going to test just with a host here, no clients. So just with one host, let's go there, pick it up, go there, drop it, and let's cut 1, 2, and 3 times. And yep, there you go, everything seems to be working perfectly. However, now if I test with a host up here and a client down here, and on the host, let's go there and cut it, 1, 2, there you go, everything synchronized, cut one more, and there you go, we have an error. So again, always remember that when you make any modifications in multiplayer, you need to verify that it works on the host and on the client. So you always need to verify every possible use case. Okay, so let's see exactly what this error is. This one is a much more sneaky issue. Note how in this code here, for running the server and the client RPC, this one is a client RPC, meaning this code is going to run on every single client. So all the clients are going to run all of this code, meaning that all of the clients are going to increase their own cutting process, and all of the clients are going to run this if. So all of the clients are going to basically try to cut the object as many times as we have clients. That obviously creates a conflict when it comes over here to destroying and spawning objects, because these things are only going to happen on the server, but we're going to run it as many times as we have clients. So that is why with just one host, this isn't actually causing problems. But as soon as we have 2 clients, and 2 clients are going to run this code, meaning that both of them will attempt to destroy the same object and then spawn a new object, so we have duplicate logic that is not good. The solution here is basically for the code that we have down here, we really only want to run this once regardless of how many clients we have. So basically, let's split this cutting process testing into another function and make it just a server RPC. So let's go down here, make a private void, call it test cutting progress done server RPC. Let's make this a server RPC with require ownership as false. And then over here, we're actually going to run just this logic. So we also need the cutting recipe, so like this. And then for calling this function, let's just go up here to where we're calling the cut object server RPC, and then let's call the other RPC. Okay, so that way now we know that this function, this code is only going to execute on the server. So it is no longer dependent on how many clients we have. So let's test. So over here, up here, I've got the host. So if I go and I cut, so 1, 2, and 3, and yep, there you go, it does work, it cut perfectly. And now let's go down here and try it out on the client. So let's pick it up, go down there, drop it. And let's cut 1, 2, 3 times. And yep, it also worked. So it seems like everything is working. However, now let's say on the client, I'm going to reuse the cutting counter up there. So let's pick this one up. Let's drop another one, paste it there. And now if I cut, and there you go, look at that issue. The client cut just once. Over there, the progress is correct. But on the server, look how the process is already maximized and the object was immediately cut. Basically, the issue is that the host is not resetting the progress. If we look back in our code here, when we're placing an object on the counter, we're going to run this code. So first of all, for changing the parent, this is already going to be automatically synchronized. But then down here, setting the cutting progress to 0, this one is not automatically synchronized. So as usual, we have two options. We could just make this a network variable, or let's just keep using the usual server client RPC pair. So let's go down here to make that function. A private void, call it interact logic place object on counter. This is a server RPC. So it's a server RPC with require ownership as false. Then let's make the corresponding client RPC. So let's go for the client RPC and the exact same name, just end with client RPC, okay? Then from this one, we run the other one, the client RPC. And now on the client RPC, we're going to run the regular logic. Again, the parent, that one is already automatically synchronized. So let's just cut this and paste it down here. And for the server RPC, let's just run it all the way up here. Okay, so like this, so we run the server RPC, that one then runs this code on all the clients. And over here, we actually have an issue with the kitchen object reference. So we could pass it in, but actually we're really not going to need this at all. We're using it down here to set the cutting progress max. But the progress normalize only is going to be 0 because cutting progress is 0. So instead, let's just not do that and just pass in 0f. Okay, that should do it. Let's test. Okay, so up here on the host, let's drop it, cut 1, 2, 3. Okay, great. Now on the client, pick it up, go there, drop it, and cut it. And there you go, the progress is synchronized, 1, 2, 3, and there you go, it does cut perfectly. All right, awesome. With this, we no longer have any errors, and our cutting counter logic is all fully synchronized. Like I mentioned, one alternative here would be to synchronize the cutting process using a network variable, and that's exactly what we're going to learn about with the stove counter in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to synchronize the stove counter. This is the more complex counter, but thanks to what we have already learned, this isn't actually going to be too difficult. We need to synchronize the timer, the object conversion from uncooked to cooked to burnt, and handle the various states. Okay, so let's handle the stove counter. We can start off with a quick test. So I'm going to create a host down here and a client over here on the editor. And now on the client, if I go ahead and I put something on the stove, so let's drop it. And there you go, we have an error right away. Here it is on this stove counter line, so let's see it. And the issue is really the exact same issue that we saw previously, which is the host is going to run this code sequentially, but on the client, setting the parent is going to take quite a bit of time. So when it gets down here, this kitchen object hasn't yet switched parents. So let's do the exact same solution. Let's just cache the kitchen object. So kitchen object, and we grab the player, get the kitchen object. Then we use this one both in here as well as in here. Okay, so that will fix that issue. Then we need all of the clients to know what frying recipe was selected. So let's make the usual server client RPC pair for our interact logic. So let's go down here and make those functions. So a private void interact logic place object on counter server RPC. And the same thing for the client RPC. So just change this. Let's add the usual client RPC attribute and the server RPC, as well as require ownership as false. Okay, our standard functions. Then on the server RPC, we call the client. And up here, when we are dropping something, so in here, we're going to trigger our server RPC, okay? So let's copy this local code, cut it from here. Let's go down to the client RPC and paste it. Okay, now in order for this to work, we need some reference to the kitchen object, or we can also grab the frying recipe just by using the kitchen object SO. So basically those are the three options we have. We could add a parameter here and synchronize directly the frying recipe SO. We can synchronize just the kitchen object or the kitchen object SO. All of those options are valid. Let's go with the kitchen object SO method since we already have these functions on the multiplayer class to convert into an index. So here on the kitchen game multiplayer, we already made these functions to convert an SO into an index. Let's just make them public so we can call from there. So both of these make them public, okay? So now back in here for our RPCs, let's receive an int for the kitchen object SO index. We have one here and one down here, and then we get there. Okay, so now up here when we are calling the server RPC, let's just go inside the kitchen game multiplayer. Let's access the instance and get the kitchen object SO index. And now we pass in this kitchen object dot get kitchen object SO. Okay, so that way we get the index. And then down here, we really just need to convert the index back into the kitchen object SO. So the kitchen object SO, we're going to go into the kitchen game multiplayer, the instance, get the kitchen object SO from the index, and pass in the index. So we have this, and then we can grab the frying recipe SO based on this. Okay, great, no more errors. With this, we are now going to have the same frying recipe SO synchronized across all of the clients. So let's test it out and see if the client can now place an object on the stove. Okay, so let's put the host down here, the client up here, and on the client, let's pick up some meat and cook it. And there you go, it did work, no errors, both of them are being synchronized. And if we wait until it gets cooked, and then we've got an error. So this is actually going to be the same issue that we already saw previously, which is destroying the object. However, before we actually solve that issue, let's solve another issue. Right now, all of the clients, they're all running their own timer on the stove. We really don't want that. We just want one source of truth. So only the server should be handling the stove timer. And when we have that, then we're going to need to synchronize the same timer to all the clients. So technically, like we've been doing, we could use a client RPC, fire it on every single update in order to update the clients. That would work, but that would be quite wasteful. So instead, let's use the other method for synchronizing data. Let's use a network variable. Again, I covered them all in detail in my dedicated Netcode for Game Objects video. Go rewatch that section to see everything that network variables can do. So over here, if we scroll down on the frying timer, instead of using a simple float, let's use a network variable of type float. Then for network variables, we need to initialize them, so let's do new network variable and start off on 0f. For the other parameters, we can leave them all as defaults, so everyone can read and only the server can write to it. So now what we need is to fix all of these errors. And first of all, before dealing with any actual errors, over here for the update, we only want to run this on the server. So let's set if not is server. If this is running not on the server, let's just return. Okay, so this logic is only going to run on the server. Then for increasing the value, we want to increase by the same amount. The only difference is when working with a network variable, we increase it by .value, okay? Then for the onProgress changed event, if we leave it like this, then the event is really only going to be fired on the server and not on all the clients. So you need to make sure that all of the clients fire off this event whenever the frying timer changes. Now thankfully, the network variable itself, this one also fires off an event when variable changes in any way. So let's listen to that, and usually for listening to an event you would do it on awake or on start, but remember we're working in multiplayer, so when listening to a network variable event, you really should listen to it on a on-network spawn. Like we already saw, this is kind of like an awake but for network objects, so let's do a public override, and let's override the void on network spawn. So let's override this one, and over here we can listen to it, so let's go into the frying timer, and it's called the on value changed. And now this one is actually just a delegate and not an actual event. So the helpful Visual Studio shortcut where we hit tab and automatically writes, that doesn't work here, so we need to manually write it. So let's just do a private void, call it frying timer, then underscore on value changed. So pretty much the same naming format. For the parameters, we're going to have a float for the previous value and another float for the new value. So we make this function and we assign it to our event. Okay, great. And now over here, we can actually run the onProgress changed event. So let's fire off this one just like this. Then instead of using the frying timer, we use the frying timer.value because again, all of the clients can read this network variable. However, over here, we actually still have one potential problem. That problem is going to be if the frying timer changes in any way, like it gets initialized before the frying recipe SO is set. If that happens, this one is going to fire off a null reference exception. We don't want that, so let's just add a simple null check. So let's define a float for the frying timer max. And basically we just check if the frying recipe SO, if this one is not null. If so, then let's use the frying recipe SO.frying timer max. But if it is, then let's use 1f. 1f basically it's the default since over here we're dividing by it. If you divide anything by 1, you always get that something. Also, by the way, if you're not familiar with this code, this is called the if shorthand. So what we're doing here is pretty much the exact same thing as this. So if frying recipe SO, if it is not null, if so, then the frying timer max becomes the frying recipe SO dot frying timer max. And if not, the frying timer max becomes 1f. So this line up here is doing the exact same code as this down here. So just a much more simpler way of doing a simple if. So let's do that just like this. Okay, great. Now let's continue our update logic. Let's fix all these errors. So again, on the frying timer, we need to access the value, okay? Then here we have the problem with destruction, but again, we're going to handle that in a little bit. For now, let's just fix the rest of the errors. So let's scroll down and find them. Okay, so down here, this one is .value. And same thing over here for resetting the timer, this one .value. But again, here we are working inside a client RPC. and the network variable, only the server can write to it. So if we do it just like this, we're going to have an error because the client cannot write to this variable. So let's just make sure to do this on the server RPC instead. Then also for the on-progress change, this one is automatically going to be fired whenever we modify the frying timer, so we can actually also remove it from here. Okay, so no more errors, so everything should be working. So let's test. So up here on the client, let's pick it up and drop it, and there you go, everything is nice and synchronized. Okay, so great. So now let's fix this error when destroying the cooked object. So as usual, the fix is super simple, exactly like we've already done. So let's go down into the update. Okay, so here we've got the frying, and we are calling destroy self. So instead of that one, let's use the other function. So kitchen object, let's destroy this kitchen object. So this one down here, let's destroy this. So that is going to handle that. Let's see where else we're destroying. It's also down here on the fried state, going from fried into burned. Let's also call the same function. Okay, so let's test. So here we are, let's pick up some meat and cook it, and there you go, the timer is synchronizing. Let's wait a bit and see if it actually cooks. And yep, there you go, it did work. Alright, the object was indeed replaced. Okay, so that's great, except we can already see on the timer, not exactly great. Basically what happened is that the burn state isn't really synchronizing, but at least the object transformation did work, so that part is great. So we have the correct object, just not yet synchronizing the actual states. So for synchronizing the burn state, we really need to synchronize two things. First of all is the burning timer, just like we did the frying timer. And then we're also going to need to synchronize the state itself. So first let's handle the burning timer. So exactly like the frying timer. So up here, a network variable of type float. And let's start off on 0f. Okay, there it is. Then down here, let's listen to the same changed event. So on the burning timer, let's listen to the on value change. We're going to make another function. So burning timer. On value changed. Let's just copy this and just replace all of the names. So this is the burning timer. And for here, we have the burning timer max. And we're going to access the burning recipe SO. And from the burning recipe SO, get the burning timer max. So we have that. And on the progress normalize, just frying timer, replace this with burning timer. And up here, I actually made a mistake that I only noticed just now. We made this one to avoid any null checks over here with the frying recipe SO, but then I forgot to use this one. So let's actually remember to use that one. And down here, same thing, let's use this one. Okay, that's good. Again, make sure all of the references have been replaced. So you can do a quick search for frying and make sure there are no frying references down here. Okay, great. Now let's continue solving all of the errors. So let's go down. For the burning timer, we need to modify the value. The progress change, this one is going to happen automatically, so move it. For the burning timer, this one is the value. Okay. And finally up here, when modifying, also modify by the value. Okay, we have no more errors. Like this, the client will indeed synchronize the burning timer, but it will not synchronize the state. Now, since we used an enum for our state, we can easily make this a network variable. Enums are serializable. So we can just go up here, make this a network variable of type state, and let's initialize it over here instead of doing it on start. So let's initialize on state.idle. So let's do this instead of doing it over here on start. And now let's fix all of the usual bugs. So instead of doing a switch on state.value. Then for modifying the state, so state.value. For firing the on state change event, let's do the exact same thing. So let's go up here onto the state and the on value change. Let's do one, so state on value changed. Let's make this function. So down here on a private void, state on value change. So we've got a state for the previous state and a state for the new state. So you have this, and over here on this one, let's fire off the local event. So let's cut this and paste it in there. So you have this state.value. Okay, so that is going to fire off all of the events locally, so that's great. Let's keep solving all the errors. So over here, all this logic is already working great. All right, now over here on fried, let's modify the state.value, and we don't need to modify the state.changed. And over here for the progress change, we're doing this basically just to hide the progress bar. It gets hidden automatically if the progress normalizes 0f. But again, over here, this code is only going to run the server, so we want to run this on every client. So let's actually put this on the onState changed event, but only when the state is either burned or idle. So let's go up here onto this one. Let's do an if the state.value, if this one is state.burned, or state.value if we are on the state.idle. So if you are on either of these states, then let's fire off the progress normalize 0 just so we hide the bar. Okay, great. Now let's fix the remaining errors. So down here on the interact, when we are resetting the state, let's set state.value back into idle, and let's get rid of the events since those are already happening. Then over here, same thing, state.idle, and get rid of this. And down here on our server and client RPCs, modify the state, so state.value, and the on-state change, get rid of this. Except of course, always remember that network variable, this one can only be modified on the server, whereas here we're working inside a client RPC. So we need to make sure to do this up here, just like that. So by now we can probably just rename this function since all this is doing is setting the frying recipe SO. So let's actually rename this. So let's use the Visual Studio shortcut, just right click and let's go ahead and rename this. Let's call this set frying recipe SO client RPC. Okay, so that will set the frying recipe SO. And then we're also going to need a function just like this for setting the burning recipe SO. So let's just copy this and do the exact same thing. So this one's going to set the burning recipe SO. So get burning recipe SO with input, and this is the burning recipe SO. Also, by the way, one note, several people commented on my single player course, and yes, you could refactor this code to have just a single scriptable object to define both the frying and the burning. You could definitely do that, that is an equally valid option. I just went with this pattern to keep the states a bit more separated so you could potentially expand upon this with more states and more custom logic for each state. Okay, so now let's just call the function to set the burning recipe SO. Also down here, let's fix this last remaining error. Okay, so for setting the burning recipe SO, that one is going to be up here. So the update, the frying, we're going to get the burning recipe SO, but just like this, it will only happen on the server. We want it to happen on every single client. So let's go ahead, call this. We go into the kitchen game multiplayer, the instance. Let's get the kitchen object SO index. And let's pass in this kitchen object SO. Okay, so just like this, we've got no more errors, so all of this logic should now be working. So let's test. So up here on the host, let's cook something, and there you go, it is being synchronized. Okay, great. Let's wait for the timer to reach the end. And yep, both objects were synchronized as well as that. And there you go, once it gets there, it also spawns the burning timer warning, and yep, both of them get burned and both of them stop. Okay, so with that, everything works perfectly. Awesome. Now we just have one error. If we go down here on the client and I try to pick up something, there you go, got an error, invalid operation. Basically, it's telling us that the client is not allowed to write to a network variable. If you look in the code, it's over here on the interact function. When we go down, when there's a kitchen object here and the player tries to pick it up. So this is the issue right here. We have the client trying to set the state value. Again, only the server can do this. So let's go ahead and do this through a server RPC. So a private void set state idle server RPC. Make this a server RPC with require ownership as false. And over here, we just set the state.value just like this. Okay, that's it. Super simple change. Now let's test. So down here on the client, let's go ahead, pick up some meat, drop it, cook it, and there you go, it is working. Let's wait for it to cook a little bit, and there you go, it's cooked. Now pick it up, and there you go, it works, no errors. Same thing up here on the host, pick it up, drop it, everything works perfectly. Wait for it to cook for a little bit. And there you go, it's almost burned, there you go. Now if I pick it up, and yep, there you go, it does work, no errors, nothing anywhere. Alright, so with that, we have essentially all of our counters, all of them fully working. All of the multiplayer state for all of them, all of that is being perfectly synchronized. The interactions work perfectly, except for one thing, which is adding an ingredient onto the plate, so let's handle that in the next lecture. Hey again, quick intermission. You're past the halfway point, so congratulations. Looking at my regular course stats, it seems about 80% of people give up by this point, so great job on sticking with it. And actually, if you are following this course, I'm assuming that you've also completed the single player course, so really double congratulations. I really hope these two courses have helped you out a lot in your game dev journey. Now my question is, are you finding this course to be more difficult than the single player or just about the same? Remember to post in the comments if you need extra clarification on anything and I'll do my best to answer. Also check out the website to see what questions others have asked. And of course, remember this is your learning journey, you're not competing with anyone but yourself. So take your time, rewatch some lectures if you need to, just focus on learning. Okay, let's go to the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to synchronize the logic to add ingredients onto the plate. Okay, so right now we already have quite a lot of the game logic working in multiplayer. I can pick up items and it's synchronized, I can drop them, synchronize, I can cut some objects, I can cook some meat, everything is working great. The one big thing still missing is picking up ingredients onto a plate. if I go ahead and I pick up a plate and then try to pick up some cheese. And yep, it didn't really work. On the host, it looks like it works, but down here, nope, there's no synchronization, so this client does not know that cheese was added to that plate. And if I try doing it down here on the client, so try to pick it up, and there you go, the client does itself get an error. Okay, so let's fix this. For handling that logic, it's on the various counters, so let's go first over here onto the clear counter. Let's go down to where we are seeing if it is a plate. So if the player is holding a plate, then it's going to call this function to try to add an ingredient. So let's see this function. This one goes over here, does a bunch of validation, and then adds the kitchen object SO onto the list on the plate. So we really just need to synchronize this. And as usual, we have our two options. One option would be to make the list itself, make it a network variable, or alternatively, there's actually a network list. That would work. We would need to make the kitchen object SO serializable, which we could do since we already handled the index functions. So that would be one option. But perhaps another simpler option is simply to use the usual server-client RPC combo. So let's do exactly that. Let's make those two functions. So let's make a private void, call it add ingredient server RPC. And we're going to have another one for the client RPC. Let's add the attribute, so client RPC, and up here the server RPC. And as usual, we want the clients to be able to call this. Okay. Then up here, when we have our interaction, let's trigger the server RPC. And down here on the client RPC, we do this and pass it into that. Okay, so that's our simple logic. Now, obviously, down here, we need a reference to the kitchen object SO. So as usual, let's receive an int for the kitchen object SO index. Let's also receive it on the client RPC. Over here, we pass it in. Then down here, let's go into the kitchen game multiplayer, the instance, and get the kitchen object SO from the index. And let's grab it from this index. And this is going to be our kitchen object SO, kitchen object SO. And yep, like this, the rest of this code is indeed working. So now up here, let's just grab the index, go into the kitchen game multiplayer, the instance, and get the kitchen object SO index of this kitchen object SO. All right, so that's it. All of this is pretty simple. Now back here in the clear counter, so basically we already handled the synchronization of the try add ingredient. So the next thing is just over here, destroy self. We need to use the other function. So let's just replace this. So go into kitchen object and call destroy kitchen object. And let's pass in this kitchen object. Okay, so that's it. And same thing down here. Let's also replace this function and destroy this kitchen object. Okay, so just like this, all of the logic should work. So let's test. So first, let's test up here on the host. Let's pick up some bread and drop it on a clear counter. Okay, now let's pick up a plate and try to pick up the bread. And if there you go, it did work. It picked up the bread, and the client down there does see that this host is carrying the bread. Okay, great. Now let's do the same thing on the client. So down here on the client, pick up some bread, drop it on there, pick up a plate, go and grab it. And there you go, it does work, and both of them are synchronized. Okay, great. Now let's do the opposite. So let's drop the bread in there. Let's pick up a plate, drop it in there, pick up some bread, drop it on the plate. And yep, there you go, it does work. And same thing over here on the client. Pick up some bread, drop it, pick up a plate, and let's go ahead, pick up the bread. And yep, there you go, everything does work. All right, awesome. So once again, because the power of writing good clean code, we didn't really need to modify many things. We really just modified one single function and everything already works perfectly. Now really all we need to do is just apply the same logic to every single counter. So let's go here onto the cutting counter, and we have our interact function. Okay, we have the usual interaction, and over here we've got the plate logic. For this one, we already handled the try and ingredient, so that one is already going to be synchronized. So really all we need is just go into kitchen object and use the other destroy kitchen object method. So let's just use this one like this. And yep, that's it. Nothing else we need to change. Next is over here on the stove counter. So again, let's go down into our interact function and let's find where the player has a plate. And really the same thing, the adding the ingredient, that's already synchronized. So let's just replace the kitchen object.destroy kitchen object. Just replace this one with that one. And then over here, we're also setting the state. So this one is going to give the same error that we saw previously. The client cannot set the state. So that is why a while ago we made the server RPC. So let's just also replace this like this. Okay, so that should really do it. These are the only 3 counters where the player can pick up something onto a plate. So everything else should already be working. Let's test. So up here on the host, let's cook some meat. Let's also cut some cheese. So both counters. Now pick it up. Let's pick up the cheese. And yep, there you go. It does work. It was synchronized. Pick up the meat. And yep, it also works. Okay, great. And then down here on the client, let's do the same thing. So cut some cheese, it works. Cook some meat, it does work. Pick up the cheese, and yep, it does work. Now pick up the meat, and yep, it also works. Both of them are perfectly synchronized. Then we can even make a delivery. So let's pick up some bread, delivery over here, and yep, there you go. It does work perfectly. All right, awesome. So with this, the plates are fully working. Pretty much everything is perfectly synchronized. Next, we want to sort something pretty basic, handling some player collisions. So let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to handle player collisions. Okay, so a lot of the game is already working great. I can cook some meat, cut some cheese, and so on, so everything works perfectly. However, one thing we don't have are some player collisions. So right now, the players can just phase through one another. Now, this is actually a design question. For some co-op games, they usually have no collisions at all, but some of them do have them. And for this game, I think either approach works. If you want to make it more casual and easier to play, then no collisions works fine. But if you want to make the game a bit more challenging, a bit more rage-inducing in a good way, then adding collisions is a simple way to do that. That allows you to be more complex with your level design by making some small levels where, for example, one player can only go through one tiny corridor. So here, let's add that, and it's up to you if you want to keep it or remove it. Now, thankfully, due to the way we built our game, this is actually going to be super simple, so this is going to be yet another quick lecture. Over here on the player script, if we go down into our handle movement function, so let's go down to this function, so here it is. For this one, we are already testing for collisions. We're doing a capsule cast to see if we can collide with something, to see if we can move or not. So this code is already working, but actually let's first refactor this code to be a bit more adaptable. I saw some people trying to expand upon the single-player game by adding some trigger colliders to do some extra logic. And like this, using this capsule cast, this cast will hit every single collider, so that means all of the counters as well as any other colliders that you probably don't want to hit. So to solve that, let's use a layer mask to make sure we only collide against things we want to collide with. So the layer mask is going to be exactly like we did up here on the handle interactions. We made a layer mask just to be able to hit some counters. So let's do the exact same thing down here. Let's look at all the versions of the capsule cast to see which one we can use. So let's use this one down here, version number 4, which is exactly the same, so it has the same parameters, and at the end we have a layer mask. So at the end we can just add, and we can just reuse the counters layer mask. So let's do that, and this way this capsule cast will only hit things on the counters layer. Let's make sure to apply it here, as well as these two other capsule casts. So on this one, and also the one down here. Okay, so let's do a quick test just to make sure that nothing really changed. So here I am, I can move around, and yep, it is indeed testing for collisions. Okay, so far so good. Except now, if we wanted, we could add some things. So let's say I would add a cube. This one has a box collider. I don't want any visual. So let's say this was just a trigger collider. So I wanted to place it somewhere in here. As long as this one is not on the counters layer, as long as it isn't, then over here on the game, I can move around, and yep, there you go. There's no issues. I can go through that invisible cube. So this allows you to expand upon the game in order to add some more logic based on colliders. Okay, great. So back to our original goal. Let's add some player collisions. Right now, this is only testing against counters, and all we really need to make this work is also test against players. But for the interaction up here, we still only want this one to hit just the counters. So really, let's just make 2 layer masks. So up here we have the counters layer mask, and let's go with another one. And for this one, let's go with a more generic name. So let's say collisions layer mask. Okay, so we have this. We're going to set this in the editor in a little bit. Let's just go down here and really just replace it with this one. So replace it on that one, and over here on this one, and then down on this one. Okay, great. That's it. There's nothing else we need to change in the code here. And now if we go in the editor and we select the player prefab, and yep, down here we have the collisions layer mask, so let's make sure to include the counters. And now we also want to include the players, so let's go into our layer, let's add a brand new layer, let's call it the players layer. Then over here on the player game object, let's put this one on the players layer. And for this case, let's not apply it to all childs. Let's leave the children on the same layer they are, so let's apply it to this object only. Okay, so this one is on the players, and on the collisions layer mask, let's just include that one. Okay, that's it. Now really all we need is just a physics shape, and we can use whatever shape we want. Since we made the movement work with the colliders on the counters, which are really box colliders, over here let's use the same thing. Let's also use a box collider. Let's actually go inside the player prefab so we can scale it. And now here, just a quick tip. Usually for physics colliders, you want to make them a bit smaller than the visual. Usually that makes for a better experience for the players. So up here, this one is a bit too big, so let's make it a bit smaller. So on the X, let's put it on 0.7. On the Y, we can live with 1, and Z of also 0.7. So it's a bit smaller than the actual visual. Now let's also lift it up by half of the height. So let's put it up on 0.5. So there we go, it is exactly like that. By the way, important, make sure that the collider is essentially touching the 0 on the Y. So up here, don't lift it up by more than half the height. That is because at the bottom, that is where we're finding the cast on the player. If you lift it up by too much, it might not hit it depending on the size you use. Okay, so that's really it. If we test it just like this, let's just exit, save the prefab, and let's test. So here I have 2 players, and moving around, it still doesn't go through the counters. Okay, great. Now if I go into the player, and there you go, now it no longer goes through the players. Alright, so that's great. It works over here on the host, and down here on the client, same thing. It also does not go through. Okay, awesome. Now, one more minor thing. For the collision detection, for the player shape, we used a capsule. Now, in most cases, this is actually a good shape for the player, but due to how we handle the collision detection here, how we handle that code for checking the X and Y in order to make it easily slide around, this method is indeed great, but it works best on straight colliders. Meaning that if I try to hit the player on the corner, like this, there you go, look at that, the player is stuck. I try to move straight down or straight to the right, and nope, it does not work. Basically, that's because the capsule collider, that one has a round edge. So if we hit perfectly on the corner, based on the code that we have here, it will not slide around, it will just be stuck. Some people mention this in the Singleplayer course because they made the map different from mine. In my map, there's never an issue because there are never any corners. But if you do have corners, then yep, swapping it out makes sense. So one option would be we could modify the collision detection code to work better against some corners. We could use the collision normal to move or something like that. Or perhaps a similar approach, let's just refactor the code to, instead of using a capsule cast, to use a box cast. That way we don't have any round corners. So back in the player code, instead of using a capsule cast, let's use a box cast. Then just need to modify the parameters. Let's use this one, version 6. So first parameter is the center, so let's use transform.position. Okay, great. Then the half extends. For this one, let's use vector3.1. This is just a shorthand for writing 111. So let's do this multiplied by the player radius. That way we have the box cast size. So next we have direction, so that is going to be the move there. Then we have the quaternion. This is the rotation for the box cast. We don't want any rotation, so let's just use quaternion.identity. This essentially means no rotation. Then we use the move distance and the layer mask collisions. Okay, that's great. So this is exactly the same thing. So let's use the exact same parameters down here. So we use a box cast. Let's use the same version, version 6. So we have that. Then for this one, we have the vector3.1 times the player radius. Then the move the x. Then we have quaternion.identity. And then we have the other two. Okay, great. And same thing down here. Also a box cast. Then replace the point 2 with this one. Then we have the move there. And again, quaternion identity, just like this. Again, make sure you don't make any mistakes on the parameters. I saw a bunch of questions in the Singleplayer course because a bunch of people got confused over here with move the x and move the z, so make sure you don't make any mistakes. So that's it, let's test this. Okay, so here we are, and if I touch the player from a corner, and there you go, it no longer gets stuck. So if I go straight into a corner, now the code does behave the same as we have up here on the corners. So it goes in and it slides around either up, down, left, or right. All right, awesome. Okay, so that's it. With this, everything already works perfectly. Just one thing, which is the fact that when they spawn, they both spawn in the exact same position. So let's just make a minor change to make them spawn on different positions. This is also super simple. Over here on the player script, let's go down into our onNetworkSpawn function. And over here, to know the player name, we can just access the owner client ID. We can basically use this as an index in order to access a list to get the position. So let's remove that just so it compiles. Let's go up here, make another serialized field. A private, let's make it a list of vector3 and call it the spawn position list. Then back here in the editor, let's select the player. And on the player script, let's put in 4 elements. So 4 positions, we're going to have 4 players. For the first one, -2, 0, 0, then +2, 0, 0, then -2, 0, and -2, and +2, 0, -2. So we have 4 positions. And over here, it's pretty simple. So we just set the transform.position, and we go into the spawn position list and access it on the index of the owner client ID, And this one is a long, not an int, so we can just cast it down to an int. Okay, that really should do it, so let's test. So up here, connect as the host, and yep, it's on that position. Down here on the client, and yep, there you go, it is on that position. Alright, great. Now I should point out that this code actually causes an error if a player disconnects and another one connects. That is because the owner client ID, this one is not really sequential. But don't worry about that for now, we're going to refactor this code later on when we handle the lobby and the character selection. Okay, so here we have our perfect collisions between all of our players. Again, like I said, this is a design decision, so it's up to you whether you want to keep it or disable it. You would just go into that player mask and either include or not include the players, so that's it. And with that, we have pretty much our game completely synchronized. The one thing we still don't have synchronized is the game state, so the countdown, starting to play, game over, and so on. So let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to synchronize the game state. So that's the waiting, game start, game timer, and game over. Okay, so we already have quite a lot synchronized, but one of the main things that is not synchronized is the game state. In the beginning of this course, we skipped the states just to make testing easier, so let's get those back now. Let's go over here onto the Kitchen Game Manager, and let's remove the auto start code, this debug trigger that we added quite a while ago, so let's get rid of this. And for the countdown timer, let's reset this one back into 3F, and that's it, nothing else. Okay, so let's test. Okay, so it starts off, and yep, it is indeed showing the controls, and as I interact, yep, there you go, it starts the countdown. Okay, so it's back to normal. Except obviously now this one is actually playing the game, where this one down here is still staring at the controls. We want to synchronize these two states. Basically, we want to start off by showing all of the players the controls window. Then as each player presses the interact action, instead of going to the countdown on that player, instead of that we want to go to another state, waiting for all of the players to be ready. And then when all the players are ready, then we do start the countdown. So let's do that. Over here in the Kitchen Game Manager, basically we need another state for when the player is ready and waiting for the rest. So one option could be to make another state here for waiting for the players to be ready. However, actually in a little bit we're going to synchronize this state across all of the clients in order to synchronize the countdown, the game playing, and so on. So since we're going to synchronize this same state across all the clients, we cannot have one that is different on a per client basis. So instead of adding a brand new state right here, let's just make a simple boolean. So a private bool, let's call it is local player ready. So we have this, and then down here when we have the interact action, instead of going straight to countdown start, instead of this one, let's just set is local player ready into true. Okay, so now we want to hide the tutorial when this player is ready. So for that, let's basically fire off an event and then expose this boolean. So first of all, let's expose this boolean. Let's go down here and make a public bool is local player ready. And we just return the is local player ready. Okay, so we return this. And then up here, let's make an event. So a public event handler. Let's call it on local player ready changed. And then down here, when we have our input over here, let's invoke this event. Okay, so we have this event. Now let's go over here onto the tutorial UI script. And previously we were listening on the state changed, and we were only hiding the controls when the countdown was active. Now we don't want this one, so let's go into the Kitchen Game Manager instance. And this time it's the on local ready player change. So let's just rename this to the Kitchen Game Manager. Okay, we have this function. And then over here, if, let's go into the Kitchen Game Manager, the instance, and let's test if the local player is ready. If so, then let's hide this. And we no longer do anything on the state changed. Okay, yep, just like this. And now, by the way, some of you might be thinking, if we have this event, why do we need to test for the boolean? Couldn't we just hide it when we get the event, regardless of any boolean? And yep, that would indeed work. The only reason I did it this way is just in case you want to add the ability for the player to unready themselves. In this case, I made it stay stuck in ready, but you could easily modify this to let the player go back. By combining the event and the boolean, you can easily add that feature. Okay, so with this, the tutorial UI should hide. Now we just need some visual to tell the player that they are waiting for the others. So back in the editor, let's go inside the canvas. And let's start off by duplicating the tutorial UI. So let's duplicate this and let's zoom in the camera, put it in 2D and go in there. Okay. For this one, let's call this the waiting for other players UI. And let's put it on the same sorting order. So just under the tutorial UI. Okay, like that. And over here, we basically just want some text. So let's just keep the same background and get rid of all these objects. And instead, let's create a new UI text. And for the text, let's say waiting for players. Let's put it in bold. Let's put that one, put it on overflow down the center. Let's put it in black and lift it up a little bit. Okay, so very simple window. Now let's make the script to run this, so with the exact same name. So let's go into our UI folder, and let's create the brand new C# script, waiting for players UI. Then on the game object, let's not forget to get rid of the old tutorial UI. Instead, let's add this one, so waiting for other players UI, and let's open this script. Over here, let's begin by making the usual show and hide functions, so private void show, and then a private void hide. And over here, game object set active into false, so the same thing we've already done so many times, okay? So we have this. Now let's listen to the local player ready event, so let's make a private void start. Go into the kitchen game manager, and let's listen to the on local ready player changed. Let's just rename this to give it a proper name. Okay, so we have this one. Then let's do the same thing. So the instance is the local player ready. If so, then let's show. Okay, so that handles the showing, which by the way over here on start, we listen to the event and then we hide it. Okay, so it will start off hidden by default and then show when the player is ready. Then we need to know when to hide it, and that is going to be when the countdown actually starts. So let's also go into the kitchen game manager instance, and let's subscribe to the on state changed event. So let's go kitchen game manager. Okay, so we have this event, so when the state changes, let's test if the event is on the countdown to start active. So if the countdown is active, then let's hide this window. Okay, so that's it, pretty simple. Let's do a quick test. So here we are, and both of them are looking at the controls. Now I press interact, and there you go. Instead of starting the countdown, now it is waiting for players. Same thing down here, interact and waiting for players. Okay, so far so good. Now we basically just need to check if all of the player states, if all of them are ready in order to know when to start the game. Now there are actually many ways we can do this. Basically, we just need to synchronize a simple boolean to know when a player is ready. The only tricky part about this is it depends on how you want to handle the number of players. So do you want the game to forcefully only work with 4 players, or maybe 2, or make it work with any number? That's another design question that will impact what data type you use. So over here, let's make it work with any player amount. Back in the kitchen game manager script, over here, let's use a dictionary. That way we can support any number of players. And also the reason for using a dictionary instead of a list is because the player client ID is not necessarily sequential. For example, if one player connects and then disconnects, it will not reuse that ID. So if in the end you end up with 4 players connected, it is not guaranteed they will have IDs 0 through 3. So because of that, a dictionary using a client ID for the key, that one is a much better approach than using a network list. Okay, so let's build our dictionary. So a dictionary for the key, and let's use yolong, which is the type for the client IDs. And for the val, let's use a simple boolean. So let's call this one the player ready dictionary. Okay, so we have this, and over here on awake, let's initialize our dictionary. So by default, all of the keys with all of the possible client IDs, they're all going to be unset. Then down here, when we have the interact action, when we set this player to ready, over here, let's tell the server that this player is ready. So for that, as usual, let's make a server RPC. So a private void, let's call it set player ready server RPC. And as usual, mark this as a server RPC with require ownership as false. Okay. And now in order for the server RPC to work, we need to make sure to mark this one not as a mono behavior, but as a network behavior. Okay, great. So we have our server RPC. We just need to also go back here in the editor. Let's select the kitchen game manager, and yep, let's set the network object component. Okay, great. So now here on this function, basically the server needs to know which player is ready. So technically up here, when we call this function to set its player as ready, when we call this function, we could pass in the owner client ID. This is going to contain the client ID of the player that set the ready. So this could work, but on the Unity docs themselves, they don't encourage this. The reason is because technically a hacker could fake their client ID and possibly break everything. Now in this simple co-op game, we're really not worried about hackers, but still let's do it the proper way. So instead of having the client send its own owner client ID, instead of that, let's go down here into the server RPC, and let's add a parameter of type server RPC params. This is a built-in type, part of Netcode for game objects. So let's receive this one as a parameter, and let's just default it. Meaning that up here we don't need to pass in anything, it gets defaulted. Then now here, when we're on the server side, we can access the server RPC params, and inside we've got a receive and a send. So in this case, the server is receiving the server RPC, so let's go inside the receive, and over here we have the sender client ID. This is going to be the ID of who sent this server RPC. We can do a quick log just to verify, so let's do a debug.log on this server client ID, so let's see. Okay, so up here on the host, if I press the button, yep, there you go, the host sent the sender client ID, which is 0. And now down here, if I interact, that one should say 1, which should be default client ID for this one. So interact, and there you go, got the 1. Okay, great. So with this, we know which player set the ready. Now to sort that is really super simple. Let's just go inside our player ready dictionary, and let's access it on this key, the key of this sender client ID, and let's just set this to true. So this will set the player ready for this client ID. Then we just need a basic loop to check if they are all ready. So let's do a for each to cycle through all the clients. So long for the client ID, and let's do a for each inside the network manager. Let's go inside the singleton, and let's cycle through the connected client IDs. So this will go through every single client ID. Then over here, let's do a basic test to see if this client ID is not ready. So if, and there are two ways that it can be not ready. So it can either have false on that key, or it can simply not have that key at all. So let's go into the player ready dictionary, and let's test contains the key of this client ID. So if it does not contain that key, then this one is unready. Or it does contain that key, but that key is false. So on the client ID is false. So if it is like this, then this player is not ready. So to check if they are all ready, up here, let's first define a boolean. Let's say all clients ready, and let's default it to true. And over here, if just one of them is not ready, then we set this one to false, and let's break out of the cycle. Okay, so then down here, now we know if all the clients are ready. So let's do a debug.log, just see this. So all clients ready, and let's print the all clients ready. Next one over here, I forgot the not. So if it does not contain this key, or this one is not ready, then this one is not ready. Okay, so with this, let's test. Okay, so here we are with the host and the client. Now if on the host I set it as ready, and if there you go, all clients are ready is false, because only the host is ready. But now down here, if I'm ready on this one, and if there you go, all clients are indeed ready. All right, awesome. So with this, all that's left is really to start the countdown. And for doing that, we have two options. We can use a client RPC to tell all of the clients to go to the next state. That's one option. However, that wouldn't be very good. Basically, we would end up with each client having their own local state. Technically, that could work, but I think it makes more sense for the state to be synchronized just once for the whole game. So instead of synchronizing both the state as well as the timers, instead of doing that through client RPCs, I think it makes more sense to use network variables. So let's do just that. First, let's go here on the state. Let's make this a network variable. And because state is an enum, we can just make it directly like this. So let's make a new state. And for default, instead of defaulting it down here on wait, let's default it up here. So default on waiting to start. Okay, we do that instead. Okay. Now let's fix the remaining errors. So over here, when we have the input, let's get the state.value. Okay, and then down here on the update. For this update, this logic is only going to run on the server. So let's test if not is server. If this one is running not on the server, let's return. So we don't want to do anything outside the server. Then we do a switch on the state.value. We do a bunch of things. Then we modify the state.value, and over here modify the state.value. Okay, let's see some more errors over here. All of them pretty much the same thing. We just have to access the value in order to fix all of this. Okay, so that solves all the errors. Now, an important thing is, since over here on the update, we made it so that only the server runs this code. Just like this, only the server is going to fire off these events. We need to modify where we are firing this, since we also want the clients to listen to these events. So let's listen when the network variable changes. So let's go up here, and as usual, let's first of all make an override for the on network spawn. So we have this one, and then let's go into that one, so that's the state. So state.onValueChanged. Let's make a function called state.onValueChanged. And let's use Visual Studio over here to auto-generate the function. Okay, so here it is with the previous value and the new value. And when the value changes, when the state changes, then we fire off this same event. So just like this, and get rid of all of these instances. Yep, only this one, just like this. Okay, so modify the network variable, and all of the clients are going to listen to this event, which in turn fires off this local event. So just like this, all of the clients should have all the states synchronized. Now we can go down here to when we are setting the player ready. So if all the clients are ready, if so, let's modify the state.value, and let's begin the countdown. So let's go into not waiting to start, but into the countdown to start. Okay, so just like this, it should work. So let's test. So here we are, and on the host, I'm going to set as ready, and there you go, it's waiting for players. Now down here, I'm going to press, and it should start the countdown. So let's press, and there you go, all of them are ready, and we've got our nice countdown. Okay, so that's great. However, if you notice down here, the client, that one was stuck on the countdown timer of 3. And we also notice that the timer over here is not being synchronized with that one. So let's synchronize both these as well. Basically, we have the countdown timer and the game playing timer. We need to synchronize both these, so let's make them as network variables. So this is one, and this one is another one. For the countdown timer, let's do a new. Let's start off on 3F, and for this one, do a new, and start off on 0F. Okay, now let's clean up all of these errors. So let's see. Down here, this is the server code, so let's just do value in order to test that one. And same thing for here, and same thing on this one. Pretty much just have to modify to access the value like that. And down here, to get the countdown timer, get the value. And over here, same thing, get the value. Okay, so that fixes all the errors. And let's also go up here in order to also test out the game over state. Let's go for the game playing timer max. Let's put this one just on 10F, just for testing. Okay, so let's test. All right, so up here, let's connect the host. Then on all of these, let's make them clients. Okay, great. Now if I ready, let's say on this one, if I ready, yep, there you go, waiting for players. Now I go into this one, ready, yep, still waiting for players. Now I go into this one, ready, and yep, still waiting, they're all waiting for the last one. And as I ready this one, yep, it started playing the countdown timers, they're all synchronized, and the game starts, yep, and over there we can see the timers, yep, those are also being synchronized. And as soon as they reach the end, let's see if they all synchronize the game over state. As soon as they reach, yep, there you go, we have the game over. All right, awesome. Okay, so here we synchronize the main game state, waiting for all the players to be ready, synchronizing the countdown timer, the game timer, and finally the game over. Now, just one more thing, there's a minor bug that I only noticed right now. If instead of setting ready first on the host, if we set it first over here on the client, and then set it as ready on the host, yep, there you go, this one stays stuck on the waiting for players. So let's fix this. This is a super simple fix. Basically, the issue is that when this event is fired, that's when that window becomes active. But when we set the play ready server RPC, that one, if all the clients are ready, is going to trigger this start countdown. So basically when this one happens, that window hides itself, but then this code runs and that window shows itself. So just a minor issue, and the simple solution is just make sure to fire the event before we set the server RPC to send the ready. So if you do it like this, now here on the client, let's go ready, on the host go ready, and yep, there you go, everything works. Okay, great. Now before we end this lecture, let's just go over here to the game playing timer max, and let's reset this back to the normal value of 90 seconds. Okay, so with that, the game state is all working perfectly. One thing we still don't have synchronized is the pause state, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to synchronize the pause state. So here we have our game where we already have tons of stuff already perfectly synchronized. However, if I pause the game on this one, and if there you go, now this one is still playing and everything still works. And if instead of pausing on the server, if now I pause over here on the client, so the client is paused, but the server is still moving, and we can see over there the countdown timer is still moving. So we need to sort this out some way. And for the pause, multiplayer games can handle it in different ways. The simplest option is simply to not allow pausing at all. Adding that ability is super easy. We're handling the pause over here on the Kitchen Game Manager. So we have over here, we have a toggle pause game. And when we pause, we set the timescale to 0, and when unpause, set it back to 1. So the simple option to not allow pausing to modify the game state would be just to not do this, so we don't modify the timescale. That's the simplest option. With that, basically the local player can check the settings and so on, but for everyone else, the game will keep playing just the same. So this is the simplest option that a lot of games implement. The main reason for that is usually to keep things fair. If you have, for example, a shooter game, you don't want one player to pause just as the other player is winning, so in those games, pause usually doesn't happen. But on a co-op game, like the one we have here, usually you do want to allow pausing just because it's a useful feature to have, and in co-op it's not much of a problem as it is in PvP games. So let's go back to our code, and let's also implement some simple pause syncing, meaning that any player can pause the game, and the other players will need to wait for the game to be unpaused. How we do this is actually pretty simple. We're going to do pretty much exactly the same thing that we did for the player ready logic. We're going to have a dictionary. If all of the players are unpaused, the game is going to unpause. And if at least one of them is paused, then the entire game for all the clients will be paused. So first of all, we need to tell the server if we want to pause, so let's use a server RPC. So a private void, let's call it pause game server RPC. This one will be a server RPC with require ownership as false, okay. Then just like we did with ready, the server needs to know which client paused the game. So let's receive the server RPC params, and as usual, let's put it as default, okay. So we have a pause function, and we're going to have another one pretty much exactly the same for the unpause. Okay, we have these two, and up here when we do this, let's trigger a pause and trigger the unpause. Okay, so now for storing the pause state, let's use a dictionary just like we saw. So let's go up here and let's make another dictionary. It's going to be exactly the same. So we're also going to have a long for the client ID and then a boolean for is player paused or unpaused. So let's call this the player pause dictionary. And let's initialize it. So up here, let's do a new dictionary. Okay, so we have this. And then down here, pretty much the exact same thing. So let's go into the dictionary. Let's use the server RPC params on the receive. Let's grab the sender client ID. And for pause, let's set this one to true. So this one is paused and this one will be unpaused. Okay, so with this now, the server knows which players are paused and which are unpaused. Then let's make a function to see if any of them are paused. So let's make a private void, call it test game paused state. And over here, let's cycle through all of the client IDs. So let's do the usual for each. Long for the client ID. And let's go into the network manager. Let's go in the singleton and let's grab the list of connected client IDs. So you have this. Now let's see if any player is paused. So if the player pause dictionary contains a key with this client ID, so if it has a key and the player pause dictionary on this client ID, if that one is true, that means this player is currently paused. So this player is paused. If so, then we're going to want to pause the entire game. And if we get down here, so we do that and then let's return. We don't need to go through the for each anymore. And if we do get down here, then at least all the players are unpaused. So all players are unpaused. And of course, we're going to run this function after we set one of these. So after a player pauses or unpauses, we run this code to test if the entire game should be paused or unpaused. So now all that's left is to tell the clients to either pause or unpause their game. We can do that either with a client RPC or we can use a network variable. For this one, let's use a network variable. So up here, let's go and we have the isGamePaused. Let's rename this to be more accurate. This one refers to the local player. So let's rename this and instead let's name it isLocalGamePaused. And then we're going to have a network variable for the actual network state. So private network variable of type bool for isGamePaused. So we have this one and start off as false. So the game starts off unpaused. Then we can go down here into the function testing the pause state. So if at least one of them is paused, let's go into this one, .value, and set it to true. And if all of them are unpaused, let's set this one into false. Okay, so that's really it. Now we can listen to the event when this network variable changes. So let's go up here to our on network spawned. Let's go isGamePaused, and let's listen to the on value change. So isGamePaused on value changed. And let's use Visual Studio to write out this function. So here it is, okay. Now when this one changes, now here we can set the actual timescale. So if isGamePaused.value, so if the game is paused, let's set the time.timescale into 0f because the game is paused. And if not, let's set the time.timescale into 1f. Okay, so with this, the pause state and the timescale will be synchronized across all the clients. Let's just go down here because we don't want to make sure to modify that somewhere else. So down here, let's get rid of the timescale and this timescale. Now for these events, we're using these events in order to show the pause window. So these are still useful. Let's just rename them to make them a bit more accurate. These are only going to be fired based on the local pause state. So let's rename this to on local game paused and this one on local game unpaused. Now let's rename also the listener functions. So it's over here on the game pause UI. So we have these functions. Let's rename them quickly. So on local game paused. And over here for this one on local game unpaused. Okay, so just like this, the game pause window should be working correctly. So the local pause should be working with a nice visual, but we also want the visual to reflect the synchronized state. We need something to say that it is waiting for all of the players to unpause. So back in the editor, let's go inside the canvas and let's begin by duplicating the game pause UI. So let's duplicate this one. Let's name this the pause multiplayer UI. Then inside, let's keep the background, keep the pause text, just get rid of these buttons. And for the pause text, let's just say waiting for all players to unpause. Let's put it a little bit smaller. Okay, so like this. Then for the sorting order, let's put this one behind the game pause. So let's put it right above there. Okay, great. Now let's make sure to remember to get rid of this script, and we're going to make a script to run this. So let's go into our scripts, create a brand new one with the same name, so pause multiplayer UI. And let's attach the script, so the pause multiplayer UI, and let's open. Now here, let's begin making the usual show hide function. So private void show and a private void hide, and game object set active either into false or up here into true. Okay. Now we need to know when to show this one. So we need to know when the global game state is paused. So back here on the kitchen game manager, let's just make some more events. So let's make a public event handler. Let's call it on multiplayer game paused and on multiplayer game unpaused. So we have these two events. And for these, we're going to fire them when the network variable changes. So over here is game pause on value change. So on this one, invoke. So this one is going to be paused. And on this one, it is going to be unpaused. So the on multiplayer game unpaused. Okay, so we have these two events. And now back in the script, let's just listen to them as usual. So make a private void start. On start, go into the kitchen game manager and listen to the on multiplayer game paused and unpaused. Let's just rename this to give it a proper name. So kitchen game manager. And then the other one. So same thing on the instance on the multiplayer game unpaused. Let's rename this one as usual. Okay, we have our two events. So when the multiplayer game is paused, let's show. And when it is unpaused, let's hide. And on start, after we listen, let's hide. Okay, so that's it, pretty simple. Let's test. Okay, so here we are. I have the host and two clients. Now if I pause on the host, yep, there you go. All of these are waiting for all players to unpause. And if I unpause on the host, yep, there you go. The game is back to normal. Now if I pause on this one, yep, there you go. The game is indeed paused. And we can see over there the timer is not counting down, so yep, everything is indeed paused. And if I try moving, also doesn't happen because the game is paused. Now let's go into this other one and let's pause this one. So now two of them are paused. Now up here, if I unpause this one, yep, there you go, still waiting until I go down here. I unpaused, and yep, there you go, everything back to normal. The timers are running, everything is working. All right, awesome. Okay, so here we implemented some nice pause syncing. This way, our co-op game is very friendly to people who might have to pause an online game for any reason. Now, one scenario we still haven't handled is what happens when a client disconnects, so let's sort that out in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to handle player disconnects, and this is actually going to be super simple. Okay, so our multiplayer game is really coming along. Now, in single player, we don't really need to worry about the player randomly quitting, but in multiplayer, we need to make sure that the game actually keeps working correctly if a player does decide to leave. So for example, if down here on this client, if I just close this window, and right away we can see that it does work very well, so the player object was removed from the world, so it looks like it already works. Basically, when the player disconnects, all of the network objects that player owns are destroyed with them, so the player prefab is destroyed automatically. Really, the only issue we have is if that player is holding something. So if down here on this player I just pick up some meat, and now I quit, and if there you go, now we have some meat holding along in midair. That's the issue that we have to solve. The player object is destroyed automatically, but we need to make sure to manually destroy the kitchen object the player is holding. So for that, let's go here onto the player script. And first, we need to know when a player disconnects. And for that, we can access a callback. So let's go over here onto the onNetworkSpawn. And we're going to go into the network manager, access the singleton. And over here, we've got a callback on client disconnect callback. So let's listen to this one. Let's rename this to network manager on client disconnect callback. Okay, great. And for the ulong over here, this is going to be the client ID. So the client ID of the client that was disconnected. And we can see over here on the documentation, this callback will be ran both on the server and on the local client that disconnects. Now in this case, for the client that disconnects, we don't really want to worry about them. So we really just want to listen to this on the server. So we can just add here if is server. And if so, we're going to listen to this. Also remember that the is server here, this one refers to the state of this build and not this specific player. So this will still attach a listener on the server side, even on players that aren't actually the host. Okay, so with this callback, now the server knows when a player disconnects. With the client ID that we have here, we can check if this is the one that was disconnected. So let's check if this client ID, so the one that disconnected, does match the owner client ID. So if so, then it was this one. Then next thing we want is to check if this player is holding any kitchen object. So if it is this one and has kitchen object, if so, then we want to destroy it. So as usual, let's use the kitchen object and destroy the kitchen object and pass in this.kitchen object. We can only destroy on the server, but over here we already attached the listener only on the server. So yep, this should be working. Okay, so just like this, let's test. Okay, so here with the client, let's pick up something, and now let's quit on the client, and yep, there you go, the object is indeed destroyed. Alright, awesome! So just with this, we already have the entire game logic working perfectly with disconnects. There's nothing else the player can do that could affect the gameplay itself. If they disconnect in the middle of cutting or frying an object, that doesn't cause any issues. The one thing that can cause issues is if they pause the game and then disconnect. So here are both, and down here on the client, I'm going to pause the game, and then I'm going to quit. And if there you go, this one did clean up the player, but now this one is stuck waiting for unpause. Now, thankfully, the way that we handled the pause synchronization, we made it over here by cycling through the network manager connected client IDs, meaning this is actually only going to test the state for the actual connected clients. So because of that, this here isn't actually a game-breaking bug. If on this remaining client I just pause and unpause, and if there you go, now the game is back to normal. But obviously, it should automatically unpause if the only pause player quits, so let's fix that. This is also going to be a pretty simple fix, so let's go over here onto the Kitchen Game Manager. This is the class where we're handling all of the pausing. So on this one, just like we did on the other one, let's listen to the disconnect callback. So over here on the on-network spawn, let's check if is server. So on the server, let's listen to it. So network manager, the singleton on disconnect callback, and let's listen to it. And as usual, rename this, keep things clean. So network manager, okay, so we'll listen to this. And over here for the parameter, this is the client ID. Although right now we really don't need the client ID because afterwards we really just need to run the function test the game pause state. This will then test all of the clients and see if any of them are paused, and if the one that disconnected was the only one that was paused, then this will unpause the game. However, this won't actually work. The reason is because when this callback is fired, when this happens, the client is still going to be on the connected list. So if it cycles through this, it's still going to cycle through the client that is just disconnecting. So basically to solve this, we need to wait one frame to make sure that this list is updated. So let's basically make a boolean, and then after that update, then we're going to run this function. So up here, let's make a private bool, call it auto test game paused state. We're going to test that automatically. So then when we have our disconnect, let's set this one into true. And over here, we are not going to run this function. All right. Then let's go down and we're going to make late update. So let's go over here, a private void late update. And on late update, let's check if this one is true. If so, then first of all, let's set it to false. And over here, we run the test game pause state. Okay, so like this, it should work. So let's test. Okay, so here we are. And on the client down here, let's pause. And now let's quit. And if there you go, that one automatically unpauses and everything works. Okay, great. So the pause disconnect logic is working. Now let's see basically the opposite, which is what happens if the host quits. So with the host up here and the client down there, if on the host I stop playing, and if there you go, look at that, everything shuts down, all of the players get destroyed, the network manager automatically stops running. So in terms of logic, it already works, so the game definitely stopped working. But obviously there's no visual for the players, so let's make one. Let's go inside our canvas, and over here, let's begin by duplicating the game over UI. Let's name this one the host disconnect UI. And let's put it on the sorting just before the game pause UI, so just like that, okay. Then over here, for the text, let's rename this to just say text. And inside, let's just say host has disconnected. Let's put it a little bit smaller, move it a little bit down, and we don't need these other ones. So let's get rid of these two, just like that. And we can leave the play again button. Okay, now let's make the script to run this. So with the same name, let's go ahead, create a brand new C# script for the host disconnect UI. Over here, let's get rid of the game over UI and add the host disconnect UI. Okay, let's open. Now on this one, let's first of all add the reference to the button. So a serialized field, private button for the play again button. Okay, like this. Back in the editor, let's drag that reference, all right. So now let's make the usual show and hide function. So private void show and a private void hide. Just set game object. Set active into false, and over here into true. Okay, we have our functions. Then for showing it, we need to know when the host has shut down. And for that, we can actually listen to the same callback. So let's make a private void start. On start, let's go into the network manager, the singleton, and let's listen to the on disconnect callback. So let's add a listener to this one. Network manager, okay. So we have this one, and again, over here we have the client ID. And now to know if the server was the one that shut down, we can basically just compare this client ID to the server ID. So let's check if this client ID equals the one on the network manager dot server client ID. This is a constant. The server is always on an ID of 0. So let's do this. So if it is, then this means the server is shutting down. And if so, then let's show this window. And on start, let's start off hidden. Okay, that's it, a simple script. Okay, so up here is the host and the client, and if on the host I quit, and if there you go, host has disconnected. Alright, awesome! So with this we have handled pretty much every single possible scenario, except perhaps the more obvious one, which is enabling the player to manually quit out of the game. Right now, if I'm here in the editor, let's say I start off as a host, then I go into the pause menu and go back into the main menu. Yep, here I am in the main menu. And if I look in the hierarchy, yep, the network manager, yep, it is still running. We still have an active connection. Obviously, we don't want this to happen. So let's go over here onto the Game Pause UI, and this is where we have the main menu button, so we'll load the main menu scene. But before we do that, let's go into the network manager, the singleton, and let's call the shutdown function. So this is going to shut down our connection. Really, we just need to do this in every place where we quit the game. So that's over here on the Game Pause UI, and the other one is over here on the Game Over UI. So we'll load the main menu, and before we do that, let's shut down the network manager. Okay, so let's test. Here we are, let's host, and let's go back into the main menu. And yep, in the inspector, we can see the network manager no longer has an active connection. Alright, awesome! So here we have handled every single disconnect scenario. The players can disconnect, and the server handles everything gracefully. So now that the disconnects are working, let's think about the opposite, which is what do we do to handle client rejoins? Let's talk about that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to talk a little bit about the concept of late player joins. Okay, so here's our game, which is actually pretty small. Each session of this game is only a few minutes long, so because of that, we're not going to allow late joins. Doing so adds quite a bit of complexity. So for a game like this one, we're going to make it so that everyone joins in the very beginning and they all play until the very end. If someone drops in the middle, they can simply just restart the session. But still, I want to talk about the topic of late joining because for other game genres, this is indeed extremely important. Now, the reason why handling that is so complex is due to potential problems with data desync. There are two main methods we have for synchronizing data. We have RPCs and we have network variables. The one big difference between both of them is that when a client joins late, they will receive the current state of a network variable, but they will not receive all of the RPCs that have been sent since the very beginning of the game. In this game, we use RPCs quite a lot to synchronize tons of stuff. We use them because they are quite simple to use and very easy to understand. Like for example, setting the kitchen object parent. So let's do a quick test. Okay, so with the two builds, down here I'm going to connect the host, but I'm not going to connect the client just yet. So I'm going to start playing with the host, count the countdown timer. Now I'm going to pick up something, let's say I pick up some meat, okay? And now if I connect with the client, and now actually we have the thing where we synchronize this window, so let's manually just hide this. So I'm just going to find the window, the tutorial UI, and just hide it. And if there you go, look at that, we can now see the desync. Basically, this second player joined late, so this one knows that an object was spawned, so that object is indeed spawned, but it does not know that the first player is actually the one holding the object. So we have a data desync. The second client did not receive which one is the kitchen object parent for this game object. Again, this is the difference between spawned objects and RPCs. The kitchen object itself, that one was indeed synchronized, but for the parent data, that one is only synchronized through an RPC, so the second player doesn't know what happened there. And now if over here on this one, if I just drop it somewhere, there you go, now everything is indeed synchronized because this one is now connected, so this one now receives the new RPC. So in this case, it's not necessarily a big issue since it does end up sorting itself out, but another thing we have synchronized through RPCs are the recipes. So I'm going to start again, on this one down here, I'm going to connect as the host and start playing. And there you go, this one is now going to generate some recipes, and yep, there you go, generate one. So now on this one, connect on the client. Let me hide that UI. And if you look in there, nope, it did not receive the very first recipe. So now they have different amounts of recipes. Again, that is because we used an RPC in order to send the new recipe spawned. So this one joined late, so it missed the spawning of the very first recipe. So now the two clients have different data for what recipes are waiting. Also same thing over here on the plates counter. Again, this one is using an RPC, so you can see over there the plates counter is full, but that one missed the message spawning the first plate. So this is the main tricky thing. If you want to make a game where you want to allow late joining, then you need to design your game in such a way that all of the important data is synchronized in a way that is automatically synced. One option, like I said, is using network variables. Those are synchronized automatically when someone new joins. So even though this second player, this one joined late, you can see over there the actual timer for the game. That one is being synchronized correctly, even though this one joined late. That is because that one is using a network variable. So if you made the waiting recipe list a network variable, it would synchronize correctly. However, the reason why I use RPCs is because we cannot directly put a scriptable object inside a network variable. So over here on the delivery manager, it would require a different code in order to synchronize this list. You could either make a network variable with a list of hints to hold the index for each recipe SO, or you could implement the iNetwork serializable to teach NGO how to serialize this specific scriptable object. I covered that in the Netcode video. So it's definitely possible, it just requires a different approach. Another option would be to keep using RPCs just like we're doing here, but when a new player joins, you would have the server send that player all the data they need to synchronize. So for example, over here on Delivery Manager, you could add a callback listener when a client connects. You can listen to that through the Network Manager, the singleton, and here is the client connect callback. So you could listen to this on the server. Then when this happens, you could have the server send a client RPC just to that client to tell them all the recipes that have already been spawned. Then from that point on, everything would already be synced. So adding support for late joiners adds a bit of complexity, but it is certainly doable. As to whether you need it or not, really depends on the game you're making. If it's a quick session game like the one that we have here, then I think it's not really worth it to add that extra complexity. But if you have a game with longer sessions, then of course that one is a must. So keep that in mind when building your game from the very beginning and deciding whether to use RPCs or network variables. So here for this game, let's not allow late joiners. And how we do that is actually very simple. If we look over here on the Network Manager game object, if we scroll down here there's a toggle for connection approval. Right now, every client that connects gets automatically accepted. We don't want that. So let's instead enable this. And then let's go here onto the kitchen game multiplayer script. And on this one, we can listen to a callback. However, one very important thing is we need to listen to the callback before we call the start host. So let's make a start host function over here on this class. Let's make a public void start host. And then we're going to have a public void start client. And over here we have the testing netcode UI. So these are the two testing buttons that we're using. Instead of directly going to the network manager and calling it, let's go into the kitchen game multiplayer, the instance, and use that function. So the start host and then the start client. Okay, so we go through those functions. Then over here on these, let's do the same thing. So network manager, the singleton, start the client, and on this one, network manager, singleton, and start the host. And now here, before we start the host, let's go into the network manager, the singleton, and let's listen to the connection approval callback. Let's add a listener to this delegate. Now this isn't an event, so Visual Studio isn't going to automatically run this. So let's call this network manager connection approval callback. And now let's use the Visual Studio automatic things to generate this method. Okay, so here it is. So we take an argument for the connection approval request and then another one. This one is for the connection approval response. And now here how we either approve or disapprove of a connection is very simple. We just go inside the connection approval response, and over there there's something called approve. That is a boolean, so we can set it to true to allow or false to not allow. So for right now, let's make sure we only approve connections when we are in the waiting to start state. So over here on the kitchen game manager, let's just expose the waiting to start state. So let's go down here where we have a whole bunch of functions. So let's go a public bool is waiting to start, and just return if the state.value equals the state.waiting to start. Okay, so then over here, let's check. So check if the kitchen game manager instance is waiting to start. If so, then we are going to approve the connection. And if not, we are going to disapprove the connection. Now actually in a bit, we're going to refactor this to make it so that the connection is actually established in the lobby. But for now, this testing code should work, so let's try it. Okay, so over here, first let's create a host, all right, and on this one, let's join right away, all right, so both of them are on waiting to start. So if I click on client, this one is going to connect, but instead of that, let's start this one, okay, waiting for players, this one start, and yep, there you go, it starts the countdown. And actually here we see one thing that I forgot. You can see that the players weren't automatically spawned. That is because when you enable this connection approval, you need to manually tell it to create a player object. So over here, when we approve, we also need to go into the response, and over here set create player object into true. So this will now revert the same behavior we had previously where the player object will be spawned automatically. Okay, so let's try again. Over here, create the host. Over here, join as the client. All right. Now let's start this one, waiting for players. This one start, and there you go. The game has started. These two players are connected. So now it shouldn't be accepting any more players. So down here, if I try to join, and oh, there you go, it does not work. The host has disconnected. So that one can no longer join our clients. All right, awesome. Okay, so here we talked about whether you want to allow late joining or not, and the various challenges that come with adding that feature. And we also limited how the players can join our game. With that, our entire game logic is now working in multiplayer. What's left is really handling all of the other scenes. But before we build those scenes, let's actually set up the entire connection flow. So let's do that in the next lecture. Hey again, here's another quick intermission. Good job on sticking with the course. By now, I really hope you've already learned a ton from the course. Almost all of the core multiplayer logic is already done by now. Although the following lectures, and also actually some of the more important ones, handling the connection scene flow, the character select scene, lobby, relay, and so on, they can be a bit tricky, so definitely do take your time. I hope you've been following the website as you go through the lectures, and I hope reading the frequently asked questions has helped you in some way. If you enjoy my teaching style, then check out my other course after finishing this one, especially the turn-based strategy course. That one would be an excellent follow-up to this one. Alright, let's go to the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to handle the connection scene flow, meaning we're going to handle the changing of scenes and set up where we're going to actually create the netcode connection in order to prepare for the future lobby and character select scenes. We're going to start from the main menu with no connection, then the lobby scene handles the lobby list. As soon as the player joins the lobby, it automatically creates the netcode connection and goes into the character select scene. On that scene, the player will then select the character and set as ready. When all players are ready, the game will load the final game scene and start the game. Okay, so let's handle the connection scene flow. Let's begin by making the scenes. So let's go into our scenes folder and let's create a brand new scene. Let's name this one the lobby scene. And let's duplicate this one to make the character select scene. Okay, now let's first go inside the lobby scene. And over here, let's create a brand new canvas. And let's set it up as usual. So screen space overlay, then over here scale with screen size. Reference resolution of 1920 by 1080 and match with the height. So the usual setup. Now inside the canvas, let's create an empty game object, call it the testing lobby UI. Let's put the width and height both on 0. Again, for this lecture, we really just want to handle the connection flow. So we're just going to make some testing buttons. We're going to set up the proper lobby in a later lecture. Inside this game object, let's create a simple button. Call this the create game button. Inside, let's put create game on the text. Let's put it a bit in bold, a bit bigger, and on the button itself also a bit bigger. Okay, great. Then let's make another button, so duplicate this one, put it down. This one is going to be the join game button, and inside for the text for this one, join game. Okay, we have our buttons. Now let's make a script to run this. So let's go into our scripts folder inside the UI. Let's create a brand new C# script with the same name, so testing lobby UI. Let's wait for it to compile. And over here, let's add the testing lobby UI. Okay, great. Let's open. Now on this one, first of all, let's add some references for the buttons. So a serialized field, private of type button. First, we have the create game button, and then we have the join game button. So you have these two. Here in the editor, let's drag the references. So the create game button and the join game button. All right. Now over here, let's do pretty much exactly what we were doing on the testing UI on the game scene. Meaning we're just going to start either a host or a client. So let's do a private void awake. Let's go into the create game button, the onClick. Let's add a click listener. On this one, we go into the kitchen game multiplayer, the instance, and call start host. And then for the other one, for the join game button, on this one, we start as a client. Okay, so we have these, and this is going to start a host or a client, which also means we need to create a network manager in the lobby scene and not on the game scene. So let's save this scene and let's go inside the game scene. Then over here, let's find the network manager. Okay, great. So let's copy this. So Control C. Let's go back into the lobby scene. Over here, Control V. Okay, we have the network manager. Let's go back into the game scene. And over here, let's make sure to delete the network manager. Remember that the network manager works as a singleton that does not get destroyed on scene changes. So we need to make sure we only spawn it once. And we're going to do that just over here on the lobby scene. Okay, great. Also for the settings, we're not going to want to spawn the player right away since there's no player object over here on the lobby. So let's click to select the player prefab field and then press on delete in order to clear it. Okay, great. So just like this, we should have this button which creates a host and this one which joins as a client. But if we test right now, nothing will actually happen since we just have a connection being established and nothing else. According to our connection flow, once we connect, we want to load the character select scene, so let's do that. Over here on the create game button, we first start the host, and then afterwards we're going to load the next scene. So we're going to loader, call load, and let's pass in the next scene. So let's actually add them to the list. So over here on the loader script, let's set our two scenes, so the lobby scene, and then we have the character select scene. Again, here make perfectly sure the names perfectly match the actual scene names, so be very sure the names are perfect. And over here, we're going to load the character select scene. Okay, like this. However, this part is actually extremely important. For loading the scenes, we're actually going to use the network manager itself to handle scene management. That way, all of the clients are going to be synchronized automatically. So in order to do that, we need two things. First one is over here on the editor, on the network manager. Let's scroll down, and over here we do see enable scene management. So let's make sure this one is enabled. This makes it so that when you change scenes in the server, all of the clients will automatically load that scene as well. And the second important thing is that we need to load through a different method. So over here on this load function, we are going through the regular scene manager and calling load scene. In order to make it work with the network manager, we need to do it through a different function. If you don't do it, if you just use this function, then the objects on the new scene will not automatically spawn. Personally, I found this out the hard way while making the prototype. I had no idea why the objects on the game scene weren't being spawned, and that is because I was using the scene manager, instead of going through the network manager. So if you have issues where you're changing the scene and the objects are not spawning on the network, double check to make sure you're changing scenes using the scene network manager. So over here, let's make a function to do exactly that. Let's make a public static void, call it load network, and we're going to receive the same scene for the target scene. And over here, instead of going through the scene manager, let's go through the network manager, the singleton, let's access the scene manager, and in there we can now call load scene, and let's pass in the same scene, so the target scene, and as usual this one takes a string, so let's do a toString. And then for the load scene mode, you can load as additive, but in this game, in this simple game, we're always using just single, so let's go with single. Okay, so that's it, so we need to make sure we always use this function and not this function. Now, one note here. Note how with this, we're actually bypassing the loading scene that we made in the single player version. I'm doing that just because handling that would be quite a bit complex, and this connection flow lecture is already a bit too long. Basically, we would need to wait until all of the clients load the loading scene before the server starts loading the final scene. So it's definitely doable, just requires a bit more complexity. Here to keep things simple, let's leave it just like this in multiplayer. So it's going to load the scene right away. So back here in our testing lobby UI, instead of using the load, let's use the load network. And also over here on the client, on this one we do not need to add it, because the client will automatically load to match the scene that is loaded on the server. Okay, so with this we're almost ready to test. We just need two more things. First of all, over here when calling start host or start client, in the end we're going through the network manager, but right now we're actually going through the kitchen game multiplayer. So we also need this object on the lobby scene, just like we have the network manager. So let's save the lobby scene, let's go inside the game scene, let's find over here the kitchen game multiplayer. Let's copy this back in the lobby scene, paste it, and back in the game scene, save the changes, and clean it up from here. Okay, great. So we have it just over here on the lobby scene. However, we have another sneaky issue. Like this object will be destroyed when we load the character select scene. We don't want that. We want this object to persist for as long as the network connection is active, pretty much just like the network manager. So over here on the kitchen game multiplayer, on the awake, we can simply do don't destroy on load, and pass in this game object. That will make sure that this game object does not get destroyed when the scene loads. Okay, great. So one more thing, it's over here on the connection approval callback. In the lobby, we don't have any waiting to start state. So for now, let's just always accept the connection, and then in a little bit, we'll handle the proper logic. So just set this one as approved as true, and let's get rid of the rest. Okay, we're almost done. Just one final thing, which is let's go into File, into the build settings, and over here in the build list, we need to make sure to add our new scenes. So let's go ahead, find the lobby scene, drag it, and the character select scene, drag it. And also for testing, we're going to need to make sure to start from the lobby scene, so let's just drag it over to the top, so that one is on index 0. Okay, so we can now test. So let's make a regular build. And over here in the editor, make sure you are on the lobby scene when you hit on play. Okay, so here is the editor and the build both running, both working great, so there are no errors. If you have some errors in your game, go check the error. Chances are you possibly forgot to copy one of the objects onto this scene. So with this, everything is already working correctly. And now on this one, I can press the button to create a game. And if there you go, it goes into the character select scene. And then on the build down here, I'm going to join the game. And if there you go, it also loads that scene. All right, awesome. So the first part is working. We're going from the lobby scene to the character select scene with no errors. Now let's handle the transition from character select onto the game scene. Let's go into the character select scene. And over here, as usual, let's make the canvas and set it up. So a brand new canvas, screen space overlay, scale with screen size, with 1920 by 1080. And let's match fully with the height. Okay, great. Now inside, let's create an empty game object for the testing character select UI. Inside it, let's create a new UI, create a new button, call this the ready button. Inside, make it say ready. Okay, we have the button. Now let's make a script to run this. So let's go into our UI folder and create a new C# script. Let's add the script, so the testing character select UI. Okay, let's open. Over here, let's begin by adding a reference to our button. So a serialized field, private button for the ready button. Okay, let's save. Back here in the editor, let's drag the reference, all right. And now the goal here is to pretty much use exactly the same logic that we made for the kitchen manager. Over here on the main game manager script, we had the ready logic, so the game would only start when all of the players were ready. So the logic is exactly the same. So let's actually copy the exact code. So let's copy first of all the player ready dictionary, except we don't want to run that logic directly over here on the UI script. So let's make a proper script. Let's create a brand new game object for the character select ready. And let's make a script with the exact same name. So the character select ready. Let's reset the transform and add the character select ready. Okay. Now this one, let's actually paste that code. So first of all, let's copy over here the player ready dictionary. And over here, let's paste it. Okay, we have the dictionary. Then we need to initialize it on awake. So on awake, the player ready dictionary, let's make a brand new one. Then let's see what other logic we're using with this one. And it's down here, we have an RPC in order to set it as ready. So let's just copy this entire function. And over here, let's paste it. And when you do, make sure you add using unity.netcode up here. Visual Studio should do it by default, but make sure you do it. Okay, so this is really going to do the exact same thing. So go through the player ready dictionary and see if they are all ready. And if so, then it's over here. Instead of setting the state, over here, we're just going to load the final scene. So going to the loader, and again, remember to use the load network function. And we're going to load the game scene. Okay, so that's really it, super simple. Then for calling the server RPC, let's expose a function, setPlayReady. And over here, we call the setPlayReady with the server RPC. So we just need to call this function from that button in the UI. So let's go up here, make a public static character select ready in order to make our static instance. The get any private set. And over here on the wake, set instance equals this. Okay, great. So now back here on the testing character select UI, let's make a simple awake. Let's go into the ready button, the onClick, let's add a listener. And on the listener, let's just go into the character select ready, the instance, and let's set the player as ready. Okay, so that's it. This should be working. Let's just do one more thing. Let's go into the game scene. So let's first of all save this scene, go inside the game scene. And over here on this one, on the canvas, we no longer need the testing netcode UI, so let's just disable this one like this. And actually just one final thing that I forgot. Over here, in order for the server RPC to actually work, we need to make sure this one is not a model behavior, but rather a network behavior. Then back in the editor, let's go into the character select scene, select the object, and yep, let's add network object. That way it should work. Okay, great. So we're ready to test. Let's go back into the lobby scene. Again, this is important. We always need to start from the lobby because this is where the network manager is created. So with this, let's make a build and test. Okay, so here we are. So up here, let's create a brand new game. And yep, on the character select scene. Now on this one down here, let's join the game. And yep, there you go. It does work. So both of them are on the character select scene. Now on this one up here, I'm going to click on ready. And there you go. This one is ready, but it did not load the game scene. It is still waiting for this one down here to be ready. And as soon as I set ready on this one, it is going to tell the server that it's ready. And yep, there you go. The server automatically loads the final game scene, and this one loads with it. All right, awesome. So everything is working great. Now over here, we are waiting for players, and there you go, it works. However, obviously, you might be noticing one issue right now. Since we removed the automatic spawn player prefab, we have nothing over here. So we need to manually spawn the player. Let's do that. Let's do that over here on the kitchen game manager. This script only exists on the game scene. And for spawning, we only want to spawn when all of the players have loaded. So for that, let's go down over here onto the on-network spawn. Let's go in the network manager. And if we go inside the singleton and then inside the scene manager, over here we have a function onLoadEventComplete. This one is triggered when all of the clients have loaded the final scene. Again, it's important, it's this one, not this one. This one up here is triggered on a per client basis, whereas this one down here is when all of the clients have loaded. So let's go with this one. Let's listen to this one. And over here, it's pretty simple. We just want to spawn all of the players. So let's cycle through all of the connected clients. So YOLO for the client ID. In the network manager singleton, the connected client list. Okay, we have all the connected clients. Then we need to spawn the player prefab. So we need a reference. Let's add it up here. So a serialized field, private transform for the player prefab. So we have this. Then the editor, let's go inside the game scene and let's go into the kitchen game manager and let's make sure to drag the player prefab. There it is. Also, one important thing, since we are spawning the player, let's go into the lobby scene. Let's make sure to save. And on this one, on the network manager, in order to spawn the player prefab dynamically, we need to make sure we add it up here. Since we removed it from the player prefab up here, we need to add it onto the network prefabs. So let's add a brand new one and drag the player prefab. Okay, great. Back in the code here, we have the player prefab. So down here, let's just call instantiate the player prefab. So this is going to return our player transform. So we have this, then on this one, let's do a get component to grab the network object. And on the network object, we can call the function spawn as player object. So not the spawn, but the spawn as player object. This one takes a client ID, so let's pass in this client ID. And then for destroy with scene, we do want the player prefab to behave as a regular game object. So we do want it to destroy with scene, so let's go with true. All right, so that's it. This will spawn the player prefabs, and after that, the rest of the game should work perfectly. Okay, so let's test. And again, as always, in order to test, make sure you test from the lobby scene. Okay, so on this one up here, let's create a brand new game. All right, here we are. Then down here, let's join. Okay, it works. Now let's set as ready. Still waiting for this one. This one goes as ready. And yep, both have loaded the final game scene. Now as I start playing, and there you go, each of them now has their own player controller. And now, yep, all of the rest of the game, all of it is perfectly synchronized. All right, awesome. Next, let's handle the connection accept logic. So over here on the kitchen game multiplayer, we modify this callback in order to always approve. Now we only want to accept while we are on the character select scene. So let us test if the current scene is the character select scene. So let's do a simple if. Let's go into the scene manager. Let's get the active scene and let's get the scene name. Then we compare. Let's compare with the loader.scene and check if we are in the character select scene. Now we need to compare string with string. So let's use the toString. Okay, so we compare if we are on the character select scene, and basically if we are not on the character select scene, then let's approve as false. So cannot connect. And then let's return a reason. So on the reason, let's just say the game has already started. Okay, so that one we don't approve, and then let's return to stop the rest of the execution. The next validation is checking the max number of players. We only want 4 players maximum. So over here we can do an if. Let's go into the network manager, the singleton, get the connected client IDs, and we check the count, and we compare it against something. So for defining the maximum, let's actually go up here and make it a constant. So a private const int for the max player amount, and let's say we want a maximum of just 4 players. Okay, with this, and now down here we can compare. If we already have way too many, then once again, same thing, let's not approve, and let's say game is full. Okay, and if it's neither of these, then we do accept it. Okay, so that's the logic. Now let's add a visual. The connection starts here on the lobby scene, so let's add the visual here. Let's go inside the canvas and create an empty game object. Let's call this the connection response message UI. Let's make it stretch to occupy everything and put 0, 0 on everything, okay? Then inside, let's create a new UI image, call this the background. And again, let's make it stretch to occupy everything. And let's put this one on black with a little bit less alpha, okay, great. Then let's also add a text, so a new UI text. Call this the message text. And here we're going to say some message. So let's put it the usual setup, so width and height of 0. Let's disable wrapping, put it down center, down the middle, in bold, and lift it up by a little bit, okay? Then let's also have a button. So a new UI button, call this the close button. And inside, let's say close. Let's put the button text in bold, put it in white, and for the parent, for this one, put it in a dark gray. And just like this, we have a simple, nice button on an X of 0. Okay, great. We have both elements. On this window, we're going to show the disconnect reason message. Now let's duplicate this one for another window, just saying connecting. So let's duplicate this window, call it connecting UI. And on this one, get rid of the close button. We just have a message. And for the message, let's just say connecting. Okay, just like this. Now here, obviously, you could merge both these windows into just one, but let's keep them separate to keep things a bit more clean. So we have our UI setup. Now we basically just need to know when the player tries to connect and when that connection fails. So over here on the kitchen game multiplayer, let's make a bunch of events. So let's make a public event handler, and let's call it on trying to join game. Another one on fail to join game. Okay, then let's go down here, and the first one is when trying to connect. For that one, let's fire over here before we call the start client. So let's invoke with the usual this event args.empty, okay? And then for the disconnect failure, for that, let's also go up here where before we call the start client, let's listen to the disconnect callback. So the network manager, the singleton on disconnect callback. So let's listen to this one. Let's give it a proper name. So the network manager. Okay, so we have a disconnect callback, and here we've got the client ID. And on this one, let's fire off the event. So on fail to join game. So let's invoke with this an event args.empty. Okay, we have both our events. Now let's make these scripts for our windows. So let's make first over here the connecting UI. So let's create a brand new UI script. Over here, let's attach it and open. Okay, now let's make the usual show and hide functions. So private void show, and then we have a private void hide. And same thing as always, so set active as false or as true. Okay, now let's do a private void start. And on start, we're going to listen to some events and then we hide it. So for the events, this one, let's listen when we try to connect. So the kitchen game multiplayer, the instance on we are trying to join the game. So when this one happens, so let's rename this kitchen game multiplayer. So when this event happens, let's show this window. And then let's also hide it when that one does fail. So on fail to join game, let's add this listener. So when it fails to connect, let's hide. Okay, great. Now let's make the other script. So the connection response message UI, let's build this one. Over here, let's attach the script and let's open. Okay, so here we're going to have pretty much exactly the same thing. So let's have the usual private void show and hide. Then let's add references to the text and the button. So let's add a serialized field. And first for the text, this one is Text Mesh Pro UGUI for the message text. And then we have another one. This one is a button, and this is going to be the close button. Okay, let's save this. And here in the editor, let's drag the references. So the message text and the button. All right. Then let's add our listener. So on private void awake, let's go into the close button. On the onClick, let's add a listener. And this one is going to be just the hide function. So that is just going to hide the window. Then let's do our private void start. And on start, let's listen. So kitchen game multiplayer, the instance, when it fails to join a game, let's listen to this one. So on start, we'll listen and then we hide by default. And when it does fail to join the game, let's show this. And then let's set the message text. And for the disconnect text, we can grab it from the network manager, the singleton, and we grab the disconnect reason. So yeah, that's it. Just like this, both our scripts should be working. However, here let me point out one very important thing. One question that I got a lot in the single player course is with regards to unsubscribing from events. You might have noticed that we pretty much never unsubscribe to events. That is because you only need to unsub if the objects have a different lifetime. If both the publisher and subscriber have the exact same lifetime, then you don't need to manually unsub. However, over here, these objects do have a different lifetime. These UI windows, these only exist on the lobby scene. As soon as we change scenes, they will be destroyed. But the kitchen game multiplayer, this one will live through all the scenes. So we need to make sure to unsub because this object is going to have a different lifetime than the kitchen game multiplayer. And how we unsub is very simple. Let's just make a private void on destroy. So this one is a mono behavior function, which is called when this object is destroyed. So this one, we really just unsub. So just going to that one and do minus equals. So we do it over here. And on the connecting UI, same thing, private void on destroy. Let's unsub to both of these. So just do minus equals. Okay, great. So now we can test. All right, so here I've got 1, 2, 3, 4, 5 clients. So on this one up here, let's create a game. And there you go, it did work. Then on this one, let's join a game. And yep, it did work, connected, joined. On this one, join. Yep, it worked. This one, join. Yep, it worked. So now we have all 4 clients connected. So the game should be full now. So on the 5th one, if I try to join, and yep, there you go, the game is currently full. Okay, great, so that worked. Now let's actually quit one of these, so let's quit this one. So technically now we do have one slot available. So let's not connect right now. Instead, let's set this one as ready, this one is ready, and this one is ready. And yep, there you go, all of them are loading the final scene. So here we have our 3 players. Okay, great. But the game is now playing. So on this one, if we do try to join, and nope, the game has already started. All right, awesome. So all this logic is working perfectly. There's just one more possible failed connection scenario. That is simply if the connection just times out. If that happens, then the same event won't be fired. The only difference is the disconnect reason will not have any text. So we can just check if the disconnect reason is empty. So if we have no disconnect reason, Then let's just set this one to just fail to connect. Okay, so that's the text. And also by default, it will take a bit too long to timeout. So over here on the lobby scene on the network manager, if we scroll down, yep, over here on the NT transport, we do see a bunch of settings. So we have the connect timeout milliseconds, so meaning after 1000 milliseconds, so 1 second, it will wait 1 second until that connection times out, and then it will try to connect for a maximum of 60 times. This seems like a bit too much, so let's put it on just 10 tries. So if it fails after 10 tries, then after 10 seconds, it should say fail to connect. Okay, so let's test. Here we are, and without creating a host, let's just try to join the game. And there you go, it is trying to connect, but there's no game, so it should fail. So after 10 tries, after 10 seconds, yep, there you go, we have our fail to connect message. Okay, great. So with that, we have almost our entire connection flow working. We start from the lobby, we can create a game, and we can join a game. We go into the character select scene, and then when all of the players are ready, when that happens, yep, the server loads the final game scene, and over here we can play as normal. So everything is working great. All that's left is the main menu. So if over here on the host, if I go back into the main menu, there you go, that one disconnects, so that's great, and I'm back on the main menu, so it looks great. But if we look in the hierarchy, yep, over there, look at that, the network manager and the kitchen game multiplayer, these objects are still active. So if we now went into the lobby scene, we would end up with duplicated objects and tons of problems. So basically, we need to clean up these objects, and let's do it when we go back over here on the main menu. So let's go into the main menu scene, so let's open this. And over here, let's make a simple script to clean this up. So let's create a new one, let's call it main menu cleanup. Let's make a script to run this. Let's attach the script and open it. And now here, really all we need to do is just clean up both objects, so that's super simple. Let's make a private void awake. And on awake, let's just test if the network manager, the singleton, if this one exists, so if this one is not null. If so, then let's really just call destroy on the network manager singleton game object. And same thing for the other one, so the kitchen game multiplayer, if this instance is not null. If so, then let's destroy this instance.game object. Okay, so that should work. With this, the objects should always be cleaned up whenever we go back into the main menu. Just one more thing, let's make sure this play button goes into the lobby scene and not the game scene. So on the canvas, let's open up the main menu UI. And over here, let's use the load, because over here we have no connection, so let's use the single player load. Instead of the game scene, let's just go into the lobby scene. And finally, we can go into the build settings, and now we can make sure that we start from the main menu scene. Okay, so let's test. Alright, so here on Let's Play, we're in the lobby, and let's create a game. Then on this one, let's play, let's join a game. Set is ready, and yep, both of them start playing. So yep, here we are both playing the same game. Now on this one, I'm tired of playing, so go back into the main menu. And if we look in the hierarchy, and if there you go, no more objects, we have everything cleaned up. Now on this one, I can play again, I can create another game. Then on this one, go back to the main menu, and let's join again. Ready again, and yep, we are back in a brand new game instance. Alright, awesome! So here we handled our complete game connection flow. We start from the main menu in single player, then on the lobby we have a button to create the connection. In turn, that loads the character select scene where more players can join. Then on that scene, each player can set the ready to true. When all of the players are ready, the normal game scene loads, and then the game continues as normal. So yep, we have all of that working. Now all that's left is actually building out the lobby and the character select scene, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to build a nice character select scene where the player can select their player color. Okay, so here let's build a character select scene. This is actually one of the more common questions I've seen in my Netcode video. Lots of games have this sort of thing, so let's build it. Let's go to the character select scene, and first of all let's just make some proper buttons. So inside our canvas, let's create an empty game object, call it the character select UI. Let's make it stretch to occupy everything. Okay, so now inside, let's add a UI button. Call this the main menu button. Let's anchor it on the top left corner, and let's move it a little bit like that. Okay, let's make it a little bit bigger. Let's make this in a dark gray, and inside for the text, let's say main menu. Let's put it in bold, in white, something like this. Okay, that's the button. Now let's duplicate this, make this the ready button. And for this one, let's anchor it on the top right, and let's put it over there, okay? Then inside, just say ready. Okay, now let's make a script to run this with the exact same name. So let's go into the UI folder, create a new C# script. Let's select the object, and let's add the script. So the character select UI. Okay, now here, first of all, let's grab the buttons. So as usual, a serialized field, private button for the main menu button, and another one for the ready button. Okay, Here in the editor, let's drag our references, so that one and the ready button, all right. And over here, let's add our click behavior. So let's make a private void awake. On awake, the main menu button. On click, let's add a listener. In order to go back into the main menu, first let's shut down the network manager, since on this scene we do have an active connection. So let's go the network manager, the singleton, and call shutdown. And then afterwards we can use the load. So that's a regular load, because right now we have shut down the network connection. And let's load back the main menu. Okay, great. And then for the other button, so the ready button, on click, add a listener. For this one, we just want to do the exact same thing we did on the testing script. So here the testing character select UI, we're running this, so let's run the exact same thing. So back in this script, just run that function. Okay, so that's it. Let's do a quick test. Before we do, let's just make sure to disable that one. All right. And again, as always, for testing, let's make sure to start from the lobby scene. So not from this one. Let's go into the lobby. Okay, let's make a build and test. Okay, so on this one, let's create a game. There you go, created. Then on this one, let's play. Let's join the game. Yep, we have joined. Now on this one, set as ready. And nope, nothing happens just yet. Now on this one, set as ready. And after a little bit, yep, they both load. Okay, great. So far, so good. Now let's go back into the character select scene and let's build a proper visual. So actually for that, let's first go into the main menu scene. And over here, let's copy some objects. So let's pick up the main camera. Let's also pick up the virtual camera, pick up the floor, the global volume, and the directional light. Okay, so let's copy all of these, Control C. Let's go into the character select scene, and let's destroy the main camera and directional light. So delete these, and press Control V, and there you go, we have our objects. Okay, so with this we have the basic visual. Let's just zoom in over here. All right. Now let's position the virtual camera. So let's put it on position 0, 1.4, and minus 3.7, with rotation on 2, 0, 0. Okay. Now here, let's create a brand new empty game object, name this the player 0. Let's reset the transform, and now inside, let's add the player visual. So inside the assets of prefabs, here is the player visual. Let's drag it on there. And there you go, there's the player. Let's just make them rotate to face the camera. And okay, so we have one player. Now let's just position 4 players. But actually before that, let's make this one a prefab. So let's drag the player 0 in order to make it a prefab. Let's name this the character select player. Now here, let's make all our 4 players. So the 0, the 1, the 2, and player 3. Okay, now let's position them. Let's position them not perfectly, so a bit more off, just to make it look a bit more interesting. So player 1, player 2. All right, so here we have all of our players. Now let's make the script to run this. So let's create a brand new C# script. Let's name it the same thing. So the character select player. And now let's make sure to add the script onto the prefab itself. So let's open up this prefab, and in here, let's attach a script. Okay, now let's open it. And over here, let's add the usual show and hide functions. Basically, we're only going to show as many as we have players connected. So a private void show, and a private void hide, and the usual thing, game object set active into either false or true. Okay, great. Now we need to handle the number of players that are connected, so we know which one of these we should show or hide. And then afterwards, we're also going to need to store the player data, like for example the color or the player name. So for that, let's go into the kitchen game multiplayer over here on this script. And the data type that we're going to use is going to be a network list. So this is kind of like a network variable, except obviously it supports a list. And for the type, let's actually make a custom type. This is a great way to learn how to serialize custom types. So first for the type, actually over here, let's make sure to save the prefab, go back outside, okay. And for the type, let's create a brand new C# script and call it the player data. Okay, so this is where we're going to store all of the data for the player. So for this one, let's make it instead of a class, let's make it a struct, since we're just going to hold some data, and this one does not extend mono behavior. Now for the data over here, right now, let's just begin by storing just the client ID. So a public ulong for the client ID, so just like this. And now back here on the kitchen game multiplayer, on this one, let's go ahead and make a field. So this is going to be a network list of type player data. And we have the player data network list. Okay, there it is. And right away, we do see we have an error. In order to use a type inside a network list, it needs to implement iEquatable. So let's do that. So back in our player data, over here, we need to implement iEquatable with a T of this type, so player data. Now let's use Visual Studio to help us implement this. So let's implement this interface. And just requires us to implement the equals function. So let's just return this client ID equals the other .client ID. Okay, great. And back in here, now we do not see any more errors. Okay, so far so good. Now for initializing this list, For a network variable, usually we would initialize it right here, except you actually can't do it up here. If you do it, you will get an error. And you also cannot initialize it on a network spawn. So in order to initialize a network list, it has to be done over here on the awake. So player data equals a new network list. Okay, so now that we have this list, let's populate it when a player connects. So let's listen to that callback. So over here on the start host, let's go into the network manager, the singleton, and let's listen to the on client connected callback. So let's listen to this and let's rename this. So the network manager. Okay, great. So when the player does connect, this parameter here is the client ID. When it does, let's go into the player data network list and let's add new entry. Let's create a new player data, and inside for the client ID, let's just use this client ID. Okay, great. So now when the player connects, we're going to update this list with new player. And over here on the character select player, in order to show or hide, we need to know when the list changes, meaning when a player either joins or quits. So over here, let's make an event to notify of that. Let's make a public event handler. Let's call it on player data network list changed. So when that list changed, let's fire it off. And for knowing when it changes, we can either manually fire it off over here, or we can also just listen to this. So listen with the on list changed event. So when this happens, we have this, and over here we fire off the local event. So on the player data network list changed, let's invoke this. Okay, great. So now we have this event. And now back in here, we can listen to it. So on the private void start, let's listen to this event. So that's on the kitchen game multiplayer, the instance. Let's listen to this event. Let's rename this as usual. When this event happens, we want to basically show or hide this character select, if this one is meant to be shown or hidden. So for that, we really just need an index to know which player this object represents. So up here, let's add a serialized field, private, a simple int, and call it just player index. Then back here in the editor, let's just assign it. So this one start off on index 0. This one, let's give it index 1. This one, index 2. And this one, index 3. Okay, great. And over here, let's make a function to update the player. So private void update player. And on this function, basically let's check if this player index is connected. So for that, let's ask the kitchen game multiplayer. So over here on this script, let's make a function to do just that. Let's make a public, return a boolean, and just call it is player index connected. And we're going to receive an int for the player index. And over here, we basically just need to know if the player data network list, if that one has this index inside of it. So we just return this player index is under the player data network list dot count. If so, then this player index is connected. So back in this script, we just check if the kitchen game manager, the multiplayer, if this one is player connected, and we pass in this player index. So if this one is connected, then let's show. And if not, then let's hide. Okay, great. So then for updating the visual, we just update, first of all, over here on start, and then of course over here when the list changes. Okay, so that's it. Let's test and see if the correct number of players are shown. Again, for testing, as always, let's make sure to test from the lobby scene. Okay, let's see. Okay, so here let's create a game, and nope, right away we do see an error. In order to use a custom data point, just like we saw, we need to implement iNetwork serializable. If not, then we have this error. So over here on the player data, let's make sure to implement that. So implement iEquatable and then iNetwork serializable. So let's implement this one and let's use Visual Studio to help us implement. So we just need to implement this function. And actually this is super simple. We just go into the serializer, so that's this parameter over here. And we just call serialize value and just pass in the reference for all the values in our struct. So in this case, we only have the client ID. So we pass it in, although importantly, this one is a ref parameter. Okay, so that's it, just like this. Here we are serializing the client ID, so we are serializing everything on the player data. So like this, it should work, so let's test. Okay, so here let's create a game. And yep, there you go, right away we don't see any errors, and we also see only one player connected. Okay, so that is correct. Now on this one down here, if I head on play and then join, and yep, there you go, player 2 is now connected. Alright, awesome. So now that we have the visual showing, let's show the ready state. So for that, let's go inside one of these prefabs. And over here, let's create a new, let's go into 3D object, and let's create a world text. Let's put the width and height on 0. This is going to just say ready. Let's pick a much smaller font size, lift it up by a bit, and as usual, let's put it down center, down the middle, wrapping disabled. Okay, there it is. We have our simple ready marker. Now this one is actually reversed, as you can see. That is basically how text works. Usually for text, you see it from behind instead of front ahead. But that's super simple to change. Just over here on the scale, let's put just -1 on the X, and there you go, now it faces perfectly. Okay, so let's name this our ready text. And let's go in the character select player. And over here, let's just add a reference, so a serialized field, private. Let's just use a game object because all we want to do is enable or show it for the ready game object. And back in the editor, let's drag the reference, exit the prefab, and save the changes. Okay, so now we have these ready counters. All we need to know is when this player is ready. So for that, let's go into the character select ready. This is the one that we made in the previous lecture. This script has the dictionary, and over here the server is handling all the state, so whenever a player sets as ready, it sets that as true. However, the one issue is that over here, this dictionary is only synchronized on the server. Note how this isn't a network variable or anything, it's just a regular normal dictionary. Meaning that all of the clients have this variable, but only the server is actually setting the ready state over here. In order to show the ready visual on all the clients, we also need the clients to know who is ready. So this is pretty simple, let's just make a client RPC to tell the clients. So a private void, let's call it set player ready client RPC. Let's make this a client RPC. And as a parameter, let's receive a ulong for the client ID. Then over here, we really just access the player ready dictionary on this client ID, and we set this one to true. So that's it, very simple. And we just trigger the client RPC up here. So on the server broadcasts the same message to all the clients, so pass in the same standard client ID. Okay, so that's great. So now all the clients know all the clients that are ready. All we need is to fire off an event to know when this changes. So up here, let's make a public, an event handler, call this on ready changed. So we have this event, and then over here, after setting it, let's invoke the event. So this event hours.empty, okay. So now back in the character select player script, over here, let's listen to that event. So that's on the character select ready. On the instance, let's listen to the on ready changed event. Let's rename this as usual, keep things nice and clean. So the character select ready. And when this happens, let's call our usual update player function. And over here on this function, so we show the player, and then for the ready game object, we're going to set active based on if this player is true or not. So for that, let's make a function to get the ready state. So back in this script, let's make a simple function down here. So a public bool just is player ready, and we're going to receive a ulong for the client ID, and simply returns the player ready dictionary on this client ID. Okay, that's it, very simple. And over here, we're going to access that function. So the character select ready. Let's test if is player ready. Except over here, an obvious question is we need the ulong for the client ID. So over here, we need to somehow get the client ID based on the player index. So let's go into the kitchen game multiplayer to get that. Over here, let's make a function to get a certain player data. So over here, let's make one. So a public player data, call it get player data from player index, and receive an int for the player index. And we just return the player data network list on this index, so the player index. Okay, so that's it. This way we can get the player data, and then from the player data we can get the client ID. So back in this script, let's get the player data. We go into the kitchen game multiplayer, the instance, let's get the player data from the index. Let's pass in this player index. And then from this one, we can grab the client ID and we can see if this one is ready. And we also need to make sure that this one has the key, so contains the key on this client ID. Okay, so here let's create a game, and there you go, there it is. Now on this one, let's play, let's join the game. Okay, we have 2 players. Now on this one, let's set as ready, and yep, there you go, we have a nice ready counter, and yep, it is synchronized. And now on this one, let's ready as well, and yep, there you go, the usual ready logic works, and the game does start playing. Alright, awesome. Okay, so next let's handle the player callers. First, let's actually start by defining the callers. So let's go over here onto the kitchen game multiplayer, and let's make that. So let's make another serialized field. Let's make it a list of type caller. Call it the player caller list. Now back here in the editor, let's assign the callers, and that object is created on the lobby scene. So let's go there. Here we have the kitchen game multiplayer, and yep, let's add all of the callers. So let's add 10 callers. Let's start off with a simple nice yellow as usual. And again, importantly over here, make sure to set the alpha on 1 on all the callers. So we have a yellow, then let's have maybe a nice green. After that, maybe a nice orange. Then a nice light blue, something like this. After that, let's go with a nice purple, maybe something like this. Then let's go with a bit more pink. Then maybe perhaps a darker blue. And after that, let's go with some basic ones. So let's go with one in pure white. Let's go one a bit in the middle. And let's go to one almost black. Okay, great. Here are all the colors. Again, make ssure you have all of them on alpha set as 1. You can see the little bar down here, the little white bar. If the alpha is on 0, then it's in black, so make sure this one is fully alpha as 1. Okay, so we have defined all the colors. Now let's make a script to handle the player visual and apply a color. So let's create a brand new C# script, call this the player visual. And now for attaching this, we want to attach it to the visual itself. So let's go back into the character select scene, let's save it. And over here on this one, we do not want to attach it just on this prefab. So let's open up this prefab, then we have the player visual, and let's also go inside the player visual, and now here we add it. So let's add the player visual component. We want to make them like this so that this script is also attached when we go into the game scene. Okay, let's open this script. And on this one, let's begin by adding a field for the body and the head mesh. So a serialized field, private for a mesh render, for the head mesh renderer, another one for the body mesh renderer. Okay, back in the editor, let's drag them. So drag the head and the body. Okay, great. And now in order to make sure that each player uses a different color, we need to make sure to use a different material for each of them. So over here, let's store a material for our material. And now importantly, let's make a private void awake. And then awake, for this material, let's construct a new material using the current material. So basically we're going to clone it. So let's go into the head mesh render, grab the material, and this is going to clone the exact same material. So we do that, and then we go into the head mesh render, set the material to this material, and same thing for the body. So this way we are making a clone, so it doesn't apply to anything else. If you don't do this, then changing one material won't change the visual on all the players since they would all share the same material. Okay, so now let's make a nice function to set a color. So a public void set player color, and we're going to receive a color. And over here, very simple, just set the material.color into this color. The material is already being used by the body and the head, so just modifying the material color will already change the visual. Now we want to set the color right away, so let's do it on a private void start. So let's call set player color. And to do that, obviously we need to know which color to use. So let's go here onto the kitchen game multiplayer, and let's make a function to get a color. So down here, let's make that simple function. So public, return a color, call it get player color. And we're going to receive an int, and let's call this the color ID. We're going to store the color ID in the player data in a little bit. Over here, we just return, going to the player color list, and let's grab the color ID. Okay, so with this, we have a color. And over here, we can go into the kitchen game manager, the instance, and get the color. And we need a color ID. And for now, let's use the player ID as the color ID. But again, over here, we have a problem. We don't have any player ID. So we can either make a function to set the player index and store it over here, or we can just call it from elsewhere. So actually, instead of setting the player color over here, instead of that, let's go over here onto the character select player, and let's add a player visual. Back in the editor, let's drag the reference, so let's exit out of this prefab, save the changes. And on this one, let's drag the reference to the player visual. And on this one, we do have the player index. So now here we can do that. So when we update the player, we're already grabbing the player data. So let's go into this one, set the color. Let's go into the kitchen game multiplayer. Let's get the color and let's pass in the player index. Okay, that should do it. So now the second player should have a different color. Let's test. And now here, if we create, and there you go, that one is using default color. Now on this one, if we join, and if there you go, we have the second color. All right, awesome. So now that the colors are working, let's make a UI to manually select a different color. Over here on the character select scene, let's go inside the canvas, and let's create an empty game object. Call it the character color select UI. Let's zoom in on it. Okay, like this. Now inside of it, let's make a button. So inside a new UI button, let's call this color 0. We're going to basically dynamically change the color of this button. So let's put it with a width and height of 100 by 100. And inside, let's get rid of the text. We only want an image. Okay, so this is our color button, but instead of a square, let's go with a circle. So let's select, let's say, the default knob sprite. Basically, through code, we're going to modify the color here in order to set the color that this one will change. And now inside, let's make another UI image and call this the selected. And for this one, for the sprite, let's say over here, the circle dashed. Let's put it to stretch to occupy everything and put it just a little bit smaller. So 5 on all of these. And that one is barely visible. So let's also add an outline. Let's make it in full alpha and put it maybe a little bit bigger. Okay, so just like that. This is going to be a single button. And now for spawning this, we can do it dynamically. So just by spawning templates, just like we've already done so many times before, or we can just make it manually. Let's make it manually since we already did quite a lot of things dynamically. So on the parent for organizing, let's create a horizontal layout group. Let's put it right down the middle center, and let's add a little bit of spacing, okay? Then inside, before we duplicate this, let's actually make this into a prefab. So let's drag it. Let's rename this to a more proper name. So character color select, this is the single UI. So to select a single color. And now let's place 10 colors. Okay, let's give them proper names. And over here on the parent, let's stretch it out, choose this one. So it stretches on the left and the right. And then for the position, let's put it a bit more down there. And also this is a bit way too much space. So over here on the child force expand, let's not expand on the width. Okay, just like that, those are some nice buttons. Now let's make the script to run this. So with the exact same name, let's create a brand new C# script for our character color select UI. And now let's make a script to run this. Except we're going to attach the script to each button and not to the actual main container. So on each button, let's go inside the prefab and let's make a script with the exact same name. So let's create a brand new C# script. Let's attach it to the prefab itself. So right over here. So the character color select single UI. All right. Now let's open it. And over here, first, let's add a whole bunch of fields. So a serialized field. First, let's add an int for the color ID. This is going to be different on a per button basis. Then let's add an image. So this is going to be the image that we're going to modify. So that's image, not image conversion. So image, the one inside Unity Engine.ui. Okay, we have the image. And then a game object for the selected game object. Okay, let's save. And back in the editor, let's drag all of our references. So first of all, for the image, that's this one up here. So let's drag the image. Then the color ID, we're going to set it outside the prefab and drag the selected. Okay, great. So now let's go outside. Let's save the changes. And over here, let's set the indexes. So this one is on 0, this one is on 1, this one 2, and so on. All right, we have all of our color IDs. Now over here, let's make a simple private void start. And on start, let's basically set the image color. So for that, let's go into the kitchen game multiplayer, the instance, and let's get the player color. And this one takes a color ID, so let's grab this color ID and set the image.color on this color. Okay, so that sets the image color. Then we need to know if this color is selected. So let's make a private void, call it update is selected. And on this function, basically we need to know if the local player is selected or not. So for that, over here on the kitchen game multiplayer, let's make a function to get the player data for the local player. So let's make a public return the player data. And let's call it just get player data with no parameters. And with no parameters, we can basically just go into the network manager, the singleton, and get the local client ID. So now we just need to get the player data with this client ID. So let's make another function to do that. So public return player data, call it get player data from client ID. And we're going to receive a ulong for the client ID. And over here, it's pretty simple. Let's just cycle through our player data. So player data in our player data network list. So we cycle through that. And if the player data.client ID matches this client ID, then yep, this is the one that we want. So let's return the player data. If we get down here, then we didn't get it. This one is never going to reach here, but still, we need to return just a basic default. Okay, so we have this one. So then down here, let's get the player data with the local client ID and return this. Okay, so now we have the player data for the local client. And now back in here to test if this color is selected. Let's check if the kitchen game multiplayer instance, let's get the player data for the local player. So get the player data. If this one .color ID, so we need to store the color ID on the player data. So over here on the player data, we're synchronizing the client ID, and let's also store an int for the color ID. And let's make sure to update all of these. So this one equals if the client ID equals and the color ID equals the other .color ID. And for serializing, we also need to do the same thing. So the color ID. Okay, great. So now back in this script, we have the player data. Let's grab the caller ID. And if this one matches the local caller ID, if so, then let's go into the selected game object, set active into true. And if not, let's set active into false. And up here on start, let's go ahead and modify this. And yep, just like this, it should work by default. Now, of course, the one missing thing is when we change color, but let's actually handle that first before we handle the event. For change the color, it's going to be by clicking on this UI button. So let's make a private void awake. And the button is on this object itself. So let's do a get component of type button. On this one, let's add a listener to the onClick event. So when we click on this button, basically we want to tell the kitchen game multiplayer to change the color. So let's go into the kitchen game multiplayer onto the instance, and let's call some function to change player color. And we're going to change the player color onto this new caller ID. Okay, so we just need to make this function. So back here on the kitchen game multiplayer, let's make that function. So here, public void, and we're going to change the player caller onto this new caller ID. And to do that, as always, we're going to first run the logic on the server. So we're going to need a server RPC. So a private void, change player caller server RPC. We're going to receive an int for the caller ID. And then we also need to know which player is changing caller. So let's receive the usual server RPC params. And let's default them. Okay, so this is a server RPC with require ownership as false. So when we change the caller, let's trigger the server RPC, pass in the caller ID. All right, so here we have a nice server RPC, and this player is asking to change their caller. Now, first of all, let's do some basic validation, just to make sure the caller is unused. Although this is a design decision, if you wanted, you could allow the same callers for multiple players, but here I'm not going to allow that. So let's make a function to check if a caller is available. So private bool is caller available, going to receive an int for the caller ID. And on this one, let's just cycle through all of the player data and see if any of them is already using this same caller ID. So let's do a for each player data in the player data network list. And on this one, if the player data, if this one dot caller ID matches this caller ID, then this one is not available. So this one is already in use. So let's return false. And if we get down here, then this caller is available. So let's return true. So now up here on the server RPC, we can check, first of all, if the caller is not available. So is caller available on this caller ID? So if this one is not available, then caller not available. And if so, we're not going to do anything. So let's just return. But if it is available, then let's basically update the player data. And how you do that, remember that on a player network list, we're using a struct. So we first need to grab it, then modify it, then update it. So in order to grab it, we are going to need the player data index. So let's make a function to convert a client ID onto a player data index. So it's actually going to be very similar logic to this one, except we return an int. And over here, instead of for each, let's do a simple for. So for cycle through this list.count. And then we just check if this one on this index, if the client ID matches this client ID. If so, then let's return this index. And if not, let's return -1. So this returns the get player data index from the client ID. Okay, great. So we have this function. And then down here, let's grab that. So an int for the player data index. And we call that function and pass in the server RPC params. Let's go into the receive and the sender client ID. So with that, we have the player data index. Then let's grab the player data, and we go in the player data network list on this player data index. So we grab this player data, now we modify it. So let's modify the caller ID to the new caller ID, and then we need to save it back onto the same list. So we access it on the same index, and we set player data equals this. Okay, just like this. When working with network lists, you need to do this. If you just were to do just like this, .caller ID equals caller ID, if you do it, yep, you have an error. You cannot modify it directly. So that is why we need to first grab it, then modify it, then upload the new changes. Okay, so this will update the caller, and let's also default the caller when a new player joins. So if we go up here, when we are creating a brand new one, we are constructing a new player data. So over here, let's set the caller ID to something, and let's set it to the first unused caller. So down here, let's make another nice helper function. So private int get first unused caller ID, and let's just cycle through the caller array. So for int e equals 0, let's cycle through the player caller list.count. And then just check, is caller available? So is caller available on this caller index? If it is available, return this one. If not, then we keep cycling. And in the end, it will never reach here because we are not going to have 10 players. But still, let's return just -1. Okay, so we have this function. And then up here, when a new client joins, let's give them the first brand new unused caller ID. Okay, so after all that, all the clients should have a different caller ID. All that's left is over here on the button, so we change the button in order to modify the caller ID, then we just need to update it. And how we're going to do that? Well, since we're modifying the list, we can just listen to that event. So on the kitchen game multiplayer, the instance, we have the event on the network list change. So when this list changes, when this happens, then let's just update the actual visual. So this one, just like this. Okay, so with this, let's test. Just one final thing, which is over here on the character select player. Over here, we made it just using the player index, but now we already have the caller index. So let's go into the player data, grab the caller ID, just like this. Okay, so let's test. Okay, so on this one, let's create a game. And yep, right away, we do see the whole UI with all the colors. And if I click on them, yep, you do see the player does change the color. Alright, so that's awesome. Now on this one down here, let's join the game. And there you go, it does choose the first available color, so it chose the green. And if I try selecting a different color, and yep, it works. And if I try selecting the same color, and nope, that one does not work. Okay, great. And now if we both ready and go into the game scene, and yep, this is the only thing that we still need to do. We need to update this color. So for that, we have two options. We could go over here onto the player script, add a reference to the player visual and set the color. Or we could do it over here on the player visual. The only thing is we would need to modify the mono behavior in order to make it into a network behavior. That way we could know which owner owns this player visual. So both options are valid. Let's do it over here on the player, just so we don't mess up anything and add a network object onto just the visual. So let's add a new one for the player visual. Back in the editor, let's go inside the player prefab and let's drag the player visual reference. Okay, there it is. And over here on start, very simple, just call set color. So we need to pass in the player color. So let's grab the player data, go into the kitchen game multiplayer, the instance, get the player data. And now we don't want just the local player. We want it for this owner client ID. So we need to make a function that takes a client ID. We already have, it's this different one. So let's use this one to get the player data, and then set the player color, go into the kitchen game multiplayer, the instance, get the player color, and use the player data.color ID. Okay, so let's test. Okay, so here let's create the game. On this one, let's go with a purple. Then on this one, play, let's join. On this one, let's go with a light blue, let's ready, and on this one, ready. And the game is loading. Let's go, and there you go. We have two players with two different colors. All right, awesome. Okay, so everything is currently looking great. But here on the character select scene, we actually have one issue. Now, if I disconnect this player, and nope, that one did not disappear. And now if I try connecting a brand new one, so join the game, and there you go, that one took another spot, even though that player has now disconnected. Basically, the issue is with our network list, we need to remove the players when they leave. So over here, let's listen to the other callback over here on the host. We already have one down here on the client. So let's actually rename this to give it a more proper name. So client on client disconnect callback. And then up here, let's make another function. So network manager singleton on client disconnect callback. And here, let's give it a different name. So on the server, okay, let's make this one. So over here, we have the client ID of the client that just disconnected. So then let's just cycle through it. So for int on the player data network list.count, let's cycle through it and see if it was this one. So the player data. So we check if the player data dot client ID matches the one that was disconnected. Then it's this one that was disconnected. So now let's just remove it from the list. So player data network list, and let's call remove at and remove on this index. Okay, and just like that, everything else should be working because everything else is listening when this one changes. So let's test. Okay, so on this one, let's create the game. On this one, let's join. Okay, now disconnect, and yep, there you go, that one is gone. Okay, great. Now, one more thing, let's add the ability for the server to kick a player. So let's go on the character select scene. Let's go inside this player prefab. Let's zoom in and look at it. And on this one, let's add a button. So let's go into UI. Let's create a new UI button. Let's call this the kick button. And for the canvas, this one, let's make it a world space. Put it on 0, 0, 0, everything on 0. Let's lift it up by a little bit. And for the kick button, let's get rid of the text inside it. We just want an image. So let's put this one really small, so maybe 0.3, 0.3. And let's lift up the canvas by a little bit. Okay, something like this. And for the image, instead of this one, let's go with the nice cross sprite. Okay, it's actually a bit too big, so maybe on 0.2, 0.2. All right. Now on this script, let's add a reference to our brand new button. So the button for the kick button. And over here, let's drag the reference to the kick button. Okay. And now, first of all, we need to make sure that this one is only visible to the server. So over here on start, let's put this one, game object set active. And it's only going to be active if the network manager.singleton.is server. So this one is only going to be visible on the server. Then let's add the click function. So private void awake. On the kick button, the on click, let's add a listener to it. And now on this one, let's make a function to kick the player. So let's go in the kitchen game multiplayer. And over here, let's make a function to do just that. So public void kick player. And we're going to receive a ulong for the client ID. And over here, it's actually very simple. Let's access the network manager, the singleton, and let's just call disconnect client. And over here, we pass in the client ID, just like this. Then over here on this one, we just need to know the client ID. So let's grab the player data from this index. And from down, let's go into the kitchen game multiplayer, the instance, and let's kick this player, so the player data, and it has the client ID. Okay, so this is going to disconnect that client. However, just like this, there's actually going to be no visual. The client will be disconnected, but it will still look like it's still on the same server. So let's add a nice visual. And for that, we can actually go into the game scene, and over here inside the canvas, we previously already made over here the host disconnect UI. The logic is going to be exactly the same, so let's just copy this, go inside the character select scene, inside the canvas, and let's paste it. And there you go, the host disconnect UI. Although we just have to do one change. Over here on this script, we are listening to the event. And one thing like we saw previously, on this scene, the character select scene, this script isn't going to have the same lifetime as the network manager. This UI object won't be destroyed as the network manager lives on. So we need to do just like we did before, we need to clean up this event. So let's make a private void on destroy, and on destroy, let's make sure to unsubscribe from this event. So let's do minus equals like this. Although at the same time, I'm not entirely sure what is the order of execution. And now there's still one more sneaky issue. For some reason, when kicking a player, that doesn't actually trigger the disconnect callback. So the function that we have up here to clean up the list, this one is not going to be automatically triggered. So let's make sure to manually trigger it. So when we kick a player, let's click them and then call the same function to update the list. Okay, so let's test. Okay, so here let's create a game. Then on this one down here, let's join it. And now the server doesn't like me for some reason, so the server is going to kick me. And there you go, host is disconnected, play again. And now I can try joining again, and yep, it works. Okay, great. Let's just handle one more final thing that we made quite a while ago. So here I joined, then I was kicked, then I joined again. Remember that the server does not reuse client IDs, so the client IDs are not sequential. So actually what we have here is the server is on ID of 0 and this one is on ID of 2 because the one was kicked. So let's actually kick this one a few more times. So let's kick and join again. So now this one has an ID of 3. Now let's kick again and join again. So now this one has an ID of 0 and this one an ID of 4. So now if we hit on ready, and if there you go, there we have our error. We can see where this area is being spawned over here on the player. And yep, it's this code that we wrote quite a while ago. So it's using the owner client ID, and the spawn position list only has 4 positions. So over here, instead of positioning the players based on the owner client ID, instead of that, let's use the player index. So let's go into the kitchen game multiplayer, and let's get the player index, and pass in the owner client ID. Okay, so let's see. Okay, so create, so this one now has index 0, and let's join. And on this one, instead of being kicked, let's actually leave voluntarily. And let's join again. So now this one has index 2, and let's leave, join again. That one has index 3, leave, join again. Okay, so now we have index 0 and 4, and if we both hit on ready, and if there you go, it does work, and they are positioned perfectly exactly where they should be. All right, awesome. Now there's just one more thing we need to clean up, which is over here, let's create a game. Over here, let's play, let's join. Okay, let's hit on ready, and both start playing the game. And yep, okay, everything seems correct. And on this one, I'm going to disconnect. And there you go, we have an error. We can go and see where it is. And yep, it's right in here, so it's the same problem as previously. We got an event, but the kitchen game multiplayer, this one is living longer than this one. So we need to make sure to unsubscribe from these. So as usual, private void on destroy. And on destroy, let's unsubscribe from this event. Let's see where else we are adding listeners. Over here on the character select player, the character select ready has the same lifetime, but this one we need to unsubscribe. So the same thing. Private void on destroy, and let's unsub from this event. Okay, I think those are the only two, so let's test. So let's create the game. On this one, let's join, set as ready, and let's go inside. And over here, yep, it's working. Now let's go outside, and if there you go, no more errors. All right, awesome. Okay, so here we created a really nice character select scene. It supports joining players, then each player can customize their color. The server can kick the players, and each player can set their ready state. When they are all ready, the game finally begins. So with this done, the next thing we really need is handling the lobby, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to create our lobby scene where the players can create games and then other players can browse the games and join them. Okay, so here let's build our lobby. Now this is a tool that I've covered in detail in a previous video, so pause the course right now to go watch that one. In there I cover pretty much everything about this tool. Here I'm focused mainly on using the tool rather than explain every single thing, so I will assume that you've seen that video. Okay, so first of all, we need to install the package. So let's open up the package manager. Let's go over here on the Unity registry under all, and let's look for the lobby. So here it is. Let's go ahead and install. Okay, there it is, it installed. And over here in the dependencies, it also installed as a dependency the authentication package. Okay, so that's great. Let's close this window. And right away, we see this window. Basically, in order to start using Lobby, we need to enable it in the Unity Gaming Services. So that means we need to go onto the project settings. But before we do, let's make sure we are signed in. So up here on the top left corner, there should be a button and it should be with your account. If this button is disabled and says sign in, then go ahead, close Unity, open the Unity Hub, and make sure you are signed in there. Okay, so with that, then you can click on this button to go to the project settings, or just manually go into edit project settings, and out go into the services. Now over here, we can create a brand new Unity project, or we can use an existing one. So if you already have one, you can link it, or you can also go to the dashboard and create one there. So here I am on the Unity dashboard. I'm going to go and select the projects and create a brand new project. Going to call this Kitchen Chaos Multiplayer. And nope, this one does not target children. Okay, let's create. All right, the project was created. Great. So now back here into Unity, we can select the organization and then go ahead and select the project. So I'm going to select the one that I just created, so Kitchen Chaos Multiplayer, and just go ahead and link the project ID. All right, so the project has been linked. That's great. Now let's go back here onto the Unity dashboard, and we need to enable Lobby. So let's make sure the project is selected, and then let's go over here on the left side to Multiplayer. Then let's go into the Lobby. And over here, let's click the button to set up Lobby. And then we've got a bunch of basic steps. So first of all, link the Unity project, and yep, we already did this. Then install the package, already did this. And finally, turn the Lobby on. So let's click and turn it on, and there you go. So let's go on next, and yep, there you go, we are finished. Okay, great. So Lobby is now enabled. With that, let's begin using it. And again, here I'm going to assume that you've seen that Lobby video and you have a basic idea for how the API works. Here we're just mainly going to use it. So first, over here on the Lobby scene, let's begin by creating a new empty game object. Call it the Kitchen Game Lobby. Let's reset the transform and let's make a script for it. So a script with the same name. And let's go ahead, add the script and open. Okay, so now here on this script, we're going to handle everything related to our lobby. And since we're also going to need to access the lobby when we enter into the character select scene, in order to get things like the lobby and the code, in order to do that, let's make sure to also mark this object as don't destroy unload. So let's make a private void awake. And over here, let's make sure to set don't destroy unload and don't destroy this game object. Okay, so that's great. And since we're doing this, we also need to mark it for cleanup. So over here on the main menu cleanup button, let's make sure to destroy it. So let's also implement the singleton pattern. So back in here, make a public static kitchen game lobby for the instance with a get and a private set. On awake, set this one equals this. Okay. So now over here on this side, let's do the exact same thing. So let's go into the kitchen game lobby. And if this one exists, let's clean it up. Okay, great. So now over here, let's first begin by initializing the Unity services. So let's make a function to do just that. So initialize Unity authentication. Here we first go into Unity services, which is inside unity.services.core. And let's call initialize async. Then as usual for these functions, these are meant to be awaitable. So let's await. And since we are calling it with await, up here we need to make sure to use async. Okay, so that is going to initialize, and we're going to call it up here on our await. All right, so that is going to initialize Unity services. And afterwards, let's go inside the authentication service. So it's this one, inside Unity services authentication. Let's access the static instance, and let's sign in anonymously. And once again, this one is also an awaitable call. Okay, great. Now, one thing, the way we have set up this object is it won't be destroyed and then recreated whenever we go back to the lobby. But you cannot initialize the services more than once. If we do, then we're actually going to have an error. So we need to make sure we only run this once. And for that, we can access the Unity services. And over here, we have a state. And there's a bunch of states. Like, for example, we can check if it is not initialized. So if this one is not initialized, so if it is not initialized, then we're going to initialize it. Okay, that's good. Now, one more thing, which is Lobby works based on the player ID that the authentication service generates. And if we run multiple builds on the same PC, they will actually all have the same player ID. So if we do it just like this, we can't actually test with multiple builds because they're all going to have the same player ID. So to solve that, we can basically initialize with a different profile every time. So up here on the initialize async for the Unity services, this one takes a initialization options. So let's create that. Let's create the new initialization options. And on this object, we can then call set profile, and we can pass in some profile name. So basically we want to pass in a new unique name every time, just so we can run multiple builds for testing. So in order to get a new name, let's just do random.range and generate a random number. This one requires a string, so let's just do toString like that. Okay, so now this will initialize with different name every time. Okay, that's great. So with this, we can test with multiple builds. So this handles the authentication part. Now let's handle creating and joining a lobby. So over here, let's make a simple function. Let's make it public because we're going to call it from the UI script. Void, call it create lobby. And to create a lobby, we're just going to need a string for the lobby name and then a boolean for is private in order to create either private or public lobbies. Then over here, the way we create, we go inside the lobby service, the instance, and we call create lobby async. This one takes in a lobby name, so let's pass in the lobby name. Then it takes the maximum number of players. And we actually already defined that over here on the kitchen game multiplayer script. We've got a constant for the max player amount. Let's just make this one public. So now back in here, we can go into the kitchen game multiplayer and grab the max player amount, okay? And then for the is private, we need to create some options. So let's create some new create lobby options. And over here, we can set is private onto this is private. Okay, so this function is going to actually create a lobby. And as usual, this one is awaitable, and this one is going to return a lobby when it completes. So let's first of all put in await. And we want to keep track of which lobby we are either creating or joining. So let's go up here in order to define that. So let's make a private of type lobby. So it's this one inside Unity Services Lobbies Models. So this is going to be our join lobby. So this lobby that we have joined. And as soon as we create one, let's set this one equals this. And since we're using await, up here we also need to mark it as async. Okay, great. So this is going to create a lobby. And now one thing that I mentioned in the lobby video, which is all of these function calls, all of these can throw an exception. So in order to make sure our game doesn't break, we need to put this inside a try catch. So let's put a try, and then let's do a catch. We're going to catch a lobby service exception. And if we have it, let's just do debug.log on this. Okay, so this is going to create our lobby. And following through with our connection flow, after creating the lobby, we want to join our game. We want to actually start the host. So you can inspect over here the testing buttons that we were using previously. So we call start host and then load the scene. So let's do exactly this. So over here, after creating a brand new lobby, let's do exactly this. Okay, so this will create a lobby, and then we're going to start host and start going into the character select scene. Before we can test, we also need some way to join a lobby. So let's also make that function. So a public, let's call it quick join. And over here, we're going to use the super useful quick join function. So the lobby service, let's access the instance. And over here, let's just do the quick join lobby async. And as usual, let's await this, which means we need to mark this as async. And this one is also going to return the join lobby, so join lobby. And again, we need to put this inside a try catch for the lobby service exception. Okay, so with this, we join the lobby. And then for actually joining, all we do is start client. So let's do exactly that, exactly the same thing. Okay, great. So with these two basic functions, we should now be able to create a lobby and then join it. So for testing that out, let's make a nice UI window. Over here on the lobby scene, let's go into the canvas, create an empty game object, call this the lobby UI. Let's stretch it to occupy everything, so put 0 on everything. Now let's make some proper buttons. So inside, let's create a new button, and this is going to be the main menu button. And let's anchor it on the top left corner, so something like that. Push it up there, and push it like this. Then for the button itself, let's make it in a dark gray. And inside for the text, let's put it in bold, text in white, and say main menu. Okay, that's the main menu button, great. Now we want a button to create the lobby and one to do a quick join. So let's make those two. Let's duplicate this one for the create lobby button, and another one for the quick join button. Now let's just position these buttons. So let's put it over here, a bit off to the side, something like this. And let's modify the text inside of them. So this one, create lobby. And on the other one, let's do a quick join. Okay, we have these buttons, and we also no longer need the testing lobby UI, so let's hide that one. Okay, there you go, it's disabled. Now let's make the script to run this. So let's create a new C# script, lobby UI. Let's go ahead, attach the script and open. And now here, let's make the usual thing. So let's grab our buttons. So a serialized field, private button for the main menu button, and then another one for the create lobby button, and finally the quick join button. Back here in the editor, let's drag our references. So the main menu, the create lobby, and also the quick join. Okay, great. So now here, let's make our behavior. So on awake, let's add some listeners. So the main menu button, the on click, let's add a listener. And for this one, it's very simple. We just go back to the main menu. So we just do loader.load. So we use load, not load network, because over here we still don't have an active connection. So let's use load. And for the scene, let's go back into the main menu. Okay, that's it. Now for the other two buttons, so the create lobby and the quick join. For the create lobby, let's go into the kitchen game lobby, the instance, and call create lobby. This one takes a lobby name and then is private or not. So for now, let's just send in lobby name. And then is private, let's put it as false so we can join with quick join. And on this one, same thing, kitchen game lobby instance, and let's just do a quick join. Okay, great. So these buttons should be working. Let's test. Okay, so now on this one up here, let's go ahead and create a lobby. And if there you go, it does go into the character selection screen. Okay, so that's great. And on this one down here, let's hit on play, and now let's do a quick join. And if there you go, they both connected. All right, awesome. Now I should point out one very important thing here, which is right now, this is actually not really joining this specific game. If we made a second lobby, it would still join on the exact same game. The reason for that is because we are still hosting and connecting to the same IP on the same port. If we look on the Unity transport, in order to connect to an IP, you need to set it here. We didn't set anything, so we are still hosting on localhost on this port. So if we made another lobby, it would still be hosting the exact same IP, exact same port, so exact same session. In order to make an actual separate instance of a game, we would need to host on a different IP, and then we would need to use that IP in order to make a direct connection, or the alternative is to use Relay, which is what we're going to implement in the next lecture. So I just want to quickly point that out right now. Right now, this is creating separate lobbies, but not separate sessions. That will be handled when we set up the relay in the next lecture. Okay, so like this, we have the basic create and quick join working. Now let's expand upon it and make a window to define some options when creating a lobby. So back here in our lobby scene, let's create an empty game object, call it the lobby create UI. Inside, let's make a UI image. Let's name it the background. Let's make this one stretch to occupy everything. Let's put it in black. And let's stretch out the parent a little bit. So let's size it to occupy something like this. Okay, great. Let's put it on X of 0. All right. Now inside, let's also make a simple text, just a nice label. So for this one, let's just say create lobby. Let's put it in bold, center, middle, no wrapping, and width and height on 0, 0. Okay, so the usual setup. Then we need some way to input the lobby name. So inside, let's create an input field. Let's call this the lobby name input field. Let's move it a little bit up there. And over here on the inspector, we can play around the input field. And let's put it on a dark gray, something like that. Then let's go inside it, inside the text area. And here for the placeholder, I actually don't like this. So basically there's a visible intertext before you actually input something. But personally, I don't really like this, so I'm going to delete this. And for the text, let's just put it on white. And now if we go back into the lobby name input field, down here we can set default text. So let's just say lobby name. Okay, let's just make it a little bit bigger. Something like this. Okay, great. So we have a lobby name. And then the other option is really just creating as either a public or a private lobby. So let's make two buttons for that. So let's create a new button. Let's call it create public button. Inside, let's say create public. Let's put the usual thing. So in white, in bold, and for the button, put it in a dark gray. Something like this, okay? So we've got the public button, and then let's make another one for create private. So the create private button. Inside, let's make create private. Okay, so those are really all the settings we need in order to create a lobby. And let's just make a close button just to be able to go back and close this create UI. So let's create a new UI button. And for this one, let's put it up there. So let's anchor it on the top left corner. And instead of using the UI sprite, let's use our nice cross sprite. Let's make sure to put it on something like 4040. And get rid of the text inside and name this the close button. Okay, so that's the basic layout we need. Now let's make the script to run this. So let's create our script with the exact same name, lobby create UI. Let's attach the script and open. Okay, so now here it's going to be super simple. First, let's grab our input field and our buttons. So a serialized field, For the button, so we have the close button. So this is actually of type button. Then we have another one for the create public button and the create private button. And then we also have the input field. So for that one, the type is actually the TMP input field. So it's this one. Here, don't make a mistake. We use Text Mesh Pro, so it is not the regular input field. It is not this one. It is the TMP input field. So this is the lobby name input field. Okay, we have all of our fields. Over here, let's set them. So the lobby name input field and the create public button, the close button, and the create private button. All right, great. So over here, the logic is going to be super simple. So on private void awake, over here, let's just add listeners. So on the create public button, let's onclick, let's add a listener. And for the listen, we're going to go into the kitchen game lobby on the instance, and let's create a lobby. And for the lobby name, let's use the lobby name input field. Let's grab the text from there. And for the is private, this one is the public button, so let's set it as false. And for the other button, very simple. So the create private button, for this one, just set it as private. All right. Then for the close button, so the close button, for this one, we want to hide this window. So let's make the usual show hide function. So private void show. And the private void hide. And the game object set active into either false and appear into true. Then as usual on private void start, we're going to start off hidden. And when we press the close button, let's also hide it. Okay, so that's it. Now over here on the lobby UI, we just need to show that. So let's actually make another reference of type lobby create UI for the lobby create UI. And here in the editor, let's drag that reference. So on the lobby UI, let's drag that one. And then super simple over here on create lobby, let's just go into the lobby create UI and call show. So we just need to make that one public. So up here, just make this one public. Okay, that's it, super simple. So here we just call the exact same function. Okay, great. Now, if we do end up creating a private lobby, we need to be able to show the lobby code so that people can actually join. So for that, let's actually go into the character select scene. Let's go into that one. And over here for this one, we need some element to say that. So let's actually go into our generic character select UI, and inside, let's create a new text object. Let's call this the lobby name text. And let's put the usual setup, and let's actually hide this host disconnected window just so we can actually see that. So over here in the hierarchy, let's hide that one. Okay, so we have the lobby name. Let's put it in bold, maybe a little bit smaller. So 24, and the usual setup, so width and height of 0. Put it center, down the middle, disabled, and up here, let's anchor it to the top corner. So let's anchor it to the top. And this one is going to say something like lobby name, and then the lobby name. Okay, so that's all we want, and then let's duplicate this one, and for this one down here, let's name this the lobby code text. And over here, same thing, we're going to say lobby code, and then say some kind of code. Okay, that's good. So now let's open up this script, and let's first of all add our references. So the Text Mesh Pro UGUI, since we're working in the UI, for the lobby name text, and another one for the lobby code text. Over here, let's drag our references, so the lobby name and the lobby code. Then all we need to do is set it up. So let's do it over here, private void start. So on start, we need to get the actual lobby. So we go into the kitchen game lobby, the instance, and we need the function to get the actual lobby. So let's make this function. So over here on the kitchen game lobby, we basically just need something to return this join lobby. So let's make that one. So public going to return a lobby, get lobby, and we just return our join lobby. Okay, like this. So now over here, we can grab the lobby. And the lobby is actually inside this one. So we grab the lobby. And over here, we're going to assume we always have a lobby since we only connect this scene when we have joined the lobby. Then on this one, let's just go lobby name.text. And we're going to set it to lobby name. And then let's go into the lobby and grab the lobby name. And then for the code, same thing, we just grab the lobby code. So this is the lobby code and the lobby code text. Okay, so that will show both the name and the code. All that's left before we can test is basically just setting a way to join by the code. So let's go back into the lobby scene. So let's go back into the lobby scene. And over here, let's make an option to join by the code. So let's actually hide over here on the inspector, just hide the lobby create UI so we can look behind it. So inside the lobby UI, on this one, let's make one more button. So let's push it down here. Let's name this one join code button. And then above it, let's make a nice UI input field. The lobby code input field, and let's set it up the same way. So let's put it in black, and down here for the text, this one is going to say some kind of code. Then let's go inside the text area. And personally, I don't like the placeholder, so let's get rid of that. And for the text, let's put it in bold, put it in white, and put it down the middle. Okay, so now let's just position it. So just above there, just above the join by code. And on that button, let's also change the text. So join code like this. Okay, now let's make this logic. So over here on the lobby UI, let's first of all add the reference. So the join code button. And then let's also add another serialized field. This one is going to be, once again, for the TMP input field, for the join code input field. Then here in the editor, let's write the references. So the lobby code input field and the join code button. Okay. So now joining by code is very simple. Let's make that one on the lobby script. So over here on the kitchen game lobby, let's go ahead and make a function. So a public void, let's call it join with code, and we're going to receive a string for the lobby code. And over here, we just go into the lobby service, access the instance, and call join lobby by code async. And this one takes in the lobby code, so just that lobby code. And as usual, let's make this await. This one is going to return our join lobby, so let's set that one. And if we use await, we need to use async, okay? And as usual, let's put all of this inside a try catch. And finally, after we join the lobby, then it's the same thing as over here, so we need to start the client. Finally, we just need to call this function. So over here on the lobby UI, for the join code button, let's on-click, let's add a listener. Just go into the kitchen game lobby, the instance, join lobby with code, and pass in the join code input field, and let's pass in the text. Okay, so let's test. Okay, so here on this one down here, I'm going to go into play, and let's go ahead and create a lobby, and this time let's make it a private lobby. Okay, it created, there's the code, and now on this one, if I try to quick join, and nope, there's an error because there are no open public lobbies. But now if I go into code and I write the same thing, so WNT4F6, and I join with the code, and if there you go, it does connect, and we have our connection. All right, awesome. Next, let's handle one thing, which is lobbies need to send out a heartbeat in order to stay alive. By default, they will destroy themselves after 30 seconds of inactivity. For example, if here I hit on play and I create a lobby, let's make it public. Okay, the lobby has been created. Now let's wait 30 seconds. Okay, 30 seconds have passed. Now if I click on quick join, and nope, there are no lobbies open. So we made this a public lobby, but it passed 30 seconds, so it was automatically destroyed. So let's make a function to send a periodic heartbeat. That's very simple, so let's go here onto the kitchen game lobby. And let's make a function to handle our heartbeat, and we're going to need to run that on our update. So let's make a private void update, and we're going to have the handle heartbeat function. So let's make this one. So private void handle heartbeat. So we have this function. And now importantly, we also only want to run the heartbeat on the lobby host. So let's make a nice helper function. So private bool is lobby host. And basically, it's going to be a host if, well, first of all, we have a lobby. So the join lobby, it is not null. So if we have a lobby and we go into the join lobby and we ask it for the host ID, if that one matches the authentication service, we access the instance and grab this player ID. If it does matches, then this one is the lobby host. So over here, if is lobby host. If so, then let's send out the heartbeat. And for that one, let's just count down a simple timer. So up here, let's make a private float for the heartbeat timer. Okay. Then over here, heartbeat timer minus equals time.delta time. And if the heartbeat timer goes under 0, if so, then let's first reset it. So the heartbeat timer, let's set it to some kind of heartbeat timer max. So let's say we want to send out a heartbeat every 15 seconds. Okay, so let's first reset the timer. And then let's set out the heartbeat. So go into the lobby service, the instance, and over here, let's send the heartbeat ping async. This one requires the lobby ID. So let's grab the join lobby and let's grab the lobby ID. Okay, that's it. Let's test. Okay, so here I'm going to go ahead, create a lobby, create a public lobby, and now let's wait for 1 minute. Okay, it has been over a minute. And on this one, if I try to quick join, and if there you go, it does join. All right, awesome. Next, let's handle synchronizing some player data, like for example, the player name. So let's go inside our lobby UI, and inside let's create a new UI. Let's make it an input field. Let's anchor it up top and put it up there. Let's set it up as usual. So the color on pretty much a dark gray. Let's name this one the player name input field. Then inside for the text area, as always, I don't like the placeholder, so I'm going to delete it. For the text, put it in white, put it in bold, down center. Okay, great. Let's also increase the font size by a little bit. And for the player input field, let's say player name, just default text. And let's make it a little bit bigger. Okay, so that's our simple player name. Now let's handle the script, so let's go inside the Lobby UI. And over here, let's add the field. So the field for the player name input field. Here in the editor, let's just drag the reference, okay? So now we have this, and now we need to set it and listen when it changes. So we need some way to store our player name. And for that, let's go over here onto the kitchen game multiplayer. Let's define a field for our player name. So private string for the player name. And in order to store it between sessions, let's also store it on a player prefs. So over here on the awake, let's go player name and let's set it. So let's go inside the player prefs and let's get a string. Then we need a key. So let's go up here to define a constant. So a private const string, call it player prefs player name multiplayer. Let's call it player name multiplayer. So this is the key for our player prefs. Then let's use it down here. So get string of this, and then for default value. So if there's no key recorded, if not, then let's just default to saying player name, and then let's add a random number. So let's go random.range. So actually that's inside Unity engine.random.range. Let's randomize a number between 100 and 1000. So just get a random number just like this. Okay, so that is going to either get or generate a brand new player name. Now let's make two functions to get and set. So let's make over here a public void, or public string rather. Let's call it get the player name. And we're just going to return the player name. And another one, so a public void set player name. And this one we're going to receive a string for the new player name. And just set this dot player name equals this player name. So we set it, and then we need to update it. So on the player prefs, let's set the string on this same key. So let's use the constant, and let's set this player name. Okay, great. So with this, we have a nice player name defined. Then we can go back here on the Lobby UI. So let's go ahead and make a private void start. And on start, let's grab the player name input field and set the text. Let's go into the kitchen game multiplayer, the instance, and let's get the player name. Okay, so that will update the name. And then we need to know when the player actually changes the input field. So that is actually also pretty simple. So let's just go inside the input field, and over here there's a callback. The callback is called onValueChanged. This is a Unity event. So let's add a listener just like we do with a click. And for the listener, this one is going to receive a string, which is the new text that the player wrote. Okay, so we have this, and over here just go into the kitchen game multiplayer, the instance, set the player name to this new text. Okay, so that will now update the current name, and it will save any new name the player writes. So with that, the player name is being set. Now we just need to show it on the character select scene. So let's go to that one. So over here on the project, let's go into the character select scene. And over here, let's go inside one of these player prefabs. Let's open it up. Okay, so over there, we already have something called ready. And let's duplicate it to make another text object, put it above, name this the player name text. And this one is going to say what it is, the player name. So let's just go into the script here, the character select player. And we're going to add a reference to our player name. So let's add, in this case, it's a Text Mesh Pro. We're using a warm object, so it's not the UGUI. So it's this one for the player name text. Here in the editor, let's drag the reference like that. Okay, so now we need to set this. And for setting it, over here we have our general update player function. So it's over here that we're going to set the player name text.text, and we're going to set it to something. And for that something, we're actually going to store the player name inside our player data. So let's go here inside the player data, and let's store a public string for the player name. And over here, we need to override all these. So we do an equals on the client ID, the caller ID, and also the player name. Okay. And down here on the serializer, let's also serialize the player name. Except if you remember from the other video, a string cannot be used here. If you look here in the inspector, nope, the player data must be a non-nullable value type. A string can be null, so a string cannot be used. And over here, the alternative is instead of a string, let's use a fixed string and then the number of bytes. This is the length of the string. And for a player name, let's go with the 64 characters. That's big enough for a player name, so let's go with this one. Okay, so we have this inside the player data. And then back here on the character select player, on the update, we go inside the player data, and let's grab the player name. Then this one is a fixed string, so let's just call toString to convert it to a regular string. Okay, so that's great. So now the visual for the player should have the player name, and we are having that over here stored on the player data. All we need is really just to set it on the player data. So for that, basically we need to tell the server our name when we connect, and then the server will update the player data, which then is synchronized to all the clients. So let's go over here onto the kitchen game multiplayer, and to tell the server the name, let's do it as soon as we connect. So let's go down to where we are doing the start client. So here we have the start client, we're listening to the client disconnect, and let's also listen to the client connect, so the other one, so on client connected callback. Let's listen to this one on the server on client connected callback. Okay, we have this one. Let's create this function. So here it is. So on this function, we have the client ID parameter, so the same as usual. And as soon as we connect, let's tell the server what our name is. So for that, we need an RPC. So let's make a private void, set player name server RPC. And this one is going to be a server RPC. We require ownership as false. Then over here, we receive a string for the player name, and we receive the server RPC param, so we know who sent this. And as usual, let's default it. Okay, great. And over here, we're really going to do the same thing that we did down here. So here, when changing the color, right now we're going to do the same thing. So let's just copy this code. Let's go up here into our function. And over here, let's paste the same code. So we grab the player data index from this server RPC params. Okay, that's great. Instead of modifying the caller ID, let's modify the player name into this player name. Okay, so all that's left is over here when the client connects. Let's trigger the server RPC and pass in get player name and update it like this. Okay, so that is going to do it for the client, but then the server itself also has a name. So up here, when we have the start host, we also have this callback. So over here, let's also set the player name. Okay, so that should do it. When a player connects, it will send the server their name, then the name is broadcast to all the clients. Let's just make sure to save the prefab, and as always for testing, let's make sure we test starting from the lobby scene. Okay, so let's test. Okay, so yep, we do see our nice input field. So on this one, I can click to modify it. So on this one, let's say I am CodeMonkey. And then on this one down here, let's hit on play. And on this one, let's give it another name. Let's say Iron Man. Okay, so I got the two names on this one, create a lobby. Let's create a public lobby. And if there you go, it does show the player name. And on this other one, let's do a quick join, and it joins, and if there you go, Iron Man, and both the names are synchronized. All right, awesome. So here we have all the names in the character select scene. Although, one note here, if you wanted, you could also show these names on the game scene above the players. So if you both go on ready, right now the game just starts playing and we just have the characters, no names. But if you want, you could also add the names up here. But since the players already have different unique colors, I think this scene looks best without the names. Okay, so the next thing we want to handle is the lobby lifetime. Right now, the lobby will stay alive until we end the entire game session, but there's really no need for that. Once we start the game, we no longer accept any connections, so we should really just clean up and destroy the lobby as soon as the game starts. So first, let's go here to the kitchen game lobby, and let's make a function to delete a certain lobby. So let's make a public void, call it delete lobby. And over here, it's very simple, the same thing. So let's go inside the lobby service, the instance, and call delete lobby async. And here we pass in the lobby ID. So let's just check if the join lobby is not null. So if we are inside a lobby, if so, then let's use the join lobby.id and destroy this one. Once again, let's await for this one. Then after we await, let's clean up the join lobby since that one will now be null. And in order to use await, we also need to use async. And finally, we must put all of this inside a nice try catch the lobby service exception, and just do a debug.log. Okay, that's it, pretty simple. Now let's see where we're going to call this. It's over here on the character select ready script. Here we have the player ready dictionary, where the player tests if all of the players are ready, and if so, then loads the game scene. So before doing that, let's just go into the lobby, so the kitchen game lobby, the instance, and let's delete the lobby. Okay, so that handles the cleanup when the game starts. For something similar, which is going to be when we leave the lobby manually, for doing that, we also need to make sure that client leaves the lobby. So back in the kitchen game lobby script over here, let's make another function. So this one, public void leave lobby. And this one just go into the lobby service, the instance, and this one we call remove player async. This one takes a lobby ID, so that you join lobby.id. And then it also takes a player ID, so let's go inside the authentication service, access the instance, and grab this player ID. So this will remove this player from this lobby. So as usual, let's do the same thing. So await async. Okay, so just like this, pretty simple. And as to where we're going to leave, it is going to be over here on the lobby UI, so we have a button to go back into the main menu. So when we do, let's just go into the kitchen game lobby, the instance, and let's make sure to leave the lobby. Okay, so finally, the last possible scenario for leaving a lobby is actually if the player is kicked. So let's make a function to kick a player. Back here on lobby, it's going to be very similar, so let's actually copy this. And let's call this kick player. And inside we're going to receive a string for the player ID. Then over here we call the exact same function, except instead of using this player ID, let's use the one that we received over there. And of course for kicking, we're not leaving the lobby ourselves, so let us not do this. And instead of testing if the lobby is not null, we're only going to be able to kick players if we are the lobby host. So is lobby host, then we kick this player. Okay, so now for calling this function, it's over here on the character select player script. We've got our kick button. When we kick, we get the player data. We kick the player from the multiplayer, so from the netcode itself. And then over here, we also need to kick them from the lobby. So let's go into lobby, instance, kick the player, and now we need a player ID. So the obvious question, how do we get that? And the obvious answer is the same thing that we did, which is let's just store it over here on the player data. So let's go here, and the player ID is also a string. So let's do also a fixed string, so player ID. And let's copy all of these. Okay, just like this. Then on the kick function, we can go inside the player data and use the player ID. All right, now we really just need to set this. So for that, let's go in the multiplayer script. And over here, we're really just going to do the exact same thing that we did on the set player name. So let's copy this RPC, except instead of set player name, this is going to be set player ID. Let's receive a string for the player ID, and we're going to set the player data.player ID. Okay, so that's what we modify, and let's just call it when we set the player name. So when a client connects, let's send this in, and for the player ID, let's go inside the authentication. Let's go inside the instance and grab this player ID. So we set it over here when we set the player name, and same thing up here when we set that one. Okay, so let's test. Okay, so starting off, let's create a lobby. Let's make it a public lobby, and first of all, let's just start playing just like this. And there you go, here we are playing, there are no errors, okay, so everything is working perfectly. Now on this one down here, if I try to do a quick join, and nope, it does not find any lobbies. That's because this one was now destroyed. Okay, great. Okay, now here let's try to create another lobby. Then on this one, let's do a quick join, and on this one, let's get them from the lobby, and yep, there you go, that does work. And now if we try joining again, and yep, it also still works. Okay, great, so all the logic is working perfectly. Now, one issue we have right now is that our lobby isn't really very responsive. There are lots of actions that take a little bit of time, but that is not visible to the player, so let's just add some nice messages. Previously, we already made this window the connection response message UI. It shows a message and a close button. So we could just make another window just like this one, or we can simply reuse this one. Let's reuse it just so we don't end up with tons of different windows. And first of all, let's actually put both these windows, let's put them on top of the actual lobby UI. Okay, so like this. All right. So now let's rename this one to just lobby message UI, so a bit more of a generic name, and lobby just because this object only exists over here on the lobby scene. So now that we've renamed the game object, let's also rename over here the script. So rename to lobby message UI, and obviously this is going to have some errors. We need to make sure that the script name actually matches the file name. So up here inside, let's just modify the class name like this. Okay, the name is correct. Now over here, we are showing this message based on these events. So let's simply make a bunch more. We want the window to show when trying to create a lobby. So let's go over here onto the kitchen game lobby and let's make an event to fire on that. So a public event handler. And for this one, let's using system, okay. So on this event, let's call it on create lobby started. So when we start creating the lobby, another one on create lobby failed. Okay, so we have these two events. Also, by the way, since we added using system, now over here we've got a ambiguous reference between the Unity engine random or the system random. So over here we can solve this by just using the complete name. Okay, great. So let's go down to where we are creating the lobby. So let's see the function over here to create the lobby. Again, remember that these are await functions, which means that this code to create a lobby isn't instant. It's actually going to contact the Unity server in order to create a lobby. So this is why we need a visual for the player, because this is not instant. So before we try to create a lobby, let's fire off the onCreateLobby starter. So invoke with the usual this and event args. Okay, so we try to create a lobby. And then if we succeed, we're going to load the other scene. So there's no need to post any message. But if we do fail, then over here, let's post a message. So let's use the onCreateLobby failed. Okay, these are the two basic events. So now back here on the lobby message UI, let's listen to them. So let's go into the kitchen game lobby, the instance, and first of all, the onLobby started. And as usual, let's rename this to give it a proper name. So kitchen game lobby, onLobby started, and the other one, which is the onCreateLobby failed. Let's listen to this one as well. Okay, we have our events, and let's also make a generic function in order to show a message. So here, a private void show message, going to receive a string for the message. And then we're just going to call show and set the message text.text into this message. So now up here, we can simply show these, so we'll do the exact same logic. So if disconnect reason is none, then let's call show message. And let's show the general message fail to connect. And if not, if we do have a disconnect message, then let's show that disconnect message. Okay, great. So now the code is a bit simpler. So we just have the show message. So over here, let's just say, so this one is on the create lobby start. So let's say creating lobby. And on this one up here, fail to create lobby. Okay, so that's great. That handles those messages. The other place where we want to show some messages is on the quick join. So let's do the same thing with two events. So let's make an event, and one, let's call it on join starting. So this works for both the quick join and the other ones. Another one on quick join failed. So let's go down and do the exact same thing. So let's go over here on the quick join. So on join starting, let's invoke this event with this and event args.empty. Okay, we have our event. And then if we do join, then we're going to load the other scene, so no need, and it's over here. So on quick join fail like this. Let's also put the same thing over here on the on join with code, so on join start, and then let's make another one, so on join failed. Let's just go up here to define this one. So on regular join failed. Okay, great. So over here, let's just listen to those events. So the usual thing, so the instance, let's go with the on join start. Let's listen to this one. Then the other one is the on join failed. And finally, we have the on quick join failed. Okay, let's rename all of these. Okay, we have all of our events now for these messages. So on join start, let's just say joining lobby. Then this one up here, fail to join lobby. And on this one up here, on the quick join failed, could not find a lobby to quick join. All right, so that's it. Here we have all of our messages. Let's test. Okay, so here if we try to create a lobby, let's go ahead, create on public, and there you go, create a lobby, and it takes a little bit, and we have a nice visual, so that's great. And now on this one, let's go ahead, click on play. And let's go ahead with the quick join, and there you go, join lobby, connecting, and yep, it connects. Let's see the other ones for fail to join. So if I exit both lobbies, and if I try to quick join, and there you go, it did work. It simply fired off the error. That's because over here in Unity, this one throws an exception, and Unity treats that as an error, so it automatically pauses the game. But in the build, this is not a problem since it won't stop. So over here, if we hit on play, going to quick join, joining lobby, and nope, could not find a lobby to quick join. And if I try to join by code, it also does not find this lobby with this code. All right, great. So just with this, our lobby actions are now much more responsive. Okay, great. So finally, let's do the most obvious lobby feature that is still missing. Let's simply list all of the available lobbies so the player can choose which one to join. So for that, first, let's go over here onto the kitchen game lobby, and let's make the function to actually list all of the lobbies. So let's go up here, make a simple function. So private void list lobbies. And in order to list all the lobbies, all we need to do is do a query. So let's go into the lobby service instance, and let's call query lobbies. This one takes a query lobbies options. If you don't include this, then it will simply show all the lobbies. But right now, let's actually add a filter. Let's only show the lobbies that are available. So let's not show the ones that are full. So over here, let's make a query lobbies options. And let's construct a new object of this type. And inside we've got the filters. So let's create a new filters. This one takes a list of query filter. So now inside we can create a new query filter. And for this one, for the field, we only want the ones with available slots. So let's go with available slots. Then for the value, we want all the ones that have more than 0. So let's go with 0, except this one actually is a string value, not an int. So let's just put this as a string. Okay. And finally, for the operation, we only want the ones that have more than 0. So let's use the GT, which means greater than. So this will only show all of the lobbies that have available slots greater than 0. Okay, so just like this, and over here, let's use the query lobbies options. And as usual, let's await this. And this one, we can see what this returns. So this is actually going to return a query response. So let's grab the query response. And also, since we are using await, up here we need to mark it as async, okay? So we grab the query response, and now inside, over here we've got the results, and the results is a list of lobby. Okay, now in order to show them on the UI, we're going to fire off an event, so let's do that. Let's go all the way up here, make another event. For this one, let's call it on lobby list changed. And in the event, we want to pass in the list of lobbies, so let's make a public class on lobby list changed event args. Let's extend event args, and inside let's have a public list of lobby and just call it the lobby list. And now the event is of this type. Okay, great. So now over here, when we have the list lobbies, we get the query, and then let's invoke this event, pass in with this, and create our new event args. And inside we have the lobby list, and we pass in the query response.results. Okay, so just like this, and as usual, let's wrap this inside a try catch. So try, and the usual catch, the lobby service exception, like this, and do a debug.log. Okay, so this is going to list our lobbies and fire off the event when we have new list. And let's also periodically call this function in order to make it automatically refresh. So for that, let's go up here onto the update. We're going to have another function. Let's say handle periodic list lobbies. Let's make this function. So on this one, we're going to count down a timer. So let's call it the list lobbies timer. We're going to count it down by time.delta-time. Let's just define the timer all the way up here, just where we define the heartbeat timer. So as usual, a private float for this. Okay, we have this timer. So we count down the timer and the usual thing. So if it is under 0, if so, then let's first reset it. So put it to some timer max. Let's define it in here, the timer max. And let's say we want to refresh. We don't need to be too specific, so let's say maybe 3 seconds. So we reset the timer and then simply call list lobbies, which in turn, that one is going to fire off the event, which the UI will listen. Okay, so that's great. Although here, this is going to continue listing the lobbies even when the player has already joined the lobby. So that's a little bit wasteful, so let's not do that. So we're only going to run this if the join lobby equals null, meaning if the player has not yet joined the lobby, let's automatically refresh. But as soon as they do, don't bother wasting. And also one more thing, this is actually going to throw an error if we run it right away. That is because over here, the authentication, this one signing in, this one is going to take a little bit of time. So on the very first update, it will not already be signed in. So we can just simply go into the authentication service. And let's just check is signed in. So this is only going to list the lobbies when we are signed in. Okay, great. So that's the function for listing all the lobbies. Now let's just make the UI. So over here in the editor, let's open up, let's just hide our message window. We don't really need that. And for the lobby UI, let's go inside of it. And over here, let's create an empty game object. Call this the lobby list container. And now inside it, let's make a new UI button. Call this the template. And inside for the text, let's give this a better name. So let's say the lobby name text. And now let's set it up visually. So let's make it a little bit bigger. And for the lobby name, let's actually anchor it on the left side. Just move it to the left by a little bit. Let's put it in bold, maybe something a bit smaller, maybe 22. Let's put it in white. And for the background, let's put it in a dark black and make it a little bit bigger. So let's say 40 or 50. Okay, so like this, we have our button, and this is going to display our lobby name. Okay, great. Now for positioning these, let's go ahead and add a vertical layout group over here onto the container. And you can also put the width and height both at 0. Okay, so let's position it somewhere around there. And basically we're going to dynamically spawn the template, so something like this. Let's just increase the spacing by a little bit, maybe 10. Okay, just like this. Let's also make a background for our UI. So let's create a new UI image. Let's put it all the way up there. And let's scale it something like this. Maybe put it in white, but a little bit transparent. Okay, so that's just a nice visual background. Also for another visual thing, over here in the game, the background still looks a bit odd. So you could use a solid color, or let's just simply actually go into the main camera. So that's what the camera can see, and let's just move it up a little bit. So over here on the while, let's rotate it something like this, just so we have a nice gradient. Okay, so that looks good. Now let's go over here onto the lobby UI script. And let's begin by adding references to what we need. So we're going to need a transform for the lobby container, another one for the lobby template. So now here, let's drag our references. So the lobby list container and the template, okay. And now let's make a simple function in order to update that list. So private void, call it update lobby list. In order to know what lobbies we want to spawn, let's receive a list of lobby. And it's this one inside Unity Services Lobbies model. Okay, this is the lobby list. And on start, we're going to start off with an empty list. So let's call this with an empty list. Then we're also going to want to show it on that event. So let's go into the kitchen game lobby, the instance, and on the lobby list changed. When this one happens, let's call update lobby list and pass in the e.lobbylist. Okay, great. So now we just need to make this function. And here we're going to do the usual setup that we've done so many times on the single player course. So let's first handle the cleanup. So let's do a for each transform child in the container. So that is the lobby container. So let's cycle through all the container. Let's see if this one is a template. If child equals the template, the lobby template. If so, let's skip this. We don't want to destroy the template. But if not, let's destroy. And we're going to destroy the child.game object. Okay, so that handles the cleanup. Then let's do a for each lobby in the lobby list. So we cycle through these. Let's instantiate our template, so the lobby template. And this one is going to be our lobby transform. Then first thing we want is to actually enable the template. So on this one, set active into true, which also means that we need to disable this one in the beginning. So up here on the awake, let's set the template game object set active into false. Okay, so that hides the template, and over here we are showing it. All right, so now all that's left is to pass in this lobby onto this transform. So let's make a script to do that. Let's create a brand new C# script for the lobby list single UI. Let's go ahead and select the template, and let's set the lobby list single UI, so right there. Also importantly, make sure you add it to the right template. Basically, these other ones don't matter. Those are just to see the positioning. So if you want, you can even just clean this up. Just make sure there are no mistakes. So there's only one template. This is the one that is selected over here. And it's on this one that we have the script. So now here on this script, pretty simple. We're going to have a public void in order to set the lobby. And we're going to receive a lobby object. So lobby, let's receive this one and store it. So up here, a private for the lobby, and do this.lobby equals this lobby. Then for the single, for this one, we're going to want to update the text and then handle the click. So for the text, let's go up here, add a serialized field, private text mesh pro UGUI for the lobby name text. Okay. Now here in the editor, let's drag the reference. So the lobby name text, let's drag this reference on there. All right. And then for the button, since we already made this template, this one itself as a button, let's do private void awake. And on awake, let's get component of type button. And when we click, let's add an on click, add a listener. And we're going to want to join this lobby. And also, by the way, up here, we are going to want to update the name. So the lobby name text.text equals this lobby.name. Okay, great. And finally, for joining, we're going to go into the kitchen game lobby, the instance, and let's join the lobby. And also, by the way, over here, we need to do it by the ID. That is because for public lobbies, when the enlist lobbies function calls, when that one lists all the lobbies, the lobby.lobby code, this one is actually going to be null. So we cannot join a public lobby through that list by the code. We need to join it by the ID. So very simple, just over here, let's make a function example like the other one. So example like we have join with code, and let's join with ID. And we're going to receive a string for the lobby ID. And then instead of join lobby by code, join lobby by ID. And everything else is exactly the same. Then over here, let's just use this function and pass in the lobby.id. Finally, back here on the update lobby list, when we grab the lobby transform, we need to get the component of our lobby list single UI. And let's pass in set lobby and pass in this lobby. Also, by the way, up here, when we instantiate, we need to instantiate inside the lobby container. All right, so let's test. And up here we are. So the list starts off as empty because there are no lobbies. Now in this one, let's go ahead, create a lobby. Let's make it a name. So my lobby name, and let's go ahead and make it public. And it created, and yep, there you go. That one did update. So we now see it on the list. And now if I click on it, yep, there you go. It does join the lobby. Okay, great. Now let's also test to make sure this one only shows lobbies that have available slots. Okay, so here I have a bunch more builds. So on this one, let's play. And yep, we do see a lobby. Let's join it. And yep, there you go, joined. Now this one, let's go ahead. We do see it. And for this one, for joining, let's join it with a quick join. And yep, there you go. Everything works perfectly. And on this one, if I go on to play, and nope, the lobby does not show up. The game is now full, so it does not show. And just one thing that I forgot a while ago, over here on the character select UI, we need to make sure to leave the lobby when we go back to the main menu. So up here for the kitchen game lobby instance, and let's make sure to leave the lobby. So now here we are, and the lobby is full, so it does not show up over here. Now if one of these, if we leave, and if there you go, that one left, this slot is now available, so now this one can indeed join. All right, awesome. Okay, so here we added yet another extremely important feature to our multiplayer game. We added the lobby so that players can create games and other players can join them. Now, like I mentioned, one thing we still don't have are different sessions. Right now, all of the lobbies are being created on the same IP, same port. So let's solve that by implementing Unity Relay in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to set up our project to use Unity Relay. This is how we can make our game easy to play by not requiring the players to handle anything to do with port forwarding or firewalls. By using this, we can easily connect any two players anywhere in the world, and it all works seamlessly under the hood. Okay, so here let's implement the relay, which is actually pretty easy. But before we do that, let's actually fix one thing that I forgot in the previous lecture. If we are playing the game, and over here let's create a lobby, and then I just go into ready and go into the game state, and nope, over here we have an error. It's a missing reference exception, and yep, it's right here on the lobby UI script for updating the lobby list. Once again, the issue is the same that we already saw, which is because the listeners, basically this object is destroyed, but the kitchen game lobby, that one continues. So let's clean up the event. So let's do private void on destroy. And when this object is destroyed, let's make sure to unsubscribe from these events. So from this one, do minus equals. Okay, great. Also, the other one where we used events was on the messages. So over here on the lobby message UI, we are listening to a whole bunch of messages. So let's also unsubscribe from these. We're already unsubscribing to that one, so let's just unsub from all of these. So just do minus equals on all of them. Okay, so that handles that problem. Although actually this error is caused by something that is actually not supposed to happen. The issue is because it was still trying to update the lobby list even though we were in the game scene. Now that is not correct. We should not be refreshing the lobby list when we are already playing the game. So over here on the kitchen game lobby script, let's scroll down to where we are handling the periodic list lobbies. And over here we are listing if join lobby is null. And when we go into the actual game, when we do that, we're actually destroying the lobby. So this one becomes null. So that is why on the game scene, this one is still running, but we don't want that. So let's make sure this one only runs if we are on the lobby scene. So super simple. Let's just add scene manager. Let's get the active scene. And let's compare the name, and let's compare with the loader.scene, and we only want to run this on the lobby scene. Okay, so just like this, we only want to list lobbies if we are on the lobby scene. So let's test. Let's hit on play. Let's create a public lobby. Let's go as ready and go into the game and now play. And yep, now everything works perfectly. Okay, great. So now let's actually handle the relay. Again, I have a dedicated video on relay. You can watch that if you want, although the relay is super simple. So here I will cover pretty much everything that I also covered in that video. If in the future you forget how relay works, you can either come back to this lecture or just watch a standalone video. First thing we need is just install the package. So let's go into the usual package manager. On the Unity registry under all, let's wait for it to fetch, and now let's find the relay package. So here it is, the relay, currently version 1.05. Let's go ahead and install. Alright, the package was installed. Now we need to use it. So just like we did with the lobby, let's go onto the Unity dashboard. And first of all, make sure you are selecting the correct project. Then over here on the left side, let's go into relay. And let's go ahead and set up the relay. Link the Unity project, we already did that. So next, install the package, we did that, next. And now here, let's turn the relay on. Yep, there it is, done, next, and yep, we are finished. Okay, great. So the relay is now set up. We can now begin using it. And basically the way we use is first we need to allocate the relay, and then we need to use it before we start the Netcode connection. So the way we set up our game is we set up the connection immediately as soon as we create a lobby. So let's go then. Let's go to the create lobby function. So here we are, we create a brand new lobby and we start the host right away. So we need to allocate the relay before we start the host. So over here, let's do that. Let's make a function to allocate the relay. So a private void, let's call it allocate relay. And now inside here, we are going to go inside the relay service. Also, by the way, sometimes Visual Studio might not update, so just go ahead, close it, and let's reopen it again. And over here, if we go inside relay service, here Visual Studio now does see, yep, we need to add using Unity services.relay, so let's add that. Then here, let's access the instance and call the function to create an allocation async. This one just requires an int for the maximum number of connections. So in our game, we already defined the max number of players, so let's go into the kitchen game multiplayer, and over there we have the max player amount. Although importantly, over here for the connections, it is actually minus the host. So we want 4 players, that is what we have here on the max player amount. So minus the host, let's just do -1. And then if you want, optionally, you can set a region, or the relay itself will decide on the region, so let's just let them decide. Okay, so this one is going to return an allocation, so allocation. So it's this one inside Unity Services Relay Models. So this is the relay allocation, and as always, this one is an awaitable call, so let's await and async. Okay, so this is going to allocate our relay. And now, just like with the lobby, let's put this inside a try catch just to make sure the game doesn't crash. So catch, and let's cache for any relay service exception. If that happens, let's just do a debug.log. Okay, great. Then we basically want to get the allocation. So when we have async, we can't directly return an allocation here. When working with async, we must return something typed task. Now this has nothing to do with Unity itself. This is regular C# code. So in C#, when using async and await, we need to use tasks, which as you can see, you can inspect these functions and see they also return a task and inside an allocation. So this is how you work with it. So over here, let's make task and return an allocation. And then, so we allocate it and we return this allocation. And in case we have an error, let's just return the default. And also up here, we need to make sure to include system threading.tasks. Okay, so there you go. So we have this nice function to allocate the relay. So now over here on the lobby, let's just call the function allocate our relay. And we made it async, so let's also await this. Okay, so this is going to allocate our relay. And now the reason why I made it return the allocation is because we're going to need it. After we allocate, we need to actually generate the code in order to be able to use it. And now the reason why I made it return an allocation is because we need the allocation in order to set the Unity transport. So the way we set it to use a relay is we go inside the network manager, let's access the singleton, and from the singleton, let's get the transport attached to it. So let's do get component of type Unity transport, this one right here. So inside Unity Netcode transports UTP. Then on the transport, we've got a function set relay server data, and this is how we can pass in data. So let's make a new of this type, sets relay server data. So let's add this one. And over here, this one, as you can see, it takes an allocation. So that is why we need over here the allocation for the relay. So let's grab the allocation. We grab this, then we use it over here. And the next parameter is the connection type. And by default, Unity recommends using DTLS. So this is some type of encryption. All right, so that's it. So now when we call start host, it is going to start the host and start the connection going through this relay. So this handles over here the creating the host. And how we join a relay is we have to join through a code. So let's generate a brand new relay code based on this allocation. So let's make a function for that. So private void, let's call this get relay join code. And inside we go inside the relay service, grab the instance, and we get the join code async. And this one, as you can see, it takes an allocation ID. So let's receive a parameter allocation. And over here we use the allocation.allocation ID. Okay, so this one is going to return a string with our relay join code. So string for the relay join code. And we get this, and as usual, let's await this. And this one is async. Okay, great. So we have this one, and then let's do it just like we did. So let's return this relay join code. So let's make it return a task of type string. And then we can just return the relay join code. Now, as usual, let's put this inside a try catch. So let's try and let's catch a relay service exception. Let's do a debug.log on E. And we have to return something. So let's just return a default. Okay, so now this function gets us a relay join code. So now in here, after we get the allocation, let's get a string for the relay join code. And we get the relay join code and pass in the allocation. And let's make sure to do this on no wait. Okay, great. So that's pretty much all we need over here on the create lobby. So we allocate the relay, we get the relay join code, we set up the entity transport to use this relay, and then we start the host. So that's all great over here. The next thing we need is some way of joining the relay through a code. So let's make that function. So private void, let's call it join relay. And over here, let's go inside the relay service, the instance, and we join allocation async. So this one takes a string for the join code. So let's receive here the string for the join code, and we use the join code. This is how we can join a relay. And you can note how this one returns a join allocation. So that is the same type of allocation that we're going to need in order to set up the network manager unity transport. So let's also make this function return that. So let's return a task of type join allocation. And as usual, let's make this async. And on this one, let's await and the usual try catch. So this one returns a join allocation, and we're just going to return this. And over here, return the default. All right, so that's this function. We pass in a relay join code, and then it joins the allocation. So then let's go down here to where we are joining. So for example, over here on quick join. So we first joined the lobby. Okay, great. Then afterwards, let's join the relay. So let's call join relay by code. And over here, obviously, we need the join code, but let's worry about that in a little bit. So this one is going to return a join allocation. So join allocation, we await this and we get that. And then with this allocation, we can do the same thing that we did here in order to set up the entity transport. So we just paste this function. Instead of using an allocation, we use the join allocation. Okay, so that's it. This is all we need in order to join through the relay. Now, the obvious thing is over here, we need the relay join code. So the big question is, how do we get it? And actually, that's very simple. We're going to use the lobby in order to share the relay join code. So let's go up here to when we are getting the allocation, getting the relay join code. And let's just add the relay code as part of the lobby data. So over here, let's just go in the lobby service, the instance, and let's call the function update lobby async. So we're going to update the lobby data. This one requires the lobby ID, so let's use the join lobby.id. And then for the update lobby options, let's create a new object of this type. And over here, we can update all of this type. And let's update the data. So let's make a new one of this type. So this one takes a string and a dictionary. Let's add a brand new entry to this dictionary. And first of all, for the key, let's define a key. And as usual, let's not define it over here. So let's go to the top of the file and make a nice constant. So up here, a private const string, call it the key relay join code, and say relay join code. Okay, so we have this key. And over here, when we update the lobby, let's use this key. And then for the value, let's just pass in the relay join code. Although this needs to be inside the data object, so let's make a new data object. And for the visibility, we want this to only be visible to members of this lobby. So let's go with member. And for the value, let's pass in the relay join code. Okay, so this is it. And this one, as usual, is an awaitable call like this. All right, so with this, we are updating the lobby to hold the data for the relay join code. then all we need is to get it when someone joins. So down here on the quick join, we have joined the lobby, and inside the lobby, we can simply access the data, and inside we can access on the same key, and yep, over here we have a string for the relay join code. So we have this, and then we just use it over here. And also, by the way, this one has a data object, so we need to grab the value. Okay, so that's really it. It really is that simple. So when we create, we update the lobby data with the relay join code, and when we join, we grab that, we use that to join the allocation, and we join with Unity Transport. Now what we need to do is we need to make sure to run this code before every single start client. So over here on the quick join, we do that. Then on join with ID, let's do the same thing, and same thing down here, join with code, like that. So you always need to make sure to set up the Unity Transport to use a relay before you start client or start host. Alright, so that's really it. With this, the relay is fully implemented, so let's test. Also on the network manager, let's scroll down to the Unity Transport, and over here for the protocol, let's swap it out for the relay Unity Transport. Alright, so here let's go ahead and hit on play. Let's create a brand new lobby. Let's name it my first lobby. Let's go ahead, create a public, and there you go, it is creating, and it does take a little bit longer since it is allocating the relay. And if we look over here on the console, yep, we do see the messages. It is indeed allocating the relay, and it did decide that the best region is Europe West 2. Okay, so this one is now using the relay. So now on this one, if I hit on play, and if there you go, I do see the lobby right away, and if I click on it, if there you go, it did join the same session. Note how the player didn't have to bother with inputting any relay code or anything. Everything happened automatically in the background. Great. And we can also verify that it is indeed working by trying to make another lobby for a separate section. Okay, so here I have 2 more clients. So on this one, let's go ahead, create another lobby. I'm not going to join, I'm going to create another one. My other game, let's go ahead, create public. And if there you go, now this one created a completely new lobby. And on this one down here, let's hit on play, and let's choose one. Let's go and join this one, so my other game. Let's join that lobby. And if there you go, note how this one did join a completely different lobby. So with this, we now have 2 completely separate sessions. We can now go into regular gameplay. So on this one, let's hit on ready. This one down here, let's also ready. And yep, both of these are now playing their own game. There it is, just like this. And on these, let's go into ready, and let's go into ready. And they're also going to start their own game. And there you go, now they're also playing a completely different game like this and like this. So here we have 2 unique sessions of our game, and both of them working perfectly and separately. Awesome! We can also look in the dashboard over here and see, and yep, we are indeed using some data, so we are indeed connected through the relay. Okay, great! So this is really it. As you can see, using the relay is super simple. With this, we can now connect any players in any location in the world. The players don't have to worry about port forwarding or anything to do with firewalls. Everything works seamlessly in the background. So with this, our multiplayer game is pretty much completely working. Unity has some more interesting multiplayer tools, so let's talk a bit about those in the next lecture. Hey again, quick intermission. You're almost at the very end, so congratulations on making it this far. This one is the second secret callout, so go ahead, post a timestamp and a monkey emoji in the comments. It will be fun to see how many people make it to this point. If you've made it this far and understood everything, then you already have most of the knowledge needed to build just about any multiplayer game. Let me know in the comments what kind of multiplayer ideas you'd like to build. Maybe you're a fan of something exactly like this, a casual co-op game, or maybe you're more interested in building something with some exploration and building, kind of like Valheim. Or perhaps you'd like to make some kind of shooter game. With knowledge you gain here, really all of those are possible to build. So right now let me say thanks for watching the course so far, and I really hope you've learned a ton. There's only a few more lectures until we get everything built, so let's continue to the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to talk about the various other multiplayer tools that Unity has in order to handle dedicated servers, matchmaking, and voice or text chat. So here we have already implemented Lobby and Relay, 2 great tools that are part of Unity Gaming Services, and there are a few more that Unity provides. There is Game Server Hosting, which also used to be known as Multiplay. This is how you can easily handle dedicated servers. This tool is actually what Apex Legends uses to manage their server infrastructure, so it's very robust. The way it works is you make a dedicated server build for a game, so pretty much just a regular build but with no graphics. Then you upload that to the game server hosting platform, and after that, when a player goes to play your game, it automatically spins up an instance of your dedicated server, locating in some data center close to where the player is. As more and more players play your game, more and more servers are automatically started. So as your game grows, the backend automatically scales to meet demand. Then for another Unity Gaming Services tool, you have Matchmaker, With this one, you can define some rules and your players will automatically be matched with one another. The most obvious use case is obviously for skill-based matchmaking. So you define some skill number for your players and you can match players with similar skills together. But that's not the only case. You can also simply define a rule for ping, so search through the regions and look for players under a certain ping in order to match them. Or if you have a game with lots of players per server, like for example an MMO, you could also match players based on server density. You can define those rules, but then you can also define secondary rules that get triggered after some time. So for example, you can match players with a skill difference of 100 points, then if none are found within 10 seconds, you can relax that rule and look for players with a difference of 200 points. This tool is very well integrated with game server hosting. And finally, you have Vivox. This is a tool to help you add text and voice chat to your games. Apex Legends also uses this tool. This is fully featured, so while you could make a basic chat system with just some basic RPCs, making something fully featured does take a ton of work, and making voice is extremely complex. So with Vivox, you have some high quality audio with low latency. It features support for both 2D and 3D positional audio. You have some easy volume and mute controls. It also apparently supports speech to text, which sounds interesting. And you can send DMs to other players, send text in a group chat, and many more features. So with these three tools, you can further expand upon your multiplayer games in many ways. Now I did want to include detailed tutorials on all of these three tools, but I've been working non-stop for these past few months on both the single player course and now this one. I'm quite a bit behind on schedule for some of my other projects, like for example my Steam game. So I don't have the time to really research and cover these tools right now, but I also don't want to delay this multiplayer course since the game is already essentially complete. So what I will do is launch this multiplayer course, which is why you're hearing this right now, and in the near future I will do separate videos covering these three tools. When I do, I will add them to the video references on the course page. So if you're watching this in the future, pause the video right now and go and look at that page. So stay tuned for that, or you can go read the documentation and learn how to implement it for yourself. If you've managed to fully understand everything in this course, then I'm sure you'll be able to learn about these tools and use them on your own. So here, back in this game, now that we have pretty much everything working, there are some built-in tools to help us debug our multiplayer game. Let's learn about those in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to look at some built-in tools to help us analyze and optimize our game. Okay, so when it comes to the topic of analyzing and optimizing a multiplayer game, there's really a million things you can do. What you should do really depends on a case-by-case basis. There are no universal rules that I can tell you that are going to be applicable to every single possible game. So instead of anything too specific, here let's just look at the tools and see how they might help. The first one is actually something that we already used. If we go into the Network Manager and we'll look down here onto the Entity Transport, down here we have the Debug Simulator. With this we can simulate delay, which is how much time packets take to be sent and received. Again, there are no universal rules. So if you're making a super fast-paced FPS or some fighting game, then for testing maybe you should test with a delay up to 50 milliseconds. Remember, the number that you get here is added on top of whatever delay you already have. Then if you're making a casual co-op game, like the one that we have here, you can probably push that up to 150 or 200 milliseconds. And if you have something like a turn-based strategy game, then perhaps it's even acceptable to go up to 500 or maybe even 1000 milliseconds. With this parameter, you can basically set the worst case scenario and test your game fully to make sure that it works with that delay and everything still works as expected. Then the other option is the jitter. This one is the rate at which the ping changes. Basically, packets on the internet, they are independent and they don't necessarily follow the same path every time. So the jitter here represents the variation in how long each packet will take to arrive. Maybe one packet takes a really short route and gets to the destination in 20 milliseconds, and then another packet for some reason takes a much longer route and instead takes 100 milliseconds. That difference is going to be the jitter. This can be important, especially with regards to packet ordering. By default, packets will arrive at the same order as they are sent, so in that case, if you have a high jitter, that can cause quite some issues. So one option you have is, for example, on the RPCs. Over here, note how this has a field for delivery, which is of type RPC delivery. And this one you have two options, you have reliable and unreliable. By default, it's reliable, which means the packet will always arrive there. Or you can also make them unreliable, which means they might not arrive in the same order as they are sent, or they might not arrive at all, which in turn can help reduce problems with jitter. Depending on what you're doing, what type of data you're synchronizing, you might or might not need ordering. And of course, remember, making it unreliable means the packet might never arrive at all. Again, whether that is a problem or not depends on the use case. If you're sending an RPC just to trigger a minor visual effect, then you probably don't care if the RPC ends up lost. So related to that, the last option is the packet drop rate, meaning a certain percentage of packets will just be lost. If you're using reliable RPCs, then that means the packet will be repeatedly sent until the receiver finally gets the packet, which in turn, obviously that will slow down all of the other queued packets. So drop rate can definitely cause some very strange behavior. Basically, it's very useful to use this debug simulator to test your game with a bunch of settings. For the numbers you define here, they're going to depend on your game, and basically you should test your game in the worst case scenario and make sure everything still works. Now, before we use this to test, let's actually check one other helpful tool. Let's go and open up the package manager, and over here let's look for the Multiplayer Tools package. So here it is, this package, let's install it. This one adds a bunch more tools. For example, one tool this adds is the Runtime Network Stats Monitor. For that, let's go into the game scene, and over here let's create an empty game object, call it the Runtime Net Stats Monitor. Let's go ahead, reset transform, just keep things clean, and now let's add the script Runtime Net Stats Monitor. And here we got a bunch of settings, you can leave them on the defaults. For the position, let's just put it on the right side just for our game. Okay, so that's great. Now let's set up our test. So let's go back into Lobby in order to look at the network manager, okay. So down here for the values, one thing is keep in mind that these values are added on top of whatever connection you have. Right now we are currently already using relay, which adds a little bit of delay. So up here for this delay, let's go with 50 milliseconds extra. Then for packet jitter, let's also go with 50 milliseconds. And for the drop rate, let's say 10%. So this will essentially simulate a pretty bad connection. Also very important is, just like it says here on this tooltip, this only gets applied on development builds. So when making a build for testing, let's go up here into File, Build Settings. And over here we have a toggle for development build. So if this one is untoggled, that will not run. So let's make sure to toggle this, and let's make a build. Okay, so here we have the build. And over here, let's try to create a lobby. So let's create a public lobby. And right away, you can see that it takes actually quite a bit longer. So that's the delay in action. Now down here, let's click on play. And let's go ahead and quick join. And once again, it's going to take a little bit longer. So the connection, there you go, takes quite a little bit. Let's go ahead, set on ready, and this one on ready, just like this. Okay, so here we are, and right away we see a bunch of things. So over there we see the Runtime Network Stats Monitor. So let's actually interact in order to start. Yep, there you go, we can see that. So first of all, over there, the RTT, this one is the round trip time. So the time to get to the server and back. And this one is the server, so this one has 0, but this one down here, note how it has 200 milliseconds. And if I move around in order to make it update, you can also see it going up and down. So that's the jitter in action. So it goes all the way up to 250, then down to 220 and so on. So that's because we added 50 in jitter. Okay, great. And right away with this, if we look over there on the host, we can see quite a big difference in delay. Look at that, everything is quite a bit laggy. Perhaps this is a little bit too much, but still, let's just make sure the game works like this. And over there, we can also see a bunch of stats. So you can see the number of RPC packets, number of bytes, both send and receive. So all of this can be useful for monitoring how much bandwidth your game is using. Now, so related to that is the profiler. So over here on the Unity editor, let's go into Analysis Profiler. And down here, if we scroll down, we can see a bunch of elements. Yep, over here for the NGO messages. And if we click on one of these and we drag it around, we can see over here we have client 1. And client 1 is sending a network variable delta and a time sync with a bunch of bytes. And if we scroll around, we can see if we try to interact with something. Yep, now we can see a client RPC message, create object message. We can see a whole bunch of interesting things. So basically over here, we can see how much data is actually being sent, either through a network variable or an RPC, and who exactly is firing that. So again, lots of data to analyze how you might optimize your game. Remember, bandwidth is a huge thing when it comes to multiplayer games. So now that we have a lag connection, we can test our game, and we actually do have a bunch of bugs. So down here, if I'm on the laggy client, if I go ahead and pick up some cheese, then I go into the cutting counter, I place it there, and now I'm going to try to slice as quickly as possible, so I'm going to spam the slice button, so just spam. And there you go, we've got an error on the server. So here it is, a null reference exception, so let's see what this is doing. And yep, here is the error, and actually the error is because the cutting recipe is null, so over here we have a null reference exception. And the reason why this one is null is because we are trying to cut something, but the kitchen object is actually going to be the cut object. Since the cut object doesn't actually then have a cutting recipe for something else, it's going to return null. Basically, the problem that we have here is that the client is trying to cut the object way too many times. That is because the cutting validation actually happens up here on the interact alternate. So this is where we decide whether we can slice or not. We are running this validation only on the client. So if the client has delay, then this will end up trying to slice way too many times, causing an error. So here, even though we are okay with having a client authoritative model, we still need to validate the actions of the client. In this case, it's actually a simple solution. We just run these checks over here on the server RPC. So let's just check if we have a recipe and if it can be cut, then we are going to broadcast the cut object message. And same thing down here on the progress done server RPC. Over here, let's also copy the same thing, so run this validation to make sure the player can actually cut this. Okay, with this simple change, let's test. Okay, so here we are, let's pick up some cheese. And now let's try spamming the cut like crazy. And if there you go, even with cutting a ton of times with a bunch of lag, now it still works as intended. Now for the next possible issue is on the trash. So if I pick up something and then I go and trash it, and once again I spam the interact key, and if there you go, we have another error. If we look, the error is here, and once again we have the same problem. The validation is client side, so we're going to get tons of server RPCs in order to destroy that object, and only the first one will work. So the first one destroys the object, and every subsequent one is going to have null in here. So once again, simple solution, let's just check if the object is already destroyed. If so, then do nothing. So over here, if the kitchen object, network object, if this one is already null, then this object is already destroyed. So if so, let's just return. Okay, super simple, let's test. So let's pick up an object, go in there and trash it. Let's spam, and if there you go, no error. Okay, great. Now for another one, it's actually on the pickup. So let's go up here, and to pick it up, once again, I'm going to spam. And there you go, we have an error. This one says the kitchen object parent already has a kitchen object. Basically, the issue is actually here on the container counter. So when we interact, we are going to spawn a kitchen object. And on this function to spawn it, we are going to use a server RPC. And again, if the client takes way too long to receive the message that the server has been spawned, if so, then they're basically going to call this function a ton of times. So the server will try to spawn one object and give it to the player, then spawn another object and try to give it to the player, which obviously cannot happen. So once again, we can validate this on the server RPC. We can just grab the kitchen object parent and compare it. So let's grab this one first. So we grab the kitchen object parent, and then just check if the parent already has something. So if the kitchen object parent has a kitchen object, then parent already spawned an object. If so, let's return and not do anything. Okay, once again, let's test. Okay, so let's go and spam to pick it up, and if there you go, it only picks up one. Okay, great. So with that, I think there are no more errors due to lag. So we can spam, pick up, and drop, and that works great. We can go there, we can slice it like crazy, and yep, everything works great. Although again, everything that I did here was very specific to this game, so you can see how there are no universal solutions. Depending on what problem you have and what your game is like, you will have a different solution. Finally, there's one more very important thing over here on the network manager. Here we have a field for the protocol version. This is how you can make versions incompatible with one another. Usually you really don't want to have different players with different builds playing with each other. That's probably going to cause a ton of problems. So your players should always update their game, and the code should only allow players with the same build to play together. So for example, let's say we fixed all of those issues, but someone out there had the old version and they didn't update. So that build was made with the protocol version of 0, and now if I change from 0 to 1, and now I test here, so up here the editor has protocol version of 1, and down here the build has protocol version of 0. And now if I go into test, over here if I create a lobby, now this one actually does see the lobby because we didn't add any sort of versioning on the lobby, although we could easily add that in the lobby data and only show lobbies on the same version. But even without that, just like this, we are guaranteed to have no connection. If I try to join this one, joining lobby, connecting, and there you go, failed to connect because we have different protocol versions. So with this, only the same version can connect. Alright, so those are a bunch of tools for how you can test your game. As you can see, the solution is heavily dependent on a case-by-case basis, so instead of memorizing these specific solutions, just learn how to use these tools to solve any problem. Okay, so with that, our multiplayer game is pretty robust. Finally, since our game is pretty much done, let's go over here onto the kitchen game lobby. And down here we have our testing code for initializing, how we set the profile. We did this just so we could have multiple builds at once, but we don't really need this in the final published game. So we can just comment out this line to set a different profile every time. And one last thing in my case, I'm going to go over here onto the game scene and I'm going to remove the quantum console. Finally, for testing, let's also disable the runtime net stats monitor. And let's go into the build settings and make sure that our builds are not development builds. Okay, great, so everything's set up correctly. Now let's go into the next lecture to add an interesting option. Let's add the option to play the game entirely in single player. Hello and welcome, I'm your Code Monkey. In this lecture we're going to add an option to play the game fully in single player. Okay, so when you make a multiplayer game, if it is possible with the design, you should include an offline single player mode. Here in this game, all of the player units work the same, so the design doesn't really require multiplayer, so let's add that as an option. And thankfully, that's actually super simple. Let's begin by going into the main menu scene, and over here all we really need is just another button. So let's take the play button, let's name this play single player button, and let's duplicate this and make the play multiplayer button. Okay, and let's just position them, put that one there, that one up there, and let's also make the text. So for this one, multiplayer, let's scale it down a little bit, and same thing on this one, let's put it single player, and also scale it down. Okay, great, 2 buttons. Now let's open up the main menu UI script, and over here let's add both button references, so let's rename this one to the play multiplayer button, another one for the play single player button. Then here in the editor, let's drag the references, so the single player and the multiplayer, okay. And now, very simply, in order to play multiplayer, we do go into the lobby scene, so pretty much the same as normal. And then on this one, we really just need to go straight into the game scene and call the start host. Now, the one tricky thing is we don't have the kitchen game multiplayer, we don't have this over here on this scene, we only have it on the lobby scene. So we could rework how our game is organized in order to place those objects over here on the main menu, or let's just add some basic automated logic on the lobby scene. So let's go here on the kitchen game multiplayer. And for this one, let's make a static boolean we can set. So public static bool, let's call it play multiplayer. So we have this static boolean, it's public so we can access it from anywhere. So over here on the main menu, let's go into the kitchen game multiplayer, and we set play multiplayer, in this case to true, and in this one we set it to false. Then we both go into the lobby scene. And now over here on this one, let's go and make a private void start. And on start, let's check if play multiplayer. If so, then we're actually not going to do anything. So let's actually say not playing multiplayer, so playing in single player. If so, then let's start playing right away. So let's call start host, and then loader, and let's load, and load the usual game scene. Okay, so honestly, that's really it. Let's test. So here we are, and press on single player, and it goes into the lobby, and immediately goes in there. And now if I hit play, and if there you go, everything is indeed working perfectly. So I'm playing around, I can pick up, I can slice objects, I can cook them, everything works perfectly. Alright, awesome. Now I can even shut down my internet to verify, so I am not connected. And over here, let's go into single player, goes into the lobby, and goes, and everything works perfect. Alright, awesome. Now one thing, this actually does throw an error on the lobby. That's because it cannot access an external location, that's obvious. But this is not the problem because it's just throwing an error and the game keeps playing as normal. So with this, the entire game works perfectly fine, everything works great, all the logic is running, but only locally. So even though the network manager is indeed running, it is only running locally in offline single player. So thankfully for this type of game, it is really simple to add single player, so if possible, definitely make sure to add it to your games. With that done, there's only one final thing we need to do, and that is make sure that our game is playable with a gamepad, so let's test that out in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to go through our game and make sure everything is playable with the gamepad. Okay, so when we made the single player game, we already made it fully playable with the gamepad, but now in order to add some multiplayer features, we also added a bunch of extra menus, so let's go through the game and make sure everything is still playable with the gamepad. Now over here on the main menu scene, everything already works, so I can go up and down and select all the buttons. Just one minor thing, which is by default the single player button is the one highlighted. Let's make the multiplayer one the one default. So very simple, just go over here onto the event system, and instead of selecting the play single player button, let's just drag that one. Okay, very simple change. Now from here, let's click and go into the lobby scene. And first of all, we don't see what exactly is selected, so let's do the same thing and change the color for all the buttons. So over here on the lobby scene, let's select all of those, like the main menu button. And we basically just go over here on the select color and put it on a green, so something like this. So let's make sure to apply this to all the buttons. So there's create lobby, quick join, join code button. Let's put all of these with a select color on nice green. And same thing for the input fields, also put them as selected. And finally on the lobby list, for the template, let's also put it on selected. Then beyond that, we've got the lobby message UI. So let's put that one, also put it on selected. And for the lobby create UI, For all these buttons, same thing. Select all the buttons, paste is selected, select the input field, and same thing. Okay, so then the other thing is on the character select scene, so let's go there now. And over here, do the exact same thing, so select all the buttons and set the selected color. And then down here for the buttons for changing the color. For this one is a prefab, so let's go inside the prefab and modify the entire prefab. Okay, so that's great. Just one more thing, which is on the event system. For this one, we need to replace it because by default it comes with this input model. We want the other one, so let's default it. So change it on this one and also on the lobby scene. Let's also go onto the event system, also replace it like this. Also for testing here, let's just default the play multiplayer to true. And let's make sure to select the default button. So let's go in the lobby UI and let's say the create lobby button, put this one as the first selected. Then on the character select scene, let's also assign one. So one of these colors down here, select them as selected. Okay, let's test. So here we are on the create lobby, move down to quick join. Okay, great. And now if I move down, it goes into the code input box. And now if I move down and nope, now I'm somewhat stuck here. So I'm not sure if the automatic navigation is meant to intentionally become stuck on an input field. I don't know if that's intentional, but that's what happens. But either way, on a gamepad, we can't right now input any text. So a simple solution is just make sure that the gamepad buttons do not go through those input fields. So over here, select the input fields, and on the navigation, instead of automatic, let's just go with none for both this one and the player name input field, just like this. So now if we move, and yep, there you go, now we can move through all the buttons. Now obviously in the final multiplayer game, you would make some kind of on-screen keyboard. For that, you would either interact with some kind of platform API, like the Xbox API or the PlayStation API or something like that, or you'd get some kind of on-screen keyboard, possibly something from the App Store. But either way, right now at least the game is playable, so we can create lobbies and we can quick join. We just need to also, over here on the create lobby, let's also disable the navigation on this one. And when we show this window, we need to show one of these buttons. So the same thing that we did previously, when we have the show, let's go, let's say the create public button, let's go and call select. Okay, so here I am and I'm going to create a lobby. And yep, let's go and make it a public lobby. So it's creating, and yep, here it is, and down there the buttons are actually selected, so I can change the color into this or this, something like that. And when I'm ready, I can go into the ready, and yep, there you go, now here I'm playing, and everything plays perfectly. Alright, awesome. So the game is now fully playable with a nice gamepad. And with that, we have our final game completed. So let's go into the next lecture and see everything that we've built. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to look at all the work we've done and have some fun playing the final multiplayer game. Okay, so we start off on the usual main menu, except right now we have an option to play in multiplayer or single player. So if we just go into single player and the game starts playing right away in single player, so we can play this offline just by ourselves and everything works perfectly. So I can move, cut, deliver recipes and so on, perfect. Then from here we can go back into the main menu. And back in here, now let's do the proper thing, let's play multiplayer. And as soon as we do, we go into a nice lobby scene. So here, if there were more players playing the game, we could see a list of all the lobbies. Up top, we can see and customize our player name. We can go ahead and create a lobby, give it a lobby name, so my awesome game lobby. And let's go ahead, create a public lobby. And if there you go, it creates, and here I am inside my character select scene. Now I've got some other clients down here, so I can go ahead and I can join the lobby with all of them. So I can either join by joining the lobby directly, or use quick join and it will automatically join. And if this were a private lobby, I could use the lobby code to join by code. And if there you go, all clients are now connected. And for character customization, now we can choose from a whole bunch of different colors. And there's some logic to prevent players from using the exact same color. Then once everyone selects their color, they can mark as ready, and the game will only start when they're all ready. Also over here on the host can kick any client. So let's go ahead, set them all as ready, and once they are all ready, the host is going to load, and yep, all of them are going to load with it. Then we have our controls, and we can press interact to continue, and it waits for all the other players, so in multiplayer, all of them must be ready, and there you go, we get a nice counter. So it counts down the time, and if there you go, the game starts playing. As I'm moving, it's perfectly synchronized on all the others, so I can move on any client anywhere, and yep, everything is synchronized. Then I can pick up objects. Once again, the animation is synchronized, the object is synchronized, all of that works perfectly. I can place the object, I can slice it, I can pick it up, do a bunch of things. Then on this one, I can go ahead, pick up some meat, cook it, then move away. Then on this one, I can pick up a plate in order to grab the meat, and everything is working perfectly. So the stove works perfectly, the container counter works perfectly, the ingredients, all of them work perfectly. So I can pick up, do everything, and deliver, and yep, all of them see a delivery success. Then the game state itself, so the countdown timer, all of that was working perfectly. Over there, the game timer, that one is also being perfectly synchronized. So we're handling all kinds of things. We even have some object deletions. Over there we destroy, and yep, the object is destroyed on the network. And when we pick up, it gets spawned on the network, so lots of things. And finally, as the timer elapses, yep, all the clients go into a nice game over state. Alright, awesome! So here we have a fully working, perfectly synchronized multiplayer game. Now if you've made it this far, then congratulations! Let's go to the next lecture where I'll give you my closing thoughts. Hello and welcome, I'm your Code Monkey, and congratulations, you have completed this multiplayer course. Alright, awesome! That is seriously a great achievement. Very few people actually complete courses, and if you're at the end of this course, then that probably means you also got to the end of the single player course, so really, double congratulations to you. I genuinely hope this course has helped you on your own game dev journey. I hope you now feel capable to build whatever multiplayer game ideas you have. Throughout this course, you'll learn about how to set up Netcode for game objects to create a multiplayer connection. You'll learn how to use RPCs and NetworkVariables to synchronize all kinds of data. You'll learn the pros and cons about Server Authoritative versus Client Authoritative. You'll learn what logic should be on the server and what can be on the client. You also learn how to make a nice character selection scene to customize your players and how to handle the scene connection flow. You'll learn how to use Unity Lobby and Relay. And most important thing of all, you'll learn how to do all of this while writing some good, clean code. So I really hope you enjoyed learning about all of that. Let me know in the comments what was the most important thing you learned throughout this course. I hope this was very fun and very educational. If you enjoyed my teaching style, then maybe check out my other courses. If you haven't yet seen my turn-based strategy course, I really think that one would be excellent for you right now. It dives even deeper into some more advanced topics, and since you've watched this entire course and the Singleplayer course, you now have all the knowledge needed to follow that course. It will help you really solidify all the knowledge you gained, especially everything related to writing some good, high-quality, clean code. And since you use Unity, check out my Ultimate Unity Overview course. It covers lots of the tools and features of the engine, so you can really use all of the tools at your disposal to make any game you can think of. Or alternatively, if you like visual scripting, I also have a course on that, or learn how to make a really nice Builder Defender game. And definitely make sure you wishlist my upcoming Steam game, Total War Liberation. I will be posting some devlogs, and in those, you will also see how the code that I use in my own Steam games is on the same level of quality as what you learned in these two courses. Okay, so that's it for me. Both of these courses have been a ton of work, so I genuinely hope they helped you a ton on your game dev journey. Now go ahead, take what you learned here, and build an original game. Thank you so much for watching, and I'll see you next time.